Welcome to DevTero's Ultimate Spring Boot REST API course. In this over 6-hour-long course, I'm going to teach you how to build a REST API in Spring Boot completely from scratch. And don't worry if you're a complete beginner, because I'm going to teach you all the theory you need to know and be with you every single step of the way. In this course, we'll build a REST API to use a real PostgreSQL database. Once we're done, we'll package up our application in a Docker container and deploy it to the cloud to AWS. If you feel like you've taken some value away from the course and you want to help us make more courses just like this, then be sure to like and subscribe. So before we start, be sure to check out the description below for the full list of everything covered in the course, and there's also the link to the source code that you can download for free and follow along with all the exercises in the modules. So let's get into it with our first module. One of the best ways of learning is by doing. So in this video, we're going to build your first Spring Boot application. For this, you're going to need a few things. You're going to need Java 17 or later installed on your machine, and you are going to need an IDE. Now we're going to be using IntelliJ IDEA, the community version, the free version that you can download from the JetBrains website. Of course, there is a paid for version as well, but you don't need to purchase an IDE for this course. You can use the free version. This is where our Spring Boot journey starts, and it's at the Spring Initializer. Now this is a website that you can get to by hitting start.spring.io in your browser, and you're greeted with a page that looks a little bit like this. Now the goal of the Spring Initializer is to allow you to configure and then download a skeleton Spring Boot project. And we're going to go through it together now to download our first Spring Boot project that we're going to run, our Quickstart application. So let's start at the top left here. Now we've got a project heading and we've got some options like Gradle Groovy, Gradle Kotlin, and Maven. Now Gradle is a build and dependency management tool. Groovy and Kotlin are different programming languages. We're going to be using Java exclusively in this course, so we're not interested in selecting Groovy or Kotlin. We're going to use Maven. Now under language, we're going to be using Java, but of course you can select Kotlin or Groovy if you would like. Now we're going to go to the Spring Boot heading here, and we're going to select 3.1.1, which at the time of recording is the general release version of Spring Boot. Of course, you can select an earlier general release version of Spring Boot if you like, or you do have the option to use a snapshot version. Now, the snapshot version is like the latest dev build. It may have the latest features, the latest fixes on it, but it may not be the most stable. So we're going to stick to the latest general release version here of 3.1.1. Now we get to give our project some metadata. So this just allows us to identify our particular project. So for the group, I use the group comdevtero. You may use a different one. And for our artifact, we're going to call this one Quickstart because it's our Quickstart application. For a description, not strictly needed, but we're going to say our first Spring Boot app. And for the package name, com.devtero.quickstart seems absolutely fine by me. Now we get to the packaging, and we have jar selected already, but we could select a war if we would like. Now the differences between jar and a war isn't for now, we'll cover that later, but we're going to select jar for the moment, because if we get a jar file, then we can run our project nice and simple. That's exactly what we want. So with jar selected, we now select our Java version, and we're going to select Java 17. Now in terms of the dependencies here, we're going to do a very simple Hello World REST API for our first project. So we just need a single dependency, and that is Spring Web. And just like that, we are fully configured. So if we click on Generate, we get to download our skeleton project, and then we can open that up in our IDE. So let's download this and head over to the IDE. So here we are with the project opened up in our IDE. So let's take a quick look through and let's implement our first Quickstart application, our Hello World Spring Boot application. So I'm going to expand this and let's just take a little look around. So we've got source main Java and we have a single class in here, which is Quickstart application. And we've got source test Java and we have a Quickstart application tests. So taking a look at Quickstart application, we can see that we've got bits of information here. At Spring Boot application annotation, this must be a Spring Boot application, and we can see we've got a main method as well. Now if we take a look at the tests, we can see at Spring Boot test, and we can see a single test in here, which is testing that the context loads. It's not doing a lot else. Now more on what that means a little bit later, but the Spring Initializer is basically giving us the bare bones of an application and a test here. So what we're going to do to implement our Quickstart application, we're going to create a class in source main Java, and then inside of our group comdevtero quickstart or whatever group that you're using. and we're going to call it the Hello World controller. There we go. Now a controller needs an annotation, and we're going to give this one a REST controller annotation. More on what that means a little later on. Now we're going to create a single endpoint for this controller, and that's going to return the string hello world. Now we're going to do that via a method returning a string, and we're going to call this one hello world like this. And as you can imagine, the implementation is simply returning a string of hello world. There we go. But that's not enough to tell Spring that this is an endpoint on our controller. We need to add another annotation here. So we're going to do git mapping. And inside of git mapping, we're going to type in path, and we're going to say that the path is hello. Because when we hit /hello, it's going to give us hello world in our browser. So that is the bare bones of our hello world application. So what we're going to do to run this, and there are several ways of running this, but we're going to do the simple way of going over to the Quickstart application here. And because IntelliJ is fantastic, we can click on this little play button and then click on run. And it's going to run our application for us. There we go. And we can see that we are running on port 8080 here. We'll cover what Tomcat is and all of that good stuff later on. We know that we're running on port 8080. Let's hit this in our browser. So here we are in our browser. All we have to do now is we'll go to HTTP, localhost, 8080, and our endpoint was /hello. And we're expecting to see the string hello world. And just like that, we have hello world. So if we were, in fact, let's zoom in a little bit. So if hello world returned on this endpoint. To show you that this is doing what it should do, let's change the string here. And we're going to go to our controller, change from hello world to maybe be hello dev0. Restarting our application. Very good. Refresh this page. And we have hello dev0. And just like that, you've implemented your first Spring Boot application. So as you can see, we didn't have to do a lot to build our first Spring Boot application, but we did skim over a lot of details. So let's just cover a few things now, just to set the scene. And of course, we're going to cover these in more detail as the course progresses. So let's go over to our code here. So here we are back at our code, and we can see we've got a few things on the go here. Here's our Hello World controller class that we implemented with our Hello World endpoint. Now this class is all to do with Spring Web. So the Spring Web dependency that we brought in earlier has allowed us to do this, essentially allowed us to build a REST API with next to no code. And it has a single endpoint that's very simple at the moment, but this can have as many endpoints as you like and be as complicated as you like as well, returning anything from a string to complex objects in JSON format or other formats if you so choose. So that's all to do with Spring Web, and more on Spring Web later in the course. Now for other things in the class here, we did quickly cover this Quickstart application class. Now this is the entry point to our application. We can tell that because it has our main method here, which simply runs a Spring application, in this case, the Quickstart application here. And we also have this @Spring Boot application annotation on top. Now this annotation does so much, and we'll break it down later on. This is actually an alias for several different annotations, but for the moment you can think of it as just identifying a Spring Boot application, an entry point to our Spring Boot application that we can then run. So that's our Quickstart application here. Now, if we go into resources, we can see that we've got some empty directories here, and more on those later, but we also have this application.properties file. And if we were to configure our application in any way, we would put our configuration in this file or file very similar to it. For example, we could have application.yaml if we prefer to use the YAML format, and Spring Boot would be absolutely fine on that. But again, more on configuration a little bit later. Now, if we go to our test directory, we've got our Quickstart application test that we took a look at earlier, but of course we didn't look to run this or anything. Now, if we were to run our Quickstart application tests, bearing in mind it has the @Spring Boot test annotation on top, what do you think will happen? Well, let's run this now and see. You've seen a Spring application start up. If you look at the logs for this test, you might see something fairly familiar. This is actually starting up a test version of our Spring Boot application. And the context loads is a dependency injection concept that Spring uses. More on dependency injection a little bit later on, but it's basically making sure that the app starts up, which of course is exactly what you want it to do in production or any environment for that matter. So that's all that test does. Of course, you can add as many tests as you like here to test against a running Spring Boot application, or if you don't need a running Spring Boot application, and there are some benefits to not having one in your tests, you can add those in different classes in this directory. And then we've got our POM file down here, which is used by Maven. Now we're going to cover Maven in detail in a little bit, but you can see, of course, we've got our Spring Boot starter web dependency here. We'll cover what a Spring Boot starter is as well. And we've got the Spring Boot starter test dependency in here as well, which allows us to have some testing functionality for a Spring Boot application. Now, you may have not noticed it, but IntelliJ integrates super tightly with Maven, and it's actually doing a lot of work behind the scenes. If you take a look at this little tab here, you can see some more information on Maven. So for the rest of our Spring Boot journey, Apache Maven is going to be our best friend. So we're going to need to know a little bit more about it in order to fully utilize it to learn Spring Boot. So let's cover Apache Maven. So you're here to learn Spring Boot, right? But just like how you can't become an Olympic sprinter without first learning how to tie your shoes, you're going to need to know your build tool. So in this module, we're going to cover the need to know of Apache Maven. And let's start with the biggie, which is what is Apache Maven? So one of the best descriptions I've come across is this. Apache Maven helps programmers manage their projects and all the things they need to build their programs. And Maven knows how to find all of these dependencies and go and fetch them. And once it's done that, they can be bundled right into the project. Now, this might sound really simple when you consider the dependencies your project needs. But then you have to consider the dependencies of the dependencies that your project needs. The first order, second order, third order dependencies. And Maven does a fantastic job of managing these transitive dependencies all for you. But it doesn't just stop at dependency management. Maven builds and tests our projects as well. And once we know our project is working exactly how we want it to, Maven allows us to build it, package it up, and then share it as a dependency to be used by others, but only if we want them to. So to run Maven from the command line in a Spring Boot project, it's actually very straightforward. So here's an example. I'm going to run mvnw, which is a script which exists in the root of our Spring Boot application project here. And I'm going to type clean, and I'm going to type compile. You can see here we have a build success, but it might not necessarily be clear what clean and compile might mean. So let's cover that now. As should be no surprise by now, Apache Maven is a command line tool. Now you can choose to use it exclusively via your IDE if you want to do it that way, but it feels like a bit of a cop-out to do that. So I'm going to show you how to use it via the command line, and then it's up to you whether or not you do it via the command line or via your IDE. For the rest of this, we're going to be using the Maven wrapper, so mvnw, and the reason for that is so there's no obligation for you to install Maven on your machine. Of course, if you want to go ahead and install it, you go for it, but we're going to be using the wrapper for the remainder of this. So as the highest level concept, we're going to cover phases. Now, Maven has 3 phases that it uses. It has the clean phase, the default phase, and the site phase. Now, you can think of a phase as a life cycle. A phase can contain one or more goals. So a goal is something specific that you're looking to achieve, whereas the life cycle is the order of those goals, or the order of the things that you're looking to achieve. Now, of the 3 phases, they each have their own purpose. Now, clean, that's used to remove temporary directories and files, at least with the goals that it contains. Default, this is where the most useful stuff lives. This is where you do your building and your testing and all that good stuff. Cover it in more detail in a bit. And then the site phase, and that's where all of the documentation is generated. So reports and Java doc, all that good stuff is done in site. So let's cover the clean phase because it's something a little bit special. So clean, we know, is there to clear out directories and files. And there is one goal in the clean phase that does all the work, and that is the clean goal. There is a pre-clean and a post-clean goal inside of the clean phase, but they're just there as hooks because sometimes you'll build a plugin for Maven and you'll want to hook into the time before the clean or the time after the clean. So clean cleans out directories and files, Let's see how that's done. So here we are back at our Quickstart application, and we can see we have a target directory here. Now, the target directory is the directory that Maven uses where it puts all of the stuff that it's processed. That might be its built classes, it might be its reports, it might be the built artifacts like the jar or war file. So this project has actually been built. So if we take a look inside of the target directory here, we have all sorts of files. We have a jar file here, which is our Quickstart application. We've got some things in Maven Status and Maven Archiver, some classes in here if we were to expand this. So you can see there's a lot of stuff in this target directory. And it might be the case we want to clear it out, we want to get rid of it. And we can do that very simply. We're simply going to run the Maven wrapper here, and we're going to type clean. That's a build success, and you can see our target directory has been cleaned, it's disappeared, it's no longer there. Now for the exciting bit, let's cover the default phase. So this list of goals is not exhaustive by any stretch of the imagination, but these are some of the biggies that you'll see used throughout the course. So the compile goal here will compile your Java code into bytecode. We have the test goal here, which runs our unit tests. We have the package goal here, which creates a jar or a war file. And we have the verify goal, which runs checks and integration tests. Now, something important that's worth pointing out here is the order, okay? So the Maven default phase is a life cycle, right? And it happens in this order. Compile will happen before test. Test will happen before package, and package will happen before verify. So if you wanted to run all of the things right up to verify, you would run verify. And of course, it would compile, test, and package your code. If you just wanted to run everything up to test, you would run Maven test, and it would run compile, and then it would run your tests. So to kind of give an example of how that works, let's flip back over to our code. So here we are, we've just cleaned the project. We're going to now compile it. So we're going to run the Maven wrapper here, and I'm going to type compile. You can see it's a build success. It's recompiled our classes here, and if we go to our target directory, which is now back, we can see we've got our compiled classes. Looking very good indeed. Now, if we were to run Maven clean once more, of course, getting rid of that target directory and all of those files in there, let's run Maven test, remembering that the test goal is after the compile goal in the default phase lifecycle. There's the test running. Build success. One test has run, looking very good. Now, if we were to go up here a little bit, we can see that the compiler has run default compile. And that proves that our classes have been compiled. That compile goal has run before the test goal. So here's something I want to point out before we move on. If you take a look at the target directory here, there is no jar file, okay? We haven't got a jar file in this target directory. So we go down here and we're going to run Maven clean. It's going to remove our target directory and all those files. That disappears. And now we're going to run the Maven wrapper, and now we're going to run Maven package. There's the compiler. There's the tests. Okay, and we have, if we look in the target directory now, the jar file. So that's our package jar file. There's our artifact. So everything's looking good so far. Now we'll just cap things off by doing Maven clean. And we'll now run Maven verify. Now we don't have any integration test configured. To do that, we would need to use a Maven plugin. More on that in a little bit. But by using Maven verify, because it's at the end of the life cycle, it generally runs everything. So that's what you'll see me run periodically throughout this course. There we go, and we just check in the target directory. We can see there is our jar file once more. That is how you interact with Apache Maven via the command line, but how do you actually use it in an actual Spring Boot project? Let's look at that now. So So to use Maven is to use the Maven directory structure. So this isn't so much a Spring Boot thing as it is an Apache Maven thing. So if we go to the Apache Maven website here, we can see an example of the directory structure that Maven requires. Source main Java, source main resources, so on and so forth. And you can see the description as to what these different directories do. So let's see how that works in a Spring Boot application. So let's go back to our quick start. So here we are. Let's expand our directory structure here. Okay, so best place to start is this source main Java. That then contains our Java code. So we can see within source main Java, we have that com.devtiro.quickstart, so our group, the package that we're using. And inside of there, we have the Hello World controller and then the Quickstart application class as well. Now, we also have here our source main resources, and that's where we find this application.properties, our configuration file. Now, if we did have any static files that we wanted to use, any other files that we wanted to load in, we would put those in source main resources. And that pretty much covers it for our source main directory. So if we minimize that, we have our source test directory. So just like we have source main Java, we also have a source test Java. So source test Java contains the same group. So we can see here the same package that we're using in our source main Java directory, but this one contains tests. So you'll usually see a reflection of the directory structure used in our production code, so source main Java, inside of our source test Java directory. So you'll usually have a class in source main Java, and then the equivalent test class for it in source test Java in exactly the same package. What's also interesting is you don't have it in this project, but you can also have a source test resources directory. So if we create one here, you can see it has a different icon, so it's already been picked up by IntelliJ. And inside of source test resources, you can have static files and configuration files that are only used in your tests, not in your production code. So Spring Boot actually allows you to override configuration inside of your test by placing configuration files inside of source test resources. We'll cover that in much more detail later on. It's just worth knowing that you'll find those in source test resources and also any static files that you're using for your tests as well. And of course, we've come across it before, but our built project and any files that are processed by Maven are placed into this target directory. So we can see here our quick start jar, and of course you have our compiled classes as well. So it's worth bearing in mind, this directory structure is enforced by Maven. It's required when you use Maven, but you can build Spring Boot applications with it. And actually, by convention, Spring Boot allows you to do some really nice stuff by using this directory structure, such as overriding the configuration files in your tests by placing something in source test resources as opposed to source main resources. But again, much more on configuration later on. And there we go. Those are the main ones that you need to know for a Spring Boot project. There are some other directories that are used in just general Maven projects of different types, but we're not going to need to know about them today. So how would you use Maven typically in a project? What would be your workflow? Well, let's cover that now. So what would a typical workflow look like when using Apache Maven? There's a few things to point out here. I'm going to show you my workflow. This works for me. It might not necessarily work for you, but it might be a good place to start. I like to use Maven from the command line rather than using it via the IDE. This might be out of habit, but I find it a lot more flexible. I also do not follow test-driven development as a general rule. If you do, your workflow will be different. It's not to say that I have a problem with test-driven development, it's just typically not the way that I do things. So this is what my workflow looks like. In terms of the project, I'll go ahead and I'll identify what needs doing, look at the requirements, and then I'll start writing code. Now, as I'm writing, I may want to get some super fast feedback on what I'm writing. Is there something a little bit weird here? Have I done a compilation error? Now, the IDE usually does a really good job of highlighting these for you, but occasionally I will write Maven compile into my terminal and get some fast feedback from the compiler there. So once I've written the feature, then I'll get to testing. And typically I will run Maven clean and test quite a bit just to get some fast feedback when I'm writing tests. Again, this can be done via the IDE, but I like to do this via the command line. Now you might be asking, why do I do clean? Well, to be honest, Compiling a project takes next to no time at all, and I don't really want any leftover files from a previous compile to influence the test as they are running. Again, the likelihood of them doing so is usually fairly slim, but I just like to use that anyway. You see here we've got a build success and one test has run. So once I've written the feature and I've written the test, I like to do one final test of the feature before I'll then commit that and push that up. And what I like to do is I like to build the artifact, in this case a jar file, and then run the jar file the same way that it might be run in production. Now, of course, you can run your application via the IDE, and you can even run your application via the Spring Boot Maven plugin, but I like to run it the way as if it was going to be run in production. And what I'll do to get hold of that is I usually go Maven, clean, for the same reasons as earlier, and then I'll type package or verify, depending on what I've got configured in my Maven project here. There we go, so that's everything built. Now, if we go into the target directory, we'll see that we have that jar file in there, and perhaps the simplest way of running that is java-jar, passing in the path to the jar file, and this should run our application. There we go, it's now running on port 8080, and we should be able to now hit this in our browser. There we go, application running. And right before I'm about to commit the code and push it on up, I'll run one last Maven, clean, and verify to make sure that everything is working nicely. Looking good, I'll typically then commit this and push it on up. So this is the workflow that I'll typically use on a Maven and, in this case, Spring Boot project. It's not completely perfect, but it's what works for me. And of course, I'll tweak it depending on the project that I am currently working on. Of course, take it under advisement. If this interests you and you can benefit from it, go for it. But if not, feel free to use your own workflow. So we want to run a project locally. We have loads of different options to do this. We can run it via the IDE. We can run it by building a jar file and then running that jar file with java-jar. Or there is another option, which is we can run our application, our Spring Boot application, via the command line, via Maven, via the Spring Boot Maven plugin. And it's very simple on how to do that. So we go down to our terminal here, and we're going to use the Maven wrapper, and we're going to type spring-boot, and then run. And this is going to run our application. Looking good, the application's up and running. Let's hit it in our browser. So there we go, we can see our application is up and running, but how do we stop it? So if we go back to our code, we'll go into our terminal and we're going to hit the buttons Control and C, and that's going to cancel the running. And if we go back to our browser again, refresh, you can see the application has stopped. The fact you're taking this course probably already means that you know Spring Boot is a framework for building Java applications. And you may know that a framework is a chunk of code that sits on top of the language's core library to solve common problems. And those common problems can be things like connecting to a database or exposing a REST API so different parts of a system can communicate. Now, if we really get down into the nitty-gritty, one such framework for doing this is the Spring Framework, which is different from Spring Boot. So Spring Framework is the thing that does a lot of the hard work for you. So connecting to databases and exposing REST APIs, all of that is done or can be done directly with Spring Framework. And Spring Boot is a layer that's actually on top of Spring Framework. Spring Boot is built on top of Spring Framework. And you might find that confusing, but of course, the purpose of a layer is to provide additional functionality to solve a specific problem. And the thing about Spring Framework used by itself is that it's highly configurable, which is great because you can configure just about anything in Spring Framework to be exactly how you want it to be. But the downside to this, of course, is that it takes a lot of effort. And that's your effort as a developer every single time you start a new project. So of course, you can use Spring Framework just by itself, configure everything yourself, and deploy an application to production. But if you choose to use Spring Boot, it's going to do a lot of that configuration for you by convention. And those conventions are very well documented, which of course is going to really speed along your application development. But by choosing to use Spring Boot, you do still have access to all of the flexibility of Spring Framework, but now it's just easier to use. And you might be asking, well, what makes it easier to use? And that is a great question, and we will answer it. But before we can fully understand it, we need to go over a few basic concepts of Spring Framework first. So we've talked about how Spring Boot is a layer that sits on top of Spring Framework. And you know what? If you zoom into your application, you'll find that layers exist there as well. So each of these layers has a specific purpose and is there to solve a specific problem. And if you think about your app in terms of these layers, then it's going to be easier to reason about, to write and maintain. And almost every single Spring Framework and Spring Boot application can be thought about in terms of these layers. So let's start at the bottom with the persistence layer. So the persistence layer is there to handle interactions with our database. And we'll often think of entities at this level, which are Java objects, which represent our domain and often map to tables in a database. Or if you're using a NoSQL technology, the equivalent in those technologies. We'll typically use entities at this level to interact with a database using one of a few different patterns. First, we have the repository pattern, and then we also have data access objects, which are commonly called DAOs. And the type of functionality that's exposed by our repositories and our DAOs would typically be described as CRUD, which is create, read, update, and delete, which are the basics of what you need to do. But of course, if you do need anything a little bit more elaborate, you can build those in to your repositories and your DAOs as well. So the goal of this layer really is to handle all of the different interactions with your persistence technology, like your database. And then you want to expose that via some really well-defined interfaces. And hypothetically, because of those interfaces, you could change your persistence technology, completely replace it, and the rest of the application just wouldn't have to worry about that because the interfaces wouldn't change. So now for the service layer. And the goal of this layer is to use all of the functionality exposed by the persistence layer and then use it to meet the requirements that our application is being built to handle. And it would typically do this through a set of interfaces and their implementing classes, which are typically referred to as services. The functionality in the service layer can be as complicated as it needs to be, or it can simply just be pass-through calls to the persistence layer. But that's still important because we don't want our presentation layer talking directly to our persistence layer. Calls must always go via the service layer. Which brings us nicely onto our presentation layer. And the goal of this layer is to take all of the data that's as a result of using the services in the service layer and then expose those to the user. And typically that can be done via a REST API, in which case you'd be using the concept of controllers as the implementation of that. Or it could be a GraphQL API, a WebSockets API, or any different type of API. Spring Framework, the ecosystem, there's a lot of tools in there to build pretty much any type of API that's needed. The wonderful thing about the presentation layer is that if we chose to present our data in a different way, let's say we are moving from a REST API to a GraphQL API, we wouldn't need to make any changes to the service layer. We would only make our changes in the presentation layer. So we would take exactly the same data, but we would just expose it in a slightly different way. This concept of layers is key. And another key concept is modularity. So let's now talk about the different dependencies used inside of a Spring Framework and Spring Boot application. So we know that Spring Framework solves common problems for us, and we know that Spring Boot makes Spring Framework easier to use. We also know that our application code is broken up into different layers, namely the persistence layer, the service layer, and the presentation layer. And we know that each of these different layers is there to solve a specific problem. So now let's talk about why we don't have to solve every single problem ourselves, and how we can leverage Spring's massive ecosystem of dependencies, or pre-canned solutions, and how Spring Boot makes them so much easier to use. So let's say you wanted to interact with a database by using Java objects, and you choose to use Spring Framework directly. Well, first of all, you would need to include all of the relevant dependencies into your POM file. You would then need to create several beans manually, including an entity manager to handle your entities, a transaction manager to handle your transactions, and a handful of other different beans as well. And that's before you even write a line of code to do the actual logic of your application. But if you're using Spring Boot, then you would simply include the dependencies, put some configuration inside of a properties file, which says how to connect to the database, and it would create all of the relevant beans for you. So you can get straight on to writing your actual logic of your application. And the way that Spring Boot creates these beans is by using sensible defaults. And this isn't just limited to the persistence layer, the same could be said for the presentation layer as well, or any other layer in fact. If you wanted to write a REST API, it's usually enough just to include the Spring Web dependencies, and away you go. Now with the general approach covered, let's talk about how Spring actually achieves this. Let's talk about dependency injection. To understand dependency injection, we need to get a little abstract for a moment. So let's say we were going to write a class, and what that class is being written to do and where it lives really isn't important, but let's represent that class with this green box. Now let's say our class depends on 3 other classes in order to achieve its goal, and we're going to represent those with these blue, yellow, and red boxes. Now one way of handling these dependencies is that we can create them inside of our green class by using the Java new keyword, perhaps in a constructor. And that's fine until we need to change these dependencies, swap them out perhaps. And what would we need to do? Well, we'd actually need to change the code inside of the green class, and we don't want to do that just to swap out and change a dependency. Luckily, there is a different way of handling this. Now let's say instead of creating those classes inside of our green class, we simply just declare the different interfaces that those classes meet. Now the wonderful thing here is that, well, something would need to provide the concrete classes that meets these implementations. And well, we can have something set around the outside to do that, such as a framework, possibly Spring Framework. And it would be up to the framework to create the concrete classes and then inject them where they're actually needed. So in this way of doing things, how would we swap out our dependencies? How would we change that concrete class to be a different concrete class that still meets that interface? Well, it's really, really simple. So let's put some labels on these for the moment. Now, let's say we wanted to swap out that alpha class, that blue box, with a different class which still meets the interface, but does it in a slightly different way. Well, inside of our framework, that gray box around the outside, we would simply get rid of that alpha class. We would create a new class that still meets that interface, and our framework would inject it where that interface is declared. And that again could be that green class, or it could be as many classes as needed inside of your application. So because the ownership of the dependencies is moved from this green class to something operating at a much higher level, this is termed an inversion of control. Now there are many different patterns which sit under the umbrella of inversion of control, and we needed something more specific to refer to this particular pattern. And that's where Martin Fowler came up with the term dependency injection. At its core, Spring Framework is a dependency injection framework. That's how we make use of all of those dependencies in the Spring ecosystem. That's how we use all of those pre-canned solutions. Now, if that doesn't make too much sense, don't worry, because we're going to get on to a worked example now, starting with some beans. So we know that coding to interfaces instead of concrete classes is the way to do things. And we also know that we should leave it up to the framework to supply the concrete classes wherever we declare our interfaces via dependency injection. Now, we're going to use the term beans to refer to those concrete classes now on, because that is the term that Spring Framework uses, and by extension, Spring Boot. Now I'm going to show you how to use beans by showing you an example Spring Boot application. Now, all this Spring Boot application does is print out 3 different colors, but it will show you how to use beans. So here we are in IntelliJ. Let me show you the colors application. Now, if we take a look at the entry point here, so our Spring Boot application annotated class, we can see that it implements command line runner, which of course makes this a Spring Boot command line application. Now, by implementing command line runner, I can now override this run method here. Now, all this run method does is it creates an instance of color printer. We can see it's using the Java new keyword there, and it's going to print out the colors given back by color printer.print method. And we can see the log.info is just simply going to print that out to the command line there. So let's take a look at the color printer interface to begin with. There's our single method. Very nice. Let's look at the implementation for the color printer, which we've got here, our color printer import. Now we can see that this has 3 dependencies, a red printer, a blue printer, and a green printer. And each of these classes also has a single method print, which if we take a look at red printer, you can see is right there. So we can see that we're doing the thing that we said we shouldn't do. Inside of the color printer import constructor here, we are creating a new red printer, which in this case is the English red printer, English being the language that it's going to print red out in. And then we've got one for blue, and we've got one for green as well. And then using these dependencies, we simply implement the print method here to print out red, blue, and green, one after another. And for completeness, let me show you one of the implementations. Let's take a look at the English red printer. You can see it simply returns the string red in its implementation. No surprise, the blue printer just returns the string blue as well. So this will absolutely work. Let me show you. So we're going to go to the colors application class once more, and I'm just going to click the play button and then run. There we go. And we can see that red, blue, and green have been printed out to the command line there. But what if we wanted to swap out the implementations of our red, blue, and green printers? Perhaps we wanted to print them out in Spanish, for example. How would we do that in this case? Well, we would have to actually change the implementations of our classes. So if we go to the color printer implementation here, so we would actually need to make changes to this class, even though we just wanted to swap out the dependencies that it uses. So the obvious way to fix this is to change this to use beans. So let's do that right now. So first up, we're going to identify the dependencies this class needs. So if we start at the colors application here, we can see that actually color printer and its implementation color printer impl, you could see that as a bean that we need to create. Now inside of color printer impl, we can see that the blue, red, and green printers, the English ones here, these are all great examples of dependencies. These should all be beans. So how are we going to create those beans? One such way of doing it is via a configuration file. Now, if we go back to our root of our project here, create a new package, and I'm just going to call this config. Now, inside of config, I'm going to create a new class here, and I'm going to call this class, I don't know, let's call it printer config. Perfect. Now, this is going to be what's called a configuration class, and we would label a configuration class with the configuration annotation like that. And that tells Spring to look in this class for bean declarations. Now, if we just close those other tabs, where should we start? I think it's probably best to start with the different printers here. So the English blue printer, that should be a bean. So in our printer config, we're going to create a method, which is going to be our bean declaration. And it's going to be annotated with the @bean annotation. And it's going to be public, and it's going to return the type blue printer. We'll simply just call it blue printer. Now, the implementation of this method is going to return the implementation of blue printer. So we're going to return a new instance of English blue printer, just like that. And we'll do the same for the other printers as well. There we go. So we now have these three beans available in our Spring application context. These can now be injected where they're needed. So we need to change the place that they're actually used to look for them in the Spring context rather than create them. So let's go to the color printer impl here. And I am going to remove these news. And inside of our constructor, I'm going to declare them. So we'll start with the red printer. And then we'll have the blue printer. And then we'll have our green printer. We're declaring this in the constructor because Spring is going to use this constructor as a way of identifying which dependencies are needed and then inject them. So we'll then assign our red printer to the red printer in our constructor arguments, and then the same for the blue printer. Instance variable is now going to be the blue printer argument, and then the green printer. There we go. So we can now see that these dependencies are declared as needed inside of the color printer class. So if we then go to where the color printer class is actually used, which we can see was in colors application, so our main class here, we've got a red underline because, well, this is now needing the dependencies. And we could just put the dependencies in these parentheses here and just supply them, but But that's not really a complete solution. So what I'm going to do instead is I'm going to declare a private instance variable on this class, which is a color printer. And then we're going to create a constructor for it. And the constructor is going to take an argument itself, and it's going to be a color printer. And we're simply going to assign the instance variable with the color printer argument provided in the constructor. And there we go. And we'll change our run method to use the color printer as provided. There we go. All is well. But of course, we now need to have this color printer available in our Spring context. So let's go back to our printer config. And we'll create a bean. And this bean is of type color printer. And we're going to return a new color printer import. But of course, this is going to require some dependencies. So how do we get access to those dependencies? Well, there's a couple of different ways of doing this. We can either use these methods directly inside of these parentheses, or we can declare them as arguments inside of the color printer bean declaration. And I want to do it that way. So let's go blue printer and red printer and green printer. See there that we need a red printer, a blue printer, and of course our green printer. There we go. So what's going to happen now? When we start our application is going to look for configuration files. It's going to find this printer config. It's going to create the beans for blue printer, red printer, and then green printer. And then when it gets to color printer, it's going to look in the application context for the blue printer, red printer, and green printer that it already has, inject them into this bean declaration. And then inside of our application context, we're going to have this color printer bean, which of course, if we go over to our colors application here, is then going to be injected into this class, and we're going to use it inside of run. So if we run this application, we should see our colors printed once more. Red, blue, and green. Very nice. But let's demonstrate this one step further. So let's create some new implementations. So I'm going to create some new classes in here, and we're going to call this one Spanish red printer. And this implements the red printer. And we just need to create our implementation for the print method now. And this is going to return, I believe, rojo. My Spanish isn't excellent, but I should know that one. So let's do the same now for the blue and green printers. Just creating those implementations, of course, isn't enough. We rerun our application here. We can see that even though we have those Spanish implementations available, we're still going to get the English for red, blue, and green on our command line here. But if we go into our printer config, and instead of having the English blue printer, we're going to have the Spanish blue printer. We're going to have the Spanish red printer, and then we're going to have the Spanish green printer. We don't actually need to make any changes whatsoever to the color printer bean declaration because these ones are going to be created first and then injected into this one. If we rerun our application now, we should see the Spanish equivalents of the red, blue, and green English text here. There we go. So you can now see that we've got rojo, azul, and verde. I apologize for my accent, but we do have those available. So what's happened is we created different implementations, different concrete classes, different beans for the interfaces of the blue printer, green printer, and red printer, put those inside of our configuration as bean declarations, and then of course they're injected and made available to our application just like that. So that is just one way of declaring beans, but there are a number of other different ways. Let me show you how to do it with the @component family of annotations. So we've covered one way of declaring beans by using a configuration class, but there are other ways, and one such way is by using the @component annotation and its friends, but more on those later. Let me show you how to use the @component annotation to declare beans. Here we are in our configuration file for our color printer class. Now, what I'm going to do is delete it, completely get rid of it. There we go. Now, because in our colors application, we still require our color printer, when I try and run this application, it should break. So let's try that. There we go. We have a parameter of 0 in constructor, colors application required, a bean of type color printer. That could not be found. So how do we declare those with @component? Well, we'll go to our color printer implementation, which in this case is color printer import. And on top of this class, I am going to put @component. And this does a couple of things. First of all, it says Spring, I am a bean. So color printer import is a bean, an implementation of color printer, and it should be put inside of the application context. And it also says any dependencies that I require in my constructor, or any other way of declaring dependencies, but again, more on those later, I want those to be injected as well. So we can see here we require a red printer, a blue printer, and a green printer. So note this error message is looking for color printer. It should change to look for the red printer, blue printer, and green printer inside of the color printer import class now. So let's run this application. There we go. It's saying red printer cannot be found. So what do? We can go over to our red printer here, which let's choose the English red printer. And again, we can just put @component on top of this one. Great, it's now moved on to blue printer. And should be no surprise, looking for the green printer. So let's do the green printer, which is there. There we go, we have a successful application run, and it's printing out red, blue, and green. So this is another way of declaring beans. So of course, if we wanted to swap out the English green printer for a Spanish one, we would simply remove the @component from this class here, go over to the Spanish implementation. There's @component, run this application once more, and we're expecting verde instead of green. There we go, red, blue, and verde. So we can see here the @component annotations on top of the implementing class works in pretty much the same way as doing an @bean declaration inside of a configuration class. We can see that these beans are then available to inject as and when they are needed. Now, I did mention that the @component annotation has some friends. One such friend is the @service annotation. Now, the @service annotation, and there are others, and they will come up as our course progresses, does exactly the same thing as @component. It's perhaps just a little bit more descriptive as to what this class actually does. And of course, we've talked about the different layers of our Spring application before, and one such layer is the service layer. And inside of the service layer, we use services. So if we wanted to label this particular class as a service, as a bean, and be able to inject this and to have dependencies injected into this class, one such way of doing it is with the @service annotation. And to prove this works, let's run this once more. And we can see that the application runs absolutely fine. And if we were to, for the sake of argument, remove the @component annotation from the English blue printer and go over to the Spanish blue printer and then put an @service annotation on top, rerun our application, we're expecting azul instead of blue. And there we go. So we've talked about the @component annotation, the @service annotation, and we talked about these configuration classes and bean declarations inside of them. But we did even mention that Spring would go looking for these things when the application starts up. But we didn't go into any more detail than that. Well, this process is called component scanning, and let's cover it in a little bit more detail now. So let's talk a little bit about component scanning. Now, component scanning is a process that starts when your application starts up. Now, what happens during a component scan is that Spring will look through your project and it's going to look for beans and it's going to look for where beans are needed. Now, if it looks at a bean such as our English red printer here, which is declared with @component, so it knows it's a bean. Equally, if it found it inside of our configuration class with an @bean annotation, it would also know that it's a bean. It's going to look at it and it's going to go, does this bean need any dependencies? In this case, no dependencies are declared. We've done that once before by declaring them in our constructor. This, of course, doesn't have a constructor declared, doesn't have any dependencies that it needs. So what component scan will do is it will create an instance of this class and it would place it as a bean into our Spring application context, which you can think of as a pool of beans, which when they're needed, they can be plucked out and put where they need to be. Now, what happens if it comes across a bean declaration that requires dependencies? Well, one such example is our color printer impl here. So we can see that our color printer impl is a bean. It's got the @component annotation on top, but it does require dependencies, a red printer, a blue printer, and a green printer as declared as arguments to the constructor color printer impl right here. So what it will do is it will look in the application context, look at that pool of beans and go, do I have the beans that I need to meet these dependency requirements? In this case, it does have a red printer, a blue printer, and a green printer. So it will pluck out those beans from the application context and put them into where they're needed, in this case, the constructor. And that process is called dependency injection, but it's also called auto wiring, which is a more Spring-specific term you may come across. Now, we've already seen it a little bit before. If Spring finds all of the beans that it needs, then the application starts up absolutely fine, which in this case we can demonstrate by just running this application here. There we go, process finished with exit code 0, and we can see 3 colors printed here. But what happens if Spring doesn't find the beans that it needs? Well, it fails to start up in this case. So if we were to go to our Spanish blue printer and remove the service annotation, we have seen this once before, the application fails to start up. And it gives you a helpful error message saying that parameter 1 of constructor of our color printer impl required a bean of type blue printer, and that could not be found because component scanning went ahead, looked everywhere, and could not find an implementation, a bean of type blue printer available inside of the application context. So let's put that annotation back. So component scanning starts at a particular point in your project hierarchy. It starts looking for all of those beans and where beans are needed, and it works its way down the tree. Now, traditionally, you would use an @component scan annotation to tell Spring that start point, and all of the packages under that particular start point will be searched for beans and places beans are needed. In a Spring Boot application, for example, we don't use that anymore. We actually use the @SpringBoot application annotation. It happens to declare, if we take a look inside of it, an @component scan annotation on the top for us. So what it says is start at this point here. We minimize this and look for everything in this package and below, which of course includes our service package here, our import package here, and everything inside of these packages. For example, if we were to take our services directory and we were to move that, I don't know, let's move package or directory to directory, and let's move that to, I don't know, comdev0. We can now see this lives in a place that component scanning would never ever look. So if we were to run our application now, we shouldn't be surprised when it doesn't find any beans. There we go, it cannot find color printer any longer because it's in a place that component scanning would never ever look. If we then put that back to where it needed to be, there we go, it's found those beans once more and everything is absolutely fine. Quick note, it's worth pointing out that yes, this directory is called Maven, but the fact it's called Maven is of little relevance. It could be called absolutely anything. The fact it's called Maven is a holdover from a previous rendition of this particular project, but the point is this. We'll declare @component scan at a point in our project, and then everywhere from that point downwards would then be looked for beans and the places that beans are needed. So we did touch a little bit on our Spring Boot application, and we can see that it does a whole lot more than just component scanning. So let's look at this in a little bit more detail now. So we've been using the Spring Boot application annotation for a little while now. Originally, we said it was there to label a Spring Boot application. And while that is true, we've since learned it does a lot more than that. Now, the Spring Boot application is an alias for a number of different annotations. And these are the three main ones. We'll look at them in a little bit more detail in a moment, but let's explore what each of them do. So the @configuration annotation, we've already come across this one. This identifies a configuration class, which is somewhere that Spring should look for beans during its component scanning phase. And then we have the @componentScan annotation, which says from this point in the project hierarchy down, look for beans and places that beans are needed. And then we have the @enable auto configuration annotation. We've previously mentioned that Spring Boot is so powerful, it makes Spring Framework so much easier to use by providing sensible defaults. How Spring Boot does that is via this process called auto configuration. And we're going to cover that in a moment. But before we do so, let me just show you the Spring Boot application annotation in a little bit more detail on a project. So let's flip back to our colors application we were using one moment ago. And here we are at the colors application main class. And there's our Spring Boot application annotation on top. And I'm going to use my IDE to go to this class. And looking at this class, we can now see that it has several annotations on there. The first one we were looking for was configuration, which is actually aliased away under this one here. We can also see that we have our component scan declared here. We've already kind of covered this one once before. And then we have our enable auto configuration annotation. So let's cover auto configuration in a little bit more detail now. So let's talk about auto configuration and the Spring Boot starters. So auto configuration is that process that Spring Boot uses when it starts up to provide those sensible defaults and create all of those dependencies. Now, the Spring Boot starters are a collection of those dependencies which are there in order to solve a particular problem. Now, one such starter that we're going to take a look at the moment is Spring Web. So we're over here at the Spring Initializer. So we'll go over to select Maven, Java, the current version, we'll go com dev tiro. This artifact we will label starter and we'll say a demo for Spring Boot starters. Select a jar, Java 17, and now we're going to go over to dependencies. And if we take a look through here, there are various starters, those collection of dependencies. Now we're going to use Spring Web for this one. And we're simply going to download this and open it up in our IDE. So here we are with our project opened up in our IDE. So first of all, let's go to our pom.xml file where all of our dependencies can be found. And if we look inside of our dependencies node here, we'll see that front and center, we have the Spring Boot Starter Web dependency in here. And the Spring Boot Starter Web is the collection of dependencies that we need in order to implement a web project, including Spring MVC and the embedded Tomcat, which is the application container that we need in order to run a web project. So if we were to actually go into this by command clicking or control clicking, we can see that it has a collection of different dependencies and they are listed here. There's the Tomcat one, there's MVC, there's some JSON, and we'll cover JSON a little bit more detail a little bit later on. But you can see all of those dependencies. So that's the starter. Where does the auto configuration come in? Well, there's actually a good way of demonstrating this. So if we go down to our external libraries here, we are looking for the Spring Boot auto configuration package. Here we are, we can see Spring Boot auto configure. And if we expand this one, and take a look at the classes here, we can see various different packages for various different projects. Now, if we were to scroll all the way down to web, take a look in here, we have some classes, and this is where the Spring Boot magic is. So these particular classes will take a look at all of the dependencies that we have available in our project, such as the ones provided by the Spring Boot starters. They're going to create classes with sensible defaults and then place those resultant beans into the Spring application context to be used throughout our application. So let me show you an example. So if we went into web servlet here and let's scroll down, let's take a look at the dispatcher servlet auto configuration. Now, the details as to what these particular classes do is kind of a little bit outside of the scope of this, but it will be enough to say that these particular classes are needed in order to have a Spring web project. Now, in a Spring framework project, you would be creating these yourself, configuring them yourself. In a Spring Boot project, these classes are going to create the beans and configure them for you. And you can see that this class has several annotations on top. Now, the annotation that I'd really like to draw your attention to is this @conditional_on class. Now, what this is saying is when this class is available on your class path, this class, the dispatcher servlet auto configuration, should be instantiated and run. Now, there's also some other annotations, and one such annotation is conditional_on_bean. I believe it is in this class. Let's go looking for it. Conditional_on_bean, again, is very, very powerful. It says when this bean is available, then this particular part of the configuration should be run. The inverse is possible as well. There is a conditional_on_missing bean. Let me show you this. Here we go, and we can see that if this bean is missing, then this part of the configuration is run. Now, don't stress too much about how Spring Boot does this. Just like you don't need to know how a car works in order to drive it, you don't necessarily need to know all of these details in order to use Spring Boot. But in all honesty, a foundational knowledge in this sort of stuff will help you to understand Spring Boot more holistically. So Spring Boot does an amazing job at configuring your application depending on what dependencies you have available on your class path. But there are going to be times when those sensible defaults aren't quite what you're looking for. And perhaps the easiest way of changing those sensible defaults is by using configuration files. So if you look here, we have our Quickstart application from earlier, so that hello world one. So if we were to run this by going over to Quickstart application here and then clicking on the little play button, we should see that Tomcat started up on port 8080, and if we go over to a browser, we should now be able to hit our application on port 8080/hello, and we can see that it says hello dev0. So our application is up and running. So let's say for the sake of argument, we already have something running on port 8080, and we want this application to run on port 8181. Well, it's just not enough to try and hit the application on port 8181. If we were to try that, for example, we can see that the site can't be reached. So how do we change our application to use that port? Well, we can do so via the configuration files. So if we take a look at our application once more, we can see here in source main resources, we have this application.properties file, and it's completely empty for the time being. So we know that we can change the port the application runs on by putting something into this file, but we don't know right now what we need to put into application.properties. How do we figure it out? Luckily, it's very well documented online. So we go over to our browser again. We can take a look at this page at the Spring documentation, which is our common application properties. Now, if we take a look here, we have a set of keys and then what the keys are there for. So for example, debug is there to enable debug logs. So we can put debug equals true in our application.properties and we can get debug logs out. And it's the same for pretty much anything that you can configure via Spring Boot here. So we want to run our application on a different port. So I'm going to click on web properties, which scrolls me down here, and there's still a lot to look through. So I happen to know that it's server.port. There we go. So we can see here the default is port 8080, but we can provide this in our application.properties file and have the application run on a different port. And again, loads of different properties for all different things that you'd ever want to configure. So let's go back to our application and use server.port in our application.properties file. So I'm going to simply type server.port equals 8181, and I'm going to restart the application now. There we go. We can see that Tomcat has started on port 8181. So if we flip back to our browser and try hitting the application on port 8181 again, we can see that we now get hello dev0. So we were able to configure those sensible defaults by using a key and a value inside of our application.properties file. But it doesn't have to be in properties format. So if we go back here and we were to change it to be from application.properties to application.yaml, YAML being a different format, so We can see here that properties follows this key equals value, whereas YAML likes to use this indent way of doing things. There we go. We can see it's server port 8181, but for the sake of argument, I'm just going to change that to be 8282. Rerun this application. We can see that it's been picked up. Tomcat started on port 8282, and to prove that, try hitting on 8181 again. That's no longer working, so we're going to change it to be 8282. There we go, we have hello DevTiro once more. Now there are some benefits to doing this in YAML if you so choose. Of course, you don't have to repeat the beginning of keys all the time. You can simply just indent instead. Now worth pointing out at the moment is if we go down to the test resources file here, we can also have configuration files in this directory. So we were to create a new file in here and then call it application.properties. There we go. We can see that the icon is such, and we have this application.properties file in source test resources. Now, anything we place in this file will be used in tests. So the source main resources will act as a base, and then anything that's provided in the source test resources, that will be preferred when we're running tests. Now, this can be really handy. So for example, if you're using an in-memory database inside of your test, the last thing you want to do is to use the actual production database configuration that you have in your source main resources. So what you can do is you can put your test database, your in-memory database configuration inside of source test resources, and that will be the database used in your tests. But that isn't the only way of getting configuration into your application. You can also use environment variables. Let me show you that now. Spring Boot can load its configuration from a number of different places. We've already seen it load it from configuration files, it can load it from command line arguments, and it can also load it from environment variables. And this is really important because when you're running your application in things like Docker, it's environment variables you'll typically use to configure your application. So you can see here we have our Quickstart application once more, our Hello World application, and it's using the sensible defaults. So both application.properties and application.test.properties are completely empty, meaning that the application is going to run on the sensible default of port 8080. To prove that, let's go over to our browser, go to port 8080/hello, and we can see hello DevTiro. Now let's say we want this application to run on port 8181, but we don't want to put anything in our configuration file. We want to configure it using environment variables. But first, it's worth covering how you would change a key, as you would find in the common application properties here, into an environment variable. And it's pretty straightforward. As a general rule, you would take the key, you would make it uppercase, and anytime you have a delimiter, such as a dot or a hyphen, you would replace that using an underscore. And Spring Boot is going to use some fuzzy matching logic to then look for various environment variables which match that pattern. So if that's not quite clear, we'll take a look at server.port here. We can see that server.port 8181 is something you would typically find in an application.properties file. The environment variable equivalent is server_port. So we go back to our application. Here we are, and let's stop this running application. Now, the first way that I'll show you to use this environment variable is directly via IntelliJ, which is the way that we've been running things so far. So we go up to the configuration here, we'll go to edit configurations. We can see that we have this environment variables part here. So I'm going to type in here server_port equals 8181. Clicking OK. And now if we were to run the Quickstart application once more, we can see the environment variables being picked up, and we can see that Tomcat is now running on port 8181. So let's confirm this in our browser. Go change that to 8181, and we have hello DevTiro once more. So that's if you're running via IntelliJ. Let me show you how you would run it via the command line. So there's a number of different ways of running your application from the command line, and the first one is via the Maven Spring Boot plugin. So if we were to simply put our environment variable before that command, it would be picked up. So if we type in here server_port, and let's change this to use port 8282, and then we're going to use the Maven wrapper spring-boot run, we should find that application starts up on port 8282. There we go, Tomcat started on port 8282. Let's confirm it in our browser. There you go, hello dev Tiro. So that's one way of doing things. Cancel this. Of course, you don't necessarily need to provide it every single time you run the command. If you were to export server underscore port, let's say 8383 to your environment, remove that. And then we'll just do Maven wrapper Spring Boot run. We should find our application start up on port 8383. Spring Boot's going to look at our environment for that configuration. We can see that Tomcat started on port 8383 here, running absolutely fine. And both of these approaches is providing your environment variable before your command and also in your environment works when you're running via the jar file. So if we were to package up our application in order to get a jar file here, perfect, and now go to the target directory. We already have our environment variable in our environment. So if I go java-jar, and then we'll run our jar file, which is called Quickstart here, we should find that our application starts up on port 8383 once more. There we go, application started on port 8383. Let's confirm that in our browser. There we go, absolutely fine. Application is up and running, configured via environment variables. So we can see that we can configure just about anything that we want to when using a Spring Boot application in the same way that if we were using Spring Framework directly. But what if we wanted to have some custom configuration used by our custom code, but loaded in exactly the same way as all the other configuration for Spring Boot and for Spring Framework? Well, let me show you configuration properties. So here we have the pizza application, and the pizza application is a very basic command line application which simply prints some pizza information. So for example, here we have some pizza config, and the pizza config has, if we go to the class, 3 instance variables, one for source, one for topping, and one for crust. And you can see that we have these annotations on top. We've making use of Lombok. So at data makes this a data class. So essentially all of the getters and setters, equals and hash code, all of that is already implemented for us by using this annotation. And we have some no-ars constructor and some all-ars constructor already implemented for us simply by using these annotations. If you want to learn more about Lombok, then check the description below because we do have a full course on Lombok as well, completely for free, available on YouTube. So we have this pizza config class and we can configure it with a source, a topping, and a crust. Our pizza application simply just prints out, I want a crust pizza with and a sauce. So if we were to run this, I want a thin crust pizza with mozzarella and tomato sauce. You can see that information is being provided in this class right here where it's constructed using the Java new keyword. Let's change this to use configuration parameters, and then we can pass this information in by using environment variables or the configuration file or any other way that Spring Boot loads its configuration. So first things first, let's delete the pizza config new there. We still do need pizza config available though, so we will inject that. Let's create a private instance variable, call this one pizza config, and then we'll need our constructor for pizza application, and we're going to declare that we need an instance of pizza config available, and we're just going to assign that to our private instance variable. Lovely stuff. And we can see here that it's picked up, it's using the pizza config instance variable now, and it's going to print that out. But here's the thing, we don't have an instance of the pizza config bean available in the application context. So you can see here when we run the application, we're seeing that we are not finding a required bean of type pizza config. It can't be found. How do we make it so it is found? Now we can declare it inside of a configuration class, and that's one way of doing things, but we want to load this as configuration from a properties file or from a environment variable. So we'll go over to pizza config. So we're going to add another annotation on top here, and I'm going to call it a configuration properties. Now, configuration properties annotation has a very important argument, and that is the prefix. This prefix is the prefix of the key that then Spring will look for inside of your configuration properties file, configuration YAML file, environment variables, anywhere that it needs to look. And we're just going to call this key pizza because that seems relevant for now. So we've declared our pizza config class as a configuration properties class, but there is one additional step that we need to do, and that's that we need to put an @configuration annotation on top, because we need to tell Spring that, hey, you need to look at this class in order to find beans. In this case, it's a configuration property bean. So if we were to run this application now, we can see that the output is I want a null crust pizza with null and null source, which sounds terrible. And the reason being is that it's not finding any of the keys as declared here. So if we go over to the resources and then application properties, I'm going to type pizza.source, and let's call that barbecue, pizza.topping, and let's call that chicken, and then pizza.crust, and we're going to have a stuffed crust. So this pizza is the prefix that we declared inside of the configuration properties annotation, and we can see here source, topping, and crust matches the instance variable names inside of our pizza config class, source, topping, and crust. So if we run the application again, we should see this information populated inside of this string here. There we go. I want a stuffed crust pizza with chicken and barbecue sauce. There we go. See, it's loaded that information. That configuration properties is now working. Of course, it also works in the various other ways of loading information. If we were to remove pizza.source from our application.properties and we were to go into the configuration here and we were to go into the environment variables, pizza_source, all uppercase, and we'll change this to be tomato. Click OK. Run our application, we should see it's moved from barbecue sauce to tomato sauce. I want a stuffed crust pizza with chicken and tomato sauce. And that's how you can leverage all of the configuration loading behaviors of Spring Boot and Spring Framework for your own custom code. When you're building an application, you typically need to store data somewhere. And relational databases like Postgres and MySQL have been very popular choices for a very long time now. Although it's not the only solution, you can go a long way by storing your data in the rows and columns of a database. And Spring Framework makes it really easy to use them. To understand the different tools that you have at your disposal, you'll need to understand the different layers of database technology and where Spring Boot and Spring Framework comes in. So at the bottom here, we have the database driver, and this is pretty easy to understand. Any major database like MySQL or Postgres will make a Java database driver available to you. And this allows you to interact with the database from your Java code. And the major database drivers are even available from the Spring Initializer. So next up the chain, you have JDBC or Java Database Connectivity. Now we consider this a low-level API. And what we mean by that is that you interact with the database by using SQL queries. A lot of developers love this because you get fine-grained control on your SQL queries, which really allows you to optimize things. However, you've got to handle all of the mapping to and from Java objects yourself. And the more complicated objects get, the more that you have to do, and it's not exactly interesting work. Spring JDBC builds on top of JDBC with some extra Spring magic and gives you things like the JDBC template, which makes interacting with a database using SQL even easier than just plain JDBC. So next up the chain, you have JPA, or the Java Persistence API. Now, JPA's superpower is to allow you to interact with a database by using Java objects. JPA handles all of the generation of the SQL and the mapping to and from the Java objects for you. It's worth noting that JPA is built on top of JDBC, so we consider it a high-level API. One of the wonderful things about JPA being so high-level is, hypothetically, you could swap the database that you're using or the persistence technology that you're using and then not have to change a lot of your code. All of the quirks of the individual databases is all handled for you by JPA. Now, technically, JPA is a specification. The actual implementation, or at least the one used by the Spring ecosystem, is called Hibernate. And you'll often hear developers that use Spring refer to JPA and Hibernate synonymously. Spring Data JPA again builds on top of JPA, adding some additional Spring magic, such as the repositories that we'll see a little bit later. It's worth pointing out you may hear Hibernate referred to as an ORM. That is an object relational mapper. ORMs map from SQL to Java objects and then back again. So in summary, database driver is what you need in order to interact with a specific database. JDBC is how you connect to the database and query it using SQL, and JPA is how you would query that database using Java objects. So let's move on to some examples of using databases from a Spring Boot application. So first up, I'm going to show you how to connect to an in-memory H2 database from a Spring Boot application. Now, the H2 database really is the go-to in-memory database, at least in the Spring ecosystem, and it has a high degree of support there. So let's go over to the Spring Initializer and download our skeleton project. So we're going to need Maven, Java as our language, the general release version, which at the time of recording is 3.1.1. Our group is going to be com.dev.tiro. Our artifact, let's call this one database. And the description will say a demo project for connecting to a database. We'll tweak that a little bit later on. Package name is fine. Packaging of jar, Java version 17. And now for dependencies. The first one I'm going to add is Lombok, because we're going to need access to a logger and potentially need to create some classes. So Lombok's going to make that nice and easy for us. Not strictly needed for anything database related, mind you. For the database stuff, we're going to need the H2 database, of course, and we're also going to need a way of connecting to it. And we're going to use the JDBC API for this. And that is everything that we need. So let's download this and open it up in our IDE. So here we are in our IDE. And I've taken the liberty of changing the database application class ever so slightly. So you can see here that we are injecting a data source object, that object for interacting with the database. And you can see there's a constructor which does the injection. And if we scroll down, we can see that we have that run method. So we're implementing the command line runner. And in the run method here, we are simply printing out the data source, doing data source.toString, log.info, getting our logger from our @log Lombok annotation there. Now we're creating an instance of the JDBC template. More on that a little bit later on, but for the moment, it's worth noting that I'm using this to query the database, and I'm querying the database with the query of select one. It's not going to do anything, but it is going to allow me to demonstrate that I have actually connected to this database and I have managed to query it. Now, other than that, the application is completely fresh. We look at the application.properties here, we'll see it's completely empty. And if we go up to the database application, we can see nothing extra in the way of environment variables or configuration. Now, if we run this application, you are going to see something fairly interesting. So let me run this now. So if we take a look at the logs down here, you can see that the application is started. Our Hikari pool, so the way that we're connecting to our database, is starting up here. We've added our connection. We've managed to connect to the database, and then we've shut down. So everything seems to have gone absolutely fine. The thing, of course, is this line here. We haven't specified how to connect to the in-memory H2 database, but somehow it still managed to figure it out. And that's because of the high level of support for the H2 in-memory database. There's auto-configurers which, if it finds the H2 in-memory database on the class path, it will automatically create the beans needed in order to connect to this database. We don't need to specify where to find it, any username or password. You can see it's already done all of that for us. Of course, we can specify this information explicitly if we choose to, and we can do that in the application.properties here. So let me populate this with that same information that's used by default, and we'll go from there. So when using an in-memory H2 database, the configuration would typically look like this. So we have this first property, Spring Data Source URL, where we specify where to find the database. JDBC, because it's a JDBC connection. H2, because that's the type of database we're connecting to. We're using an in-memory database rather than a database on disk, which is also an option for H2. And then we're naming our database TestDB. We specify our driver class name. We're using a H2 driver to connect to a H2 database, of course. And then we have our username, which is SA by convention, and then the default password, which is password. So if we run this application now, we should see that we are still able to connect to the H2 in-memory database. There we go. We can see that we've added a connection. Slightly different information because we are naming this one testDB, but you can see that it's went absolutely fine. Hikari ball as start completed, and then the application shuts down. So that is how you connect to a H2 in-memory database. So connecting to an in-memory database is all well and good, but how do you connect to a real database? Well, let me show you how to connect to a Postgres database from a Spring Boot application. So over here at the Spring Initializer, let's set this up as before. So we're going to use Apache Maven, Java, the general release version of Spring Boot. Our group is going to be comdev.tiro. Our artifact, we're going to call this one database. A demo project for connecting to a database. You can always tweak that later. Package name, comdev.tiro database, packaging of jar, Java version 17, and now for our dependencies. As before, we're going to add Lombok to give us easy access to our loggers and also if we need to create any classes. And now for the actual database dependencies. First things first, we're going to need our PostgreSQL driver. So let's select this one. And we're also going to need our JDBC API. So let's generate this and open it up in our IDE. So here's our application inside of our IDE. As before, I've taken the liberty of updating our database application class here. I've added @log in order to get easy access to a logger. We are injecting the data source object here. And then in the run method, we are simply printing out the data source using log.info and using our REST template, which is an easy way for me to interact with the database. And we're executing the query select one. It's not going to do anything, but it is going to allow me to show that I have connected to a database and executed the query. Other than that, the application is as default. The application.properties is empty and there is no additional configuration as environment variables or anything like that. There is one additional file, however, and that is this Docker Compose file down here. Now, I've used this Docker Compose file because it's going to allow us to easily start up a Postgres database. We can see here that we're using the image Postgres. It's going to run on port 5432. And we're using this environment variable in order to specify the password of change me in prod ! So before we start this database, let me show you what the application does when it can't connect to a database. So we're going to go over to database application here and then run our application. Here we are, it's failed to start up. So we can see exit code 1. If we scroll up here, it says failed to determine a suitable driver class, but that's not strictly what's happening here. You can see that we failed to configure a data source because the URL attribute is not specified and there is no embedded data source that could be configured. So essentially, it's not found the configuration. Fair enough. We don't have a running database. We haven't found the configuration. That's absolutely fine. So we go into the application.properties here. Let's populate the configuration, which tells this application how to connect to the database. So here we are in application.properties, and we can see that we've got this pattern that we saw before in the H2 example. Spring data source URL, we're using JDBC, PostgreSQL, on localhost 5432, which is where we know our database is going to run. We want to connect to the Postgres database, which is the default one, which is always going to exist for demonstration purposes anyway. The username that we're using here is Postgres, which is the default user. And the password that we're using is the one that we specified in our Docker Compose file, which is change me in prod ! And of course, we're specifying that we're using the driver class name of PostgreSQL, using a PostgreSQL driver to connect to a PostgreSQL database. So this should be enough information for the application to connect to the database if it was running, which it currently isn't. So let's click on play here to start our application and see what the error message we receive. Okay, here we go. We have an error. We have a stack trace. Connection refused. Connection to localhost 5432 has been refused. Check the host name and the port are correct. This is expected because, of course, we're not running our database just yet. So let's open up a terminal and let's start our database by starting our Docker Compose. So in the same directory as our Docker Compose file, we simply have to do docker-compose and up. Of course, you will need Docker installed on your machine in order to do this. There we go. We can see the database system is ready to accept connections. Let's start this application and see if it connects to the database, providing, of course, the information we provided to it is correct. Go over to our database application, and then we'll click on play. Okay, here we go. This is interesting here. So this is a slightly different output from what we've had before. We can see that our application has started up. Tomcat has started up. And if we look down here, Tomcat has started on port 8080. There's our Hikari source. It's started up, and then it's added a connection to the Postgres database, and it's managed to connect absolutely fine. So the connection's gone absolutely fine, but it's approached it in a slightly different way from the H2 in-memory database. You can see here that Tomcat has been spun up in order to connect to the real PostgreSQL database. Nevertheless, this is how you connect to a PostgreSQL database from a Spring Boot application. So you've managed to connect to a real PostgreSQL database, which of course is great. But typically you'll want to set up that database in some way. You might want to create a schema and you might want to populate data. Actually, Spring Boot makes that really, really easy for you. Let me show you how that's done. So here we are in the project that we've just looked at, which is connecting to a Postgres database. However, you can see there's a couple of different changes here. If we go into source main resources, there is 2 files. And by convention, one is called data.sql and the other one is called schema.sql. Now we'll start with schema.sql. Essentially, this allows us to set up the schema. So this is run after the connection to the database is established. And you can see here, it's creating a table called widgets. We're setting this up to be a widgets application. And it's dropping a sequence if it exists, the widgets ID sequence, and then it's creating a table called widgets, which simply has an ID, an numeric ID, a name of a widget, and then the purpose of what that widget is for. Now, if we look at data.sql, we can see that we're populating the widgets table with several widgets, widget A through E, and each of their individual purposes. One's used for testing, and this one enhances productivity. This one is perfect for outdoor activities. It's just populating the database with this data. So what we want to happen is when our Spring Boot application starts up, we want the Spring Boot to look for schema.sql, run it against our database, and do the same for data.sql. However, this isn't all that we need to do in order for that to happen. Let's take a look at application.properties here. So we've got all of our information for connecting to our Postgres database here, but we do have one additional key value pair, and that is spring.sql.init.mode is always. And that's simply saying that we always want to run schema.sql and data.sql. Now, in production, that's probably not going to be the case. There are other values that you can provide to this key. However, for our demonstration purposes, we always want to run these 2 SQL scripts. There are alternatives to this approach, however, such as Flyway and Liquibase, but this is perhaps the simplest way of getting information into our database. So let's start up our application now. There we go. We can see that Tomcat started up. We can see that the connection has been established. And everything seems to be fine here. But how do we know that the data has been populated in our database? Well, let's open up our database in a piece of software called dbeaver so we can view it visually. So dbeaver is free, or at least the community version is free. Let's establish a connection to our database. We are using a PostgreSQL database here. It's running on localhost on the default port. We're going to connect to the Postgres database. Everything seems fine here. Our password is change me in prod, exclamation mark. Let's try that again. Change me in prod, exclamation mark. Let's test that connection. Great, the connection seems fine. So let's finish this. There's our Postgres database. Let's take a look at the schemas. There's our widgets table. And there's our widgets data. ID, name, and purpose. This one is used for testing purposes. This one enhances productivity, and this one is perfect for outdoor activities. So we can see that the schema has been established here. We have our table, and the data.sql file has been run because it's populated this table with widgets A through E. So let's cover how to interact with a database by using SQL. And we're going to be using the JDBC template for this. So we kind of touched on the JDBC template before, but we didn't go into it in too much detail. That's what we're going to do now. So you can see here, this is the project that we use to connect to our PostgreSQL database. We go over to the POM here. We can see the dependencies of Spring Boot started JDBC, PostgreSQL, there was Lombok. And that's pretty much it. If we look over on the application.properties here, we can see we just have the connection information for Postgres, nothing more. You can see here we don't have a data.sql or a schema.sql, nothing like that. And if we go over to our database application, we can see we don't implement the command line runner. It's just a plain, simple application. So what do we need to do in order to get our JDBC template? Well, we're going to create this in the configuration class way. So we'll go over to our package here. We're going to create the config package. And then inside of the config package, we're going to create a class here. And I'm going to call this one database config. So here we have database config. We're going to add the @configuration annotation, which specifies this as a configuration class. And then inside of our database config class, we're going to create a bean. And that bean is going to be public, and it's going to be JDBC template bean. Now the JDBC template requires a data source, so we're going to specify that as an argument. There we go. And then we're going to return a new instance of the JDBC template, passing in the data source so it can connect to our database. And just like that, we have a JDBC template bean available in our application context that we can now use for querying our database. So one of the many different patterns that you can use to interact with your database using SQL is the DAO, or Data Access Object pattern. But what exactly is a DAO? So let's consider this domain. We have books and we have authors, and an author can write many books, but a book will always have one author. Put it into database terms, it might look a little bit like this. A book has various different attributes. It has an ISBN, which is a text attribute and is its unique identifier. It has a title, usually on the front cover, and it has an author ID, which we use to reference the author. Now, the author in this case has a numeric ID, its unique identifier, the name of the author, and then the age of the author. Now let's imagine there were 3 services in our service layer which needed to interact with the database. They needed to interact with the authors and the books that we store in our database. In this case, if we're using JDBC, each of these services would need to know about the structure of that database, how to query it using SQL, and then they would each need to deal with the conversion to and from Java object and SQL. And of course, that would result in a whole bunch of duplicate code. Now let's say we took all of that duplicate code and we put it into a class corresponding to an entity, in this case a book DAO and an author DAO. It would be the responsibility of these classes to know the structure of the database in relation to their specific entity and to handle all of the mappings to and from Java objects and SQL. And then each of the services could inject the relevant DAO, which in some cases could be more than one, and make use of their behaviors via a nice, clean interface. So really, when you think about it, a DAO allows for that separation between the service layer and the persistence layer, and allows for that extra modularity, which of course makes writing the application, maintaining the application, and testing the application a whole lot easier. So that's the theory on what a DAO is, but how do we actually implement one? Let's set everything up so we can do that. So here we are at the project that we've just left. So we can see here that we've got a JDBC template inside of our configuration class. This is a bean, so it's available inside of our application context. Now we need to do a few things to set this project up so we can implement some DAOs. And the first thing is we need to create a schema in the database. We already know how to do this. So if we go over to our project here, go source main resources, you're going to create a schema.sql file. And to this file, I'm going to create the SQL schema as we shown earlier. As a reminder, the schema needs to look a little bit like this. So we need an ISBN, title, and author ID on the books table. And then we need an ID, name, and age on the authors table. And we need that foreign key constraint from author ID to author. So let me populate this SQL now. Here we go. We're creating the table authors here, ID, name, and age. Got a constraint, the primary key here, of course, the ID for authors. And then we're creating our books table, ISBN, title, author ID. And then we have a constraint on the ISBN for that to be unique, as is the primary key there. And then we can see we've got a foreign key constraint from author ID to the ID on authors. So this we'll create the schema that we need. That is step 1. Step 2, of course, we need to go to our application properties and make sure that the schema is going to be run. So let's add the key here. We'll set this to be mode always for it to always run. Of course, in a production application, you probably don't want this to run every time the app starts up. Okay, now let's create our domain classes. Let's go over here. Let's create a directory and let's call this one a domain directory. So a domain package. And inside of here, we need to create 2 classes. One is going to be our author class. And the other one is going to be our book class. So let's start with the author. As a reminder, our author class needs an ID, which is numeric, a name, and an age. Let's create these instance variables on this class, and we're going to use Lombok to make this easier. So data, create a data class. So that creates our equals and hash code and toString and all that good stuff for us, and our getters and setters. That's the main one. We'll have an all ask constructor, and we'll have a no ask constructor. And just in case we want to, let's create a builder for this as well, so we can use the builder pattern. And we need to create, it was a numeric ID, so let's use a long for this. I'm using long capital L to use the object, so that could potentially be null. If we're using little l long, then it will default to 0, which might be a bit confusing. So we're going to use the long object, so it can be null. Then, of course, we need the name of the author, which is going to be a string. And then the age of the author, which is going to be an integer, capital I integer rather than int for the same reason as long. It could potentially be null. And we'll call this one age. So that's our author object. Now let's handle our book object. So as a reminder, a book needs an ISBN, which is a unique identifier, but this is text, so it'll be a string. It needs a title, which is also a string, text. And then it will need author ID, which is a numeric ID, which will be a reference to the author here. So data, all ask constructor, no ask constructor, builder, in case we want to use that. Then we'll have a private, and it was a string called ISBN. We'll have a private string, which is the title, and we're going to do a private long, which is going to be the author ID. Now, you may be wondering, why aren't we using an author object here? Well, the book class that we have here is going to map pretty much directly to the structure of the database. And the structure of the database is such that it will have an author ID, a numeric ID in the table rather than a nested author object, if that makes sense. So we're going to go with the author ID, which is a long inside of this class, rather than the author object. Okay, with the domain object created, we'll now go ahead and create a DAO package to contain our DAOs. So inside of the DAO package, we're going to create 2 interfaces to begin with. One is going to be our book DAO interface. I will leave this empty for the time being. And we'll create an author DAO, also an interface. Leave that empty for the time being. Now, as a bit of a convention, whether it's good or not, it does keep things tidier. So we're going to create an import directory to contain our implementations of our interfaces. And inside of here, I'm going to create a author DAO import. And we're going to implement the author DAO, which of course doesn't have anything declared on it as an interface at the moment, completely empty. And we're going to do the same for the book DAO. Book DAO import. And that's going to implement the book DAO class. Now, we do know one thing about both of these classes, and that's that it's going to need the JDBC template for whatever we implement in here from now on. So let's create a private instance variable of JDBC template. And in our constructor, we're going to declare JDBC template, and then we'll go this.jdbc template equals JDBC template. And that's going to allow us to inject the JDBC template into this class or auto wire it into this class. Now, because we're using the constructor, it comes with the bonus that we can make this final. So it can't be reassigned once it's instantiated, which of course makes things a lot simpler and easier to reason with. We can actually go one step further and make this final as well. Now it's going to be pretty much the same in the other class. So I'm going to copy this line, go over to the book DAO, import, do that there. And I am just going to make use of my IDE in order to add that constructor parameter for me. But I am just going to add that final. There we go. So we now have access to the JDBC template as an instance variable inside of this class, which doesn't have any methods yet. We'll add those in a moment. So when we're implementing our DAOs, we absolutely want to test them. So let's set up our tests. Now, I want to do some integration tests for this. So what that means is we're going to start up a test version of our Spring application, which also is going to mean we need a database. Now, we could use a real database and use something like test containers to start that up. I'm going to elect to use the H2 in-memory database for this one in order to keep things simple, but still get the value of testing against a real database. So let's go down to our pom.xml here. And we can see we've got our dependencies, got PostgreSQL runtime, so that's our production dependencies, and then our test dependencies start. We can tell that because it has the scope of test there. I'm going to add in the H2 in-memory database as a test dependency. We can tell that because it has the scope of test. So this won't go anywhere near our production dependencies. It won't be run when our application is run. It will only be used in the tests. So we're going to use H2 there. But of course, we need to tell Spring how to connect to it and the specifics on how to connect to it. So we're going to go to our application.properties, but we're going to do that in source test resources, which it looks like we need to create. So let's create that. That's a nice little shortcut. And let's create application.properties in here. Very good. There's an empty file. So I'm going to populate this file on how to connect to an in-memory H2 database inside of tests. And here we go. Let me talk you through this because it's ever so slightly different from what you've seen before. So the H2 database has a specific mode setting, so it allows it to emulate the specific quirks of some databases. One such database is Postgres. So we've got here JDBC, it's a JDBC connection, H2 because that's a database we're connecting to, an in-memory one called TestDB. But we're saying here the mode that we want H2 to be in is the PostgreSQL mode. So emulate the quirks of Postgres, essentially. And we're saying database to lower is true. So we're using lowercase names. H2 likes to have everything uppercase. Postgres, you tend to do things in lowercase. And the default null ordering is high. So this particular settings allows it to be the most like Postgres, or at least the most like Postgres that I've managed to figure out. So that dependency is now available in tests, and we've set up the configuration on how to connect to that database inside of test when we use our Spring Boot test annotation. So to test that out, if we go to our test here, which is the default one that comes with anything that comes from the Spring initializer, you can see this has @SpringBootTest on the top, which means it's an integration test. Essentially, it's going to start up a test version of our Spring app when it runs. So we're going to run this class, and if it starts up absolutely fine, it means that our H2 database is configured and in our application context and ready to go. It's saying it can't find the H2 driver, so that may be because IntelliJ hasn't refreshed from the POM file. So I'm just going to click this tab on the right-hand side to go to Maven, and then click on this little button here to reload the Maven project. Okay, let's try running this test once more. Great, that test has passed, which means that H2 is available in our tests, and it looks like everything is good to go. So we've just set up the skeleton of what's needed in order to implement our DAOs. Let's get on and start implementing them. So previously we mentioned CRUD functionality, so create, read, update, and delete. And we also mentioned that the persistence layer typically exposes CRUD functionality. So let's start with the create functionality, so the C in CRUD. So what we're going to do in this case is we're going to start with a unit test. So we have everything set up for integration tests. They'll come later. For here and now, let's do a unit test. So we're going to go over to our test directory here, and I'm going to create a new package. Now I want this package to be a reflection of the production packages here. So ComDevTiro database already exists. We're going to create the DAO package. And inside the DAO package, we want to now create our test class. So we're going to create a DAO for both the author and the book. But considering that the book references the author, I think we should start with the author. So I'm going to create a new class in here. And I'm going to call this one author DAO impl tests, because we're testing that implementation. Great stuff. So here's our class. We need to set this up as a unit test. Now, the author DAO impl is going to be using the JDBC template. We already know that, but we are writing a unit test here rather than an integration test at this point. So I'm going to set this up for mocking using Mockito. So we're going to set this up to use the extends with, and we're going to use the Mockito extension class. And that enables the Mockito functionality, or at least it extends the test runner to be able to use the Mockito functionality. And now we want to set things up. So the class that we are testing is the author DAO impl. Let's make that private. And we'll call this under test as an instance variable. Now I'm going to place inject mocks on the top of this. And I'm going to create a private instance variable of the JDBC template. And I'm going to place mock annotation on top of this. Now, what this will do is by using the Mockito extension and by putting inject mocks above the author DAO impl, which is our class under test, and then putting mock on the JDBC template, essentially, before each test is run, a new instance of the author DAO impl is created for us. And then the dependencies, the collaborators, which in this case is the JDBC template, a mock of that is created and then injected into our author DAO impl class. Now, of course, we can do all of that manually in a setup function, but this is a nice shortcut to do it all for us. So let's now write our test. So we're going to use the test annotation, and then we're going to write public void because this test doesn't return anything, and we're going to call it test that create author generates the correct SQL. And we're going to write this test to make sure that the correct SQL is generated to be passed on to the database. So first things first, let's call our under test class with the create method. And then we're going to pass in an author, which we'll call author. And we're going to use the builder here. So we'll go author builder.build. And let's populate some information. So of course it's ID, and then the name and the age. So let's populate these fields. So for an ID, we'll go for 1 and an L to denote it as a long. The name will go for Abigail Rose, and we'll go for the age of 80 there. So there's our author, and we're going to pass our author into the create method. Now you'll notice the create method is red, and that's simply because it doesn't exist yet. So we need to create that. So let's go ahead and do that. If we click on the create, we get this little red icon here, and then it gives us a shortcut to create the method create, and we'll create it in the interface. There we go. So the create method doesn't return anything, so it's a void method, and it will take an author of type author, of course. Now let's go to the implementation. We get a red squiggle because it doesn't exist in here yet. So we're going to right click, we're going to go to generate, and then we're going to implement methods. We'll make sure create is selected, and then we'll go OK. And that will create the outline of our create method for us, but of course it doesn't do anything. But that's enough for the moment. Let's go back to our tests. Great, so that's now compiling. We now need to assert on the SQL that's generated. And the way that we do that, because the create method doesn't return anything, is by using the Mockito verify method. So if we import this, import a static method, Mockito.verify, and we'll pass in the JDBC template. Now, we want to verify that a certain method is called on the JDBC template with a very particular set of arguments. So the method that we want to verify on is update in this case. Because it's creating an object, it's going to be using the update JDBC method. You can see it's overloaded, so there are some various different ways of calling it. We're going to take this one here. So we're going to pass in a SQL string and then a set of arguments. And we're going to do this to create essentially a prepared statement. So our SQL is going to include question marks, and then the arguments as they're given to this method, the underlying implementation is then going to swap out the question marks with the arguments that have been provided. Now, of course, we could just pass in a SQL string and use string concatenation like the plus signs to create the query using arguments, but we're not going to do it that way because it's not safe. By using this way, by passing in the arguments to the update method and doing the prepared statement, we essentially protect ourselves from SQL injection attacks. So let's do that. The SQL query that we're expecting is going to be something like insert into authors, the name of the table, and then the column names, which we know to be ID, name, and age, the values, and here's our question marks, 1, 2, 3, for ID, name, and age. Let's put that on a new line. So there's our SQL query. What about our arguments? Well, before we move on to the arguments, there's a bit of a quirk with Mockito that we need to use matches instead of the raw values. Now, you can go some way on the raw values, but to make sure everything's working fine, we're going to use matches, in this case EQ, to make sure that this variable is equal to the one. So we'll use argument matches.eq. Now, EQ again, we want to make sure that the arguments are as follows. Basically the same as up here. The ID, we want to be 1L. The name, well, we know we want that to be Abigail Rose, so we'll just copy that for the moment. And the age, EQ again, we want to be 80. There we go. And when the update method is called with exactly these variables, the test will pass. Otherwise, we'll get a failed assertion and the test will fail. So if we run this, we should get a failing test. There we go. Wanted but not invoked. Insert into authors with the variables we've got there. Actually, there were 0 interactions with this mock, and that shouldn't be any surprise because if we go over to the implementation here, we can see that we haven't done anything yet. So let's implement this method. We're going to take the JDBC template. We're going to call the update method on there, and then we're going to write our SQL. There's our query, and now we pass in our arguments, which we'll get from our author object. So author dot get ID, author dot get name, and then author dot get age. There we go. So that should be everything that we need to do in order to create an author in our database. So let's run our test and see if we get a pass. Looking good. Now, if we were to perhaps change this, run it again, we should get a failure. Looking good. So that's confirming that everything is working, at least from a unit test perspective. So that's our create author method, all implemented and working fine, at least from a unit test perspective. We're not yet at a point where I'm going to create an integration test. That will come a little bit later on. Now let's implement the book create method. We're going to do this in exactly the same way. I'm going to go down here into our DAO test package, and we're going to create a Java class. Book DAO impl tests. And then we will do extends with the Mockito extension like before. Inject mocks, and then we're going to have a private instance variable with our class under test, which we know to be the book DAO impl. Call that under test. This too is going to have a JDBC template as a mock. And now we need to write a test, which is public void test that create book generates the correct SQL. Very good. So as before, we'll do under test dot create. That won't exist yet. We'll need a book, so let's create a book. So ISBN, title, and then the author ID. Let's populate these with some values. And now let's pass in the book to our create method. Great, so that's not going to compile. So let's create our create method, which we'll do with that shortcut. Go to the book DAO, There we go. As before, it's not going to return anything. It is a create method and it takes a book. We go to the implementation. Let's implement the missing create method. And of course, it's empty. Very good. So let's go back to our test now. And now we'll need to verify that the JDBC template, just import that. And this will do an update. And the query we're looking for here will be insert into, in this case, the table books. And then the column names are going to be ISBN, title, and its author underscore ID, the reference of the author, the values, and this too is going to use the question marks, 3 of them. And the values that we're going to expect are going to be, let's use our EQs. Importing those. That ISBN, the title, the shadow in the attic, and the author ID, which we know to be 1. There we go. So let's run this test and we should get a failure. As expected, wanted but not invoked because, well, it doesn't exist. That implementation doesn't exist yet. So let's now go over and create that implementation, shall we? Now to speed things along, I'm just going to copy that SQL and we're going to go over to the book DAO impl. As before, I'm going to call the JDBC template, .update, giving it that SQL. I'm going to take the book, get ISBN, book, whoops, get title, and then book, get author ID. Perfect. And if we run our test once more, we can see that everything passes. If we just change the SQL just to be on the safe side, we can see that was a correct green test. Perfect. So we have created create methods for both our author and our book now in the DAO style, and that's the C in CRUD. Let's move on to the R in CRUD. Let's create some read methods. So we've done our create methods, now let's do our read methods. Now typically our read methods are split into a read one and a read many format. So read one is typically you pass in an ID, and if the entity exists in the database, it's returned, and if not, you may get a null or you may get an optional empty if you're using the Java optional. Now in the case of a read many, you'll either ask to get all of the entities of a certain type returned, or you may use a query to get a subset of them, and then you'll get a list of those entities returned. In the case that no entities exist which meet your criteria in the database, then you'll just get an empty list, but you will still get a list. Now we're going to implement the find one method for the books and the authors today. But before we do, I've noticed that this test directory doesn't fully match what we have here. So I'm just going to create a directory in here, call it impl, and then move our tests for our impl classes into that, clicking on refactor. That's better. So let's create our find one method test first of all. So we're going to, again, start with the author. Let's create our test. So we're going to use the test annotation, public void, and we're going to call this test that find one returns, generates the correct SQL. There we go. And we're going to go under test.find one, passing in an ID, which we'll use 1L in this case. Let's create that method find one, and we'll do that on the interface like so. Now here's the find one signature, which currently returns nothing. It's a void method. We want that to return an optional, I think, and we'll go for the optional of type author. So in the case that we find an author with the ID provided, then we will get that author back wrapped in an optional. However, if the author doesn't exist, we will get an optional back still, but it will be an optional empty. We do this rather than returning null, a little bit more type safe, preferable. So that is our find one method. Let's now go to the implementation, create this implementation here. and it's just returning an optional .empty. Absolutely fine. Let's go back to our test. We want that failing test first. So let's do as before. Let's use that verify method. So we're going to say verify JDBC template, but rather than using the update method this time, we're going to use the query method. And you can see this is also overloaded. So the query method that we're going to use starts with a SQL query. So let's start there. I'm going to say select, and we'll declare the column names of ID, name, and age from table. In this case is going to be authors. Let's stay consistent, make that uppercase. Where, and in this case we're going to say ID is equal to the ID provided. Now we only want one author return, so I'm also going to elect to say limit 1. So now we have a choice to make. Because we are using JDBC and we're using the DAO pattern, we need to handle the conversion to and from SQL and Java objects ourselves. There are several ways of doing this, row mappers, result set extractors, row callback handlers, loads of different patterns in there. The one that I'm going to choose today is the row mapper because I found that's the easiest way of testing for it as well. At least in my opinion, different people tend to have different approaches to this. I'm going to show you the row mapper way today. So for our test at the moment, we will make this better. I'm just going to say any, which is another matcher, and I'm just going to say row mapper. Oh, and it's row mapper.class. Now, of course, it is a generic. It does take a type. We'll need to come back to that a little bit later on, but bear with me. And now the final argument that we need to take is going to be any arguments that we're passing in, which in this case is going to be the ID. So we're going to say equals 1L. So you can see this isn't compiling because it's technically not matching the method signature, or at least it's not able to figure out which method signature it's matching because it's overloaded. And it's to do with this row mapper here. So before we can really get into the guts of getting a failing test, we do need to do a row mapper. So what we'll do then is we'll go over to our implementation. We'll go to the author DAO import and we'll create a row mapper. Now the row mapper is there to convert from a result set, which is something that's returned when we query the database, and convert it into an object, which in this case is going to be our author object. Now I'm going to choose to create our mapper as a class inside of our author DAO class here. So a nested class. We are going to create a public static class, and we're going to call this author row mapper. This is going to implement row mapper of type author. Great, so that's a red squiggle because we haven't implemented the methods here. We do need to implement map row. So you can see there it takes the result set and a row number, and we're expecting an author back. So I'm going to use the author builder, and an author, it takes an ID, a name, and an age. So our result set RS has some methods on there that we can use. In this case, we can use get long, and we'll use column labels. So we know this one to be ID. For name, we can use get string. And for our age, get int, and it's age there. So we can use this for as many methods as we need to inside of our implementing class here, author DAO import. And because we do have this class name, it also makes it easier to match in our matches. So if we go back to our tests, put that on a new line, there is a bit of an incantation to make this work. So I'm going to fully qualify it, argument matches, .any. But I'm going to declare here the type of author DAO import dot author row mapper. If it seems complicated, it's because it is a little bit, but we're basically saying here when our argument matcher matches the author row mapper, which of course we know to be a row mapper implementing the generic type of author, and now that any matches, at which point it now is able to match this up against the right signature from the overloaded method. Okay, no more squiggles in this class. So we can now go ahead and run this in order to get our failing test because we still haven't implemented any functionality in our method there. Oh, I've missed equals on the top. See, this is what happens when you mix raw values with matches. 3 matches expected, 2 recorded. So we'll put an EQ around the SQL query. There we go. So wanted but not invoked, JDBCTemplate.query. And we can see up here, it wasn't invoked, 0 interactions with the mock. So let's now implement it. So go to our author DAO, impl, and let's implement our method. Okay. So let's minimize that for the time being. JDBCTemplate.query. We're going to pass in our SQL, which will be a bit lazy and just take from our test here. There we go. And for the time being, I'm just going to create a new instance of the author row mapper. Now, this is going to create a new instance every single time it runs, which isn't ideal. So we can optimize on that a little bit later on. And then we need to pass in the arguments, which we know to be well, it's called L up here, but we're going to call it the author ID in order to give it a better name. There we go. And then let's assign this to an instance variable. And we'll call this results. So we can see here we've got a list of authors, which are results, because we're using that author row mapper and we're doing a JDBCTemplate.query with this particular query. So we need to return now an optional of author. Perhaps the easiest way of doing this is by using the stream API. And we can then say find first, which returns an optional of author, and we can return this just like that. So if we now run our test again, we see we get a passing test, which is fine. So if we change that to be, I don't know, limit 99, for example. There we go, we've got a failing test. So yes, that's passing absolutely fine. Now, it is worth mentioning that we are just asserting that the query that we are building is what we expect it to be. We're not actually running this against a database in our test just yet. We'll get onto that in a moment. But first, we need to implement the book version of this too. So here we are in our book DAO impl test. So let's create a new test, shall we? Minimize this. At test, public void, test that find one generates, or perhaps we'll be saying find one book generates the correct SQL. There we go. And we're going to call under test dot finds, but of course doesn't exist quite yet. Now we need to pass in an ISBN. So we're going to take this ISBN right here, pass that in. Great, so find doesn't exist, but we should be able to create that now. So let's create our method on the interface. Call this one ISBN. Oops, we'll call this one string, should I say? And then name it ISBN. Great, and as before, this is not going to be a void method. It's going to return an optional of type book in this case. Great, so let's go to our implementing class. Create that method. It can just return an optional empty for the time being. That's absolutely fine. Let's go back to our tests. So we'll do verify, JDBC template, dot query, and then we'll need to write our query. So we'll go select ISBN, title, author ID, from books, where ISBN is equal to question mark, and we'll also say limit of 1. Great. So we're going to have some fun with the row mapper argument matcher in a moment, so we'll just leave that as is. But the last argument to pass in is going to be the ISBN, which is going to be the same as this one up here. And let's wrap everything in EQs. Great. So argument matchers.any. We do have those red squiggles because we haven't declared our type there. So let's create our row mapper over in our book DAO impl. We'll do this in the same pattern that we did before. Again, this may not be the most optimized of patterns, but it does allow you to test it rather well, and it seems to work rather well as well. So we're going to go for a public static class, and we're going to call this one book row mapper. It's going to implement row mapper of type book. Of course, we need to implement that map row. And we'll use the builder again. So book.builder.build, .build, ISBN, title, author ID. And then we're going to go result set.getString, ISBN, result set, get string, and it's going to be title. And then result set, get long, and it's going to be author underscore ID. And then we'll return this, just like that. Great. So that book row mapper is now available. Let's go back to our tests. Declaring the book row mapper type there. Great. So we should now be able to run this and get our failing test. Looking good. JDBC template wanted, but was not invoked. 0 interactions with the mock. So let's now create some interactions by implementing our method. JDBC template dot query. Again, let's grab that query from before. And then we'll create a new book row mapper. Again, not the most optimized. We can optimize for that later. Put that on a new line. And we'll need to pass in our ISBN also. Let's assign this to a variable, which we'll call results. That's a list of books. So again, we'll use the stream API to do a find first, returning that optional of book. So if we run our test again, we can see that's passed absolutely fine. Again, let's just double check that by changing that to be limit 99. Very good. So that seems to be working as expected. Great. So we now have implemented our create methods and our read one methods for both our books and our authors. We're now at a point where we can write an integration test that provides a decent amount of value. And we're going to do that right now. So we've implemented create functionality and find one functionality for both our author DAO and our book DAO. And we've even tested that the SQL queries are as we expect them to be using unit tests. What we haven't done yet is actually run this SQL against a database in memory or otherwise. So what we're going to do now is create an integration test. And in this integration test, we're going to actually run the SQL against an in-memory H2 database in PostgreSQL mode. So let's get started. We're going to go down to test here, open this up, and I'm going to put this test, I think, inside of the same directory as everything else. And I'm going to call this author DAO impl integration test. Now, the name of this particular class is important because if we did choose to go author DAO impl IT, capital IT, so if we were to call it something like this, this is a convention that's used by the Maven failsafe plugin. So this will be an integration test, which once configured, will run in that verify step. We're not going to go through the effort of configuring that for the time being. So I'm going to call it integration test, which will be picked up by the Maven Surefire plugin, which is the thing that just runs unit tests. So author DAO impl integration tests. Great, except for I typoed it. Let's fix that. There we go. So we're going to set this up to be a Spring Boot test. So it's going to start up a test version of our application when the test runs. And we're going to use the extends with, and we're going to use the Spring extension class to make sure that everything is fully integrated and supported. Now let's write our test here. So we are going to test that a author is created in the database using the create method, and then we're going to use the find one method that we've implemented to retrieve that author once it's been created. So we're going to say public void test that author can be created and recalled. Great. So we need an author. We have already created a test author over in this test here. There it is. So we really want to be able to reuse that functionality if we can. So I'm going to extract this out into its own method to begin with. So we can go refactor, extract method, and we'll call this create test author. This is a private static at the moment. I'm going to move this into its own test data utility class so we can reuse it. And I'm going to put that at the root of here. So I'm going to go new class, and I'm going to call this one test data util. Great. A utility class usually follows a pattern of being final. We are not going to expose the default constructor. We don't want this class constructed at all. So we can say test data util, and it's not going to do anything. And then we're going to have public static methods available on this class, but I'm not going to create that manually. Instead, I'm going to rely on our refactor tools for that. So I'm going to right click here, I'm going to go refactor, and then I'm going to go move members. And I want to move the member to, here we go, test data util, okay, and then refactor. Great. So if we now click to go to the class, we can see it's a public static method and it's creating a test author that we can use in our tests. So let's go ahead and use that in our tests by going back to our integration test and then creating an author. So author, I'll call it author, test data util dot create test author. Great. Now that's all well and good, but we haven't actually got a reference to our class under test yet. So let's get one of those. So we'll go private, author, DAO, impl, and we'll call this one under test. But that's not going to be enough to get hold of it inside of our test. So we're going to use constructor injection for this. So I'm going to type all that out. I'm going to go public, create a constructor, and the constructor is going to require an author DAO impl, and then under test. Now we can do this because we are writing a Spring Boot test and an integration test. And then we're going to say this dot under test equals under test. There we go. Now, in order for the constructor injection to work in this particular format, we need to put the annotation auto-wired on top of this class. This is actually the first time we've met auto-wired in this course, because everywhere that we've used constructor injection in our main production code, this is omitted nowadays. You don't have to provide auto-wired, providing you only have a single explicit constructor like this, but this, of course, is a test, and they are required at least at the point of filming. So we're going to put at auto-wired on this, and that simply labels, it tells Spring that, hey, you should inject dependencies as declared in this constructor, author DAO impl. So we now have a reference to our under tests, so let's write our test. We're going to say under test dot create, passing in our author, which in theory should create an author in our database. And then we're going to say under test dot find one, passing in the author ID, author dot get ID. Great, and that's going to return a result, which is an optional author. Now I'm going to assert that. So this particular assertion is assert J. So I'm going to import assert J, assertions.assert that. This is a personal preference, but I find it to be very readable and at least some really good failure messages as well when your tests fail, really informative. So we're going to assert that the result is present. So that's to mean that it's not an optional.empty. This does actually exist in the database. And we're going to do a second assertion on here. Again, we may want to do a separate test for a second assertion, but I'd say this is close enough that it warrants being in the same test. So I'm going to say result.get, returning the actual author that's inside of that optional. And I'm going to say it's equal to the author as being created here. So in theory, this should pass if everything is working correctly. Now, I do really like to see a failing test just to make sure that it is the case. So I'm going to type in here 99L, passing in an ID which should not exist in the database. So let's run this and see a red test. There we go. Okay, so we've got failed to resolve parameter, author DAO impl. Okay, it's because we haven't declared these as beans just yet. So this is great. This is exactly what we want in integration test 4. So let's go over to our author DAO impl, and we're going to put at component on here. Let's run this test once more. Okay, so we have here expecting an optional to contain a value, but it was empty. There is our failing test. So let's go back and change that to be the ID of the author as created, get ID. And now let's press play, expecting a green test this time. There we go. Everything seems to be working absolutely fine. Now this is equal to method of assert J is going to use the equals method that is on the class. Now, because we're using Lombok, it's going to use every single instance variable on that class in order to determine if this class is equal to that class. So you can feel very confident that the class, as we have it created here, has actually been saved in the database and recalled. At least as far as we can be confident with an integration test of this type. So we've done that for author. Now let's do it for book. So we'll create a new class. Book, DAO, impl, integration test. It's a Spring Boot test. We use the extends with, passing in the Spring extension class. Now let's get a reference to our class under test to begin with, shall we? So we say book DAO impl under test. And we should be able to use the refactor tools to create, or the generate tools to create our constructor for us. There we go. Let's put auto wired on top. So we now have reference to that. Let's create our test. Public void test that book can be created and recalled. Okay, so we need access to that book. So as before in our unit test over here, we do create a book right here. So let's extract this out into its own method. And we'll call this one create test book. And we'll refactor and move this over to the test data util, which will also make it public as well. There we go. If we go over to the test data util, we can now have two classes, one create test author, one create test book. Very good. So let's go back to our book DAO impl integration test, and let's get a book, shall we? Let's import our book. Then we'll go under test dot create, passing in our book, and then under test dot find using the book's ISBN here, which of course will return an optional of type book, which will say is result. And then we'll assert that the result is present. Let's import assert J is present. And we'll assert that the result dot get is equal to the book as created. Great. So as we did before, let's just change this to be something that is absolutely not going to exist in the database and run our test, making sure it's red. As before, we haven't got the book DAO impl as a bean, so let's fix that immediately. At component, run our test once more. Aha. So we hit a foreign key constraint, which again is fantastic, because that's something that you get from an integration test that you would never get from a unit test. And it simply is the case because we have a foreign key constraint between book and author, and our author doesn't exist. So let's create our author, shall we? So we'll go back to our test here. And we will now need access to our author DAO. So we're going to declare the author DAO interface, and we're going to leave it up to the framework to determine what author DAO implementation we get, because we're not testing author DAO impl specifically here. We're testing the book DAO impl. So we'll add this to our constructor. There we go. We now have an author DAO available. So we simply need to create our author. So we're going to, as before, create our author using test data util. There's our test author. Now I'm going to save this author, which I'm going to do by using the author DAO dot create author. That author now exists in the database. So before we save our book, we're going to set the author ID to be the author.getID. Great, so now that author exists in the database, the book references that author, this should now pass, in theory. Or at least fail, but fail for the reason of being an optional empty because this ID doesn't exist. There we go. We've got an expecting optional to contain a value, but it was empty. So if we now make this the ISBN of the book that exists, book.getISBN, click on play. The test now passes absolutely fine. We are able to create and recall the book. So that was a really valuable integration test and picked up on a few bugs that we had in our production code. Well worth it. So now let's move on to implementing our read many methods. So we've got create endpoints and we've got a read one endpoint, and we've tested those with unit tests and now integration tests. I think it's about time to start implementing our read many endpoint. So it's going to be very similar to read one in a lot of ways and arguably even simpler. So let's start out by going to our tests. And again, we'll start with author just like we've done before. And let's start with our unit test here, shall we? So we're going to write a test here. And this is going to be called public void test that find many generates the correct SQL. So we're going to say under test dot, well, doesn't exist yet, but we're just going to say find. Doesn't take any arguments whatsoever. Let's create this. Creates in the interface. And find is going to return not a void, but instead a list of authors. Great. Now we're going to verify that the JDBC template using query again. And this query is select ID, name, and age from authors. Of course, we need to use our EQ. And we need to use our row mapper. So we're going to go argument matches .any, and then passing the type of our author row mapper. And let's put this on some new lines so we can see it well. Great. So there we go. So this is essentially going to call find, which is going to select ID, name, and age from authors and return all results in the database. Now, you might not necessarily want to do this on a massive data set, and things like pagination will certainly help with that. And we'll get onto that when we talk about JPA and Hibernate. But for the time being, we're just going to return everything. And we're going to use our author mapper as well. So if we run this test, we should get a failure because, of course, it doesn't do anything right now. Oh, we haven't implemented it in author DAO either. So let's do that now by going to the implementing. There we go. At the very least, this should compile. Perfect. Let's run that test again then. Should get a failing test. Great. Okay, wanted but not invoked. Of course it wasn't. So let's call the JDBC template. We'll query, passing in the SQL. And again, we're going to do a new author row mapper. Again, we should probably do this as an instance variable on our class at some point, but for the sake of these tests, it should be absolutely fine. We can get onto that when we start refactoring. So if we now return this, that should be enough for our find endpoint. That's looking good. So let's now test this with an integration test now that we've unlocked that functionality. So I'm going to go over here to the author DAO import integration tests. And we'll create a test. And we're going to call this one public void test that multiple authors can be created and recalled. Okay, so we do have access to a single author here, which is just like that, but we don't have any other authors. So we are going to, let's create those here. I'm going to rename this to be create test author A. I'm going to copy this method, test author B, test author C, And I'll populate these with some different information now. There we go. So we have Abigail Rose, we have Thomas Cronin, and we have Jesse A. Casey. So we've got some test authors to play with. Let's go back to our integration test. And we'll name this one author A. And we'll have an author B. And an author C. Great. So we have 3 authors now. Let's go ahead and create these authors in our database. There we go. So we now have 3 authors in our database, which allows us to do under test. And then we can do find in order to get our result, which is our list of authors. And we're going to, let's call that result. We're going to assert that result has size of 3, because it's going to contain exactly 3 authors. And let's assert that the result contains, and we'll say author A, author B, and author C. Now we can put this all on one line actually, so rather than doing 2 asserts, we can do 1 assert and chain them, and that's the magic of assert J. So we can do something like that. Okay, so let's see if this passes or fails. Okay, we can see it passes absolutely fine. So we've got 3 authors created, and then we're able to return the authors. So if we were to say, I don't know, has size 2, we get a failing test, because of course we get 3 authors returned and not 2. Now, what happens if we run the entire class? In fact, just for the sake of argument, let's just make this green first. Good, so we can see it passes by itself. Let's see what happens when we run the entire class. We can see it fails. And we can see it fails because of something called test pollution. So if we look at the error message here, we can see that we get a duplicate key exception. So we are creating test author A up here in this test. And then in the second test, we're creating test author A again. So actually, there's test pollution in the sense that the author created here is already in the database before this test runs. And we don't want that. We want a fresh database every single test. And you can do this with the dirties context annotation. So the dirties context annotation will clean down the context. So clean down any changes that you've made to the context, including the database. Well, depending on when you tell it to, before each test, after each test, at the beginning of the class. And we can decide that by saying the class mode. And you get some options here, and I'm going to suggest we select after each test method. So after every single test is run, clean down the context, ready for the next test to run, so it's all fresh. So if we run our tests again, we can see that they pass absolutely fine. So then, let's move on to implementing the book DAO. So we'll say at test, public void, test that find generates correct SQL under test dot find. Oh, it appears that we have some inaccuracies with the names. So we're going to refactor the base method, changing that to be find1, meaning that we have find here, and that would be consistent with the author DAO. Now then, let's create the method find on the book DAO here. Find returning a list of books. Let's create that method on the implementing class, returning null for the time being, going back to our test. And then we're going to verify that the JDBC template is called with query, and the query is going to be select ISBN, title, author ID from books. And of course we have our argument matcher, whoops, .any. And we'll need to declare our row mapper, which is going to be our book row mapper. And it's easy as that. So let's run this, expecting a failure because, of course, we haven't implemented this yet. Oh, we haven't wrapped an EQ. Let's do that now. Great. Okay, so wanted but not invoked. Perfect. So let's go ahead and implement this then. So we'll go to find, and we're going to say JDBCTemplate.query. In fact, we'll just borrow the SQL from this test here. We'll create our book row mapper again, suggesting that we make that an instance variable at some point. So we have a failing test that's run again, and hopefully this will go green. Looking good. Our unit tests are passing. So the SQL is being passed via the JDBC template as expected. So let's go over to our book DAO integration tests. And as before, let's create a test. Public void test that multiple books can be created and recalled. And we'll need access to our multiple books. Now we're going to make all of these books belong to a single author. So we're going to take this line from up here, creating our author in our database. And then of course we'll create our book, which can be done via the test data util. .create test book. Let's go over to the test data util. So create test book. We'll call that create test book A. And as before, we're going to create test book B and test book C. Let me populate this data and then we'll move on. So there we go. We have test book A, test book B, and test book C. So let's go back to our test. And we'll create these test books. And let's set the author ID on each of them. And we'll create each of these books in the database. Great, so we now have 3 books in the database. So we're going to go under test.find, and that will return our list of books, which we're going to call our result. And then we're going to assert that the result has size 3, because it's going to be 3 books. And as before, we're going to say it contains exactly book A, book B, and book C. So let's run this test. And we can see it passes fine. Let's just confirm that by changing that to has size 2. Great, and that goes red because of course it's 3 books being returned, all belonging to that author with ID 1. So that's very good. Now let's run this entire class, and I imagine we're also going to have some failures as a result of the context being dirty. So let's figure that out. Okay, so we're going to do @dirty's context. And again, we're going to go for the class mode of after each test method. Let's run them all once more. Looking good. But I am going to open up the terminal here and then call Maven from the command line to be sure there aren't any other issues. So I'm going to do Maven, clean, and then verify. Build success, all of our tests are passing, looking good. So we now have a create method, a find one, and a find many implemented in our DAO style. I think it's time we moved on to the update method. So we're going to pick up a pace a little bit now because you're probably starting to understand what we're doing. Let's implement our update method, shall we? And we'll start with our author. So we'll go over to the author DAO import test here. We're going to create a new test. public void, test that. Update generates the correct SQL. Now we're going to go for a full update rather than a partial update. We'll come on to partial updates when we talk about, again, Hibernate and JPA. So we're going to say under test.update, and that's going to require an author. So we need an author. Let's get hold of one. So update doesn't exist, so let's create that. It's going to be a void, but it is going to take an author. Let's go down to the implementing method. Let's create that. Okay, so it's not going to do anything for the time being. So let's verify that the JDBC template. And we're going to use update for this one. And we're going to say update, authors. Then we're going to say set ID equal to question mark, name equal to question mark, and age equal to question mark, where ID equals question mark. And now for the objects. So we have our author here. The first question mark is going to be the author's ID, which we know to be 1. In fact, let's just take a look at that author once more. ID of 1, name is Abigail Rose, and the age of 80. So ID is 1, name is Abigail Rose, and the age is going to be 80. And then the ID, of course, at the end here is going to be 1 again. So if we run this method, we can see it's wanted but not invoked. So I'm going to borrow the SQL right here, and we'll go over to the under test.update, and we're going to go JDBCTemplate.update, passing in our SQL query. And then we're going to go for author.getID, author.getName, author.getAge. And of course, we need that ID once more. If we run our tests, we can see it passes absolutely fine. And this would be a valid method. But what I like to do is explicitly declare the ID as an argument to this method, and then that allows you to change IDs. So I'm going to go for long ID, and then we'll go to the implementing method, do the same here. And now we'll make that ID, which allows us to update the IDs of authors if we so choose. We do need to update our tests, however, so let's go back to there. We are just going to use author.getID. If we run the test once more, that passes absolutely fine, but just to be on the safe side, let's go for 3. There we go. There we go. Having a different ID in there is just a better test in this case. So that is the unit test for our author. Let's create an integration test. Test that author can be updated. So of course we need to start with an author. So let's create an author here. So we have an author created in the database, author A. Now I am going to go ahead here and I'm going to update author A. And I'm going to set the name to be updated. And then we're going to go under test.update, author A.getID, passing in author A, which has been updated to have the name updated. And we're going to go under test.find1 using the author A.getID. And then that's going to be our result. Now we're going to assert that the result is present. And let's assert that the result.get is equal to author A, which of course has been updated to have the name updated. So let's run this test and see what we get. Great, it looks like our update is working absolutely fine. So let's move on to our book now. So we'll create a test, public void, test that, update, generate the correct SQL. We're going to go under test dot update, which of course doesn't exist, but we'll pass in a book, test book A. Let's pass that in there. And let's create this method over on our book DAO. Whoops, but of course it's the ISBN that's needed for this book, not the ID. So it won't be a long, it will be a string. And there's the book for the update. So let's go down to the implementing class, create this method here, and we'll just leave it at that for the time being. Let's go back to our test. Let's go verify that the JDBC template is called with update. And of course, we're going to go for update books set ISBN equal to a question mark, title equal to a question mark, and author ID equals to the question mark, where ISBN is equal to the ISBN provided. Run this test. There we go, wanted but not invoked. So let's implement our method. But let's just borrow this SQL. JDBC template update, passing in our SQL there. And now we need our arguments. So we're going to go book.getISBN, book.getTitle, book.get author ID, and then we're going to pass in the ISBN from the arguments of the method there. So let's run our test again. Arguments wanted but were different. ISBN, title, author ID, ISBN. Oh, may have rushed that one a little bit. So we just need to populate this with the information, of course. Go to testbook A. There's our ISBN. The first one. The title is The Shadow in the Attic. And the author ID, of course, is 1. And the ISBN just happens to be the same for this one. So we're going to just put that there. There we go. Rush that one. So let's play that test once more. That's a bit better. It's now passing. So let's go ahead and write our integration test for this. Test, public void, test that book can be updated. So we're going to need an author to begin with. So let's grab one of those from up here. And now we're going to need to create a book, which actually has already been done for us here. So let's borrow that. So we now have a book created in our database. Let's go ahead and update that. So we're going to say book A dot set title to be updated. And I'm going to go under test, update, book A, get ISBN, and then we're going to pass in the updated book A, which of course has the title of updated. That should update. And then when we do a find one, so under test dot find one, passing in the ISBN from book A, that's going to return a result, which is an optional of book. And then we can assert that the result is present. And then we can assert that the result.get, which will return a book, is equal to book A, which has been updated with the title updated. So let's run this test and see what we get. And there we go, passing absolutely fine. So we now have a update method for both our book DAO and our author DAO. So of the CRUD acronym, we have the C, we have the R, we have the U. Now we move on to the D, which is delete. So let's implement that delete method now. Okay, so let's now implement our delete method. So we're going to start over on our author here. So let's go to our tests. And we're going to write a new test. And we're going to say public void test that delete generates the correct SQL. Great. Now we'll call under test.delete. And it's going to take an ID, which in this case can be 1L. This method, of course, does not exist, so let's create it. Void delete, that's absolutely fine. Let's go down to the implementing method and create it there as well, but not doing anything, no implementation. Verify, JDBCTemplate dot update, and our SQL query here is going to be delete from authors where ID is equal to question mark. And of course, we're going to pass in the ID as our argument, which is 1L. Let's run this test and see a failure. There we go, wanted but not invoked. So let's now implement this. Okay, let's run this once more. And we have a passing test. So let's now create an integration test for this. At test, public void, test that author can be deleted. So let us create an author in the database. And then we're going to go under test.delete using author A's ID. And now we're going to go under test.find1, again using author A's ID. This will return a result. If the author doesn't exist, that will be an optional empty. So we're going to assert that our result is empty. Great. So if we now run this test, we can see it passes absolutely fine. We are deleting that author. If we were to comment out the delete for the time being, we should expect this to fail because, of course, the author should still exist. There we go, looking good to me. So that is the author side of things done. Let's now do the book side of things, shall we? So let's go over to the book DAO import tests. At test, public void test that book delete generates correct SQL. So we're going to go under test.delete, and then it's going to take an ISBN in this case. So let's grab an ISBN from up here. This method doesn't exist. Let's create it. Great. Let's go to the implementing class. We won't do anything. But let's go to the test. Now verify that the JDBC template is called with update and the query of delete from books where ISBN is equal to question mark. And of course, we'll expect the ISBN to be an argument in there as well. Let's run this test and expect a failure. Looking good, wanted but not evoked. So we're going to borrow this, go over to our delete, and then we're going to implement this with JDBC template.update, passing in our query, and then the ISBN. Great, let's run this test once more. It's all green, perfect stuff. So let's go over and do an integration test for this. At test, public void, test that book can be deleted. So we're going to need an author because all books that we create in the database need an author. And then we're going to create a book. So we're going to borrow this from up here. We could potentially extract this out into private methods at some point when we're refactoring. But we now have a book in our database. Let us call under test.delete using the ISBN from book A. That should delete our book for us. So if we now do a find one using book A's ISBN, we should find that the result from this is now empty. So we're going to go result.is empty. Oh, we need to, of course, assert that. Otherwise, it's not going to amount to much. There we go. I am going to comment out the actual delete for the time being, because I want to see a failing test first. Okay, and now if we uncomment that, we see that it's passed absolutely fine. And this is a great time for us to rerun Maven Clean Verify. Everything's passing absolutely fine. So we've now implemented DAOs with CRUD behavior, create, read, update, and delete for authors and for books, where an author and a book are related in the sense that an author can write many books, but a book will always have one author. I think we can appreciate this was a lot of work. There must be an easier way to do this. I mean, of course, this gives us access to really tweak those SQL queries, but you can see a lot of those queries we were using were very, very basic. Is there a better way? Is there an easier way? Yes, there is, and that's by using JPA and Hibernate. Let me show you how that works now. So we've made use of the JDBC template to build DAOs for the author and the book, and we've done it completely from scratch ourselves, and it was a lot of work. Is there a better way? Yes, there is, and it's by using Spring Data JPA and Hibernate. This is a higher level API, and it takes care of a lot of the low level details for you. For example, we're not even going to be touching a line of SQL when we deal with this module. Now, the best way to demonstrate this, the differences between a plain JDBC template approach and then going the full-blown Spring Data JPA approach, is to build on the project from the last module. So you're going to be using exactly the same domain of books and authors, whereby a book has one author, but an author can have multiple books. But we're going to take the code that we've written with our DAOs, we're going to strip out the bits that we don't need, and then we're going to place in all of the bits that we do need in order to implement a Spring Data JPA implementation of the standard create, read, update, delete, CRUD functionality in our persistence layer. So here we have our project from where we implemented our DAOs. And the first thing we're going to do is delete our schema.sql file. So this was used to set up the database structure, and we no longer need that. Hibernate's going to take care of it for us. Let's delete that. Now let's go over to our DAOs. So if we take a look here, we've got our book DAO and author DAO. And this is where we're exposing the create, read, update, and delete functionality for the book and the author respectively. We no longer need these, so we're going to get rid of those and the implementing classes as well. In fact, let's just delete the whole DAO directory, because all of the SQL is going to be generated for us now. We'll keep the domain, but we'll tweak those in future. And the database config with the JDBC template in there, we no longer need that JDBC template, so we're going to go ahead and delete that. We may bring that config directory back later. Yep, keeping the domain objects. So let's go down to the tests here. Now I'm going to delete the unit test that we had before, but I'm going to create here a new package, and I'm going to call this package repositories. More on why I've done that later, and I'm going to take the integration tests and I'm going to place those into the repositories package. That may seem mysterious, but you'll see why I've done that. But what I am going to do is delete the DAO package. I'm going to comment these out for the time being. There we go. So we don't have to worry about those not compiling because, of course, the DAOs have been deleted. The database application test just does context loads. Can keep that, and the test data util that has all of our lovely test data in there, let's keep that as well. So as far as it goes, we have some commented out tests. We have our configuration for connecting to a PostgreSQL database inside of our production code. Inside of our test code here, we're connecting to an in-memory H2 database, which is in PostgreSQL mode. And in terms of our production code, we have a domain and we have our entry point and not a lot else. So let's kick things off by going over to the pom.xml here, and where we've got Spring Boot Starter JDBC, I'm going to change that to Spring Boot Starter Data JPA. And we'll go over to the little tab on the right-hand side here, and we'll refresh. So we'll refresh Maven in IntelliJ here. So just like that, we have all of the dependencies that we need in order to use Spring Data JPA, which is great. because we can now create our repositories in production. So we're going to do just that. So we're going to create the repositories directory. And I'm going to create two interfaces here. I'm going to create one, which is going to be the author repository. That was an interface, not a class. And I'm going to create another, which is going to be the book repository. There we go. We're not going to do any implementation on these at the moment. We're just going to leave them as blank interfaces. So the next step for us is to get started by updating our domain objects to become entities. So let's get onto that right now. So let's get started by modeling our domain as entities. So this is what we've got. We've got books, we've got authors. We are very familiar with these objects by now. So let's flip over to our code. So we've got these plain old Java objects, POJOs, left over from our DAO implementation. We've got one here, which is an author, and the other one, which is a book. So what do we need to do in order to change these POJOs into entities so that we can use them with Spring Data JPA and Hibernate? Well, it's actually very straightforward, and most of it is annotations. So let's get started. The perhaps most important one is we need to put an annotation on here, which is @entity. And this simply labels this object as an entity that can be used with Spring Data JPA. So that's step one. Now we need to say which table this maps to in the database. And we are going to map this to the authors table. Name equals authors. Perfect. So now we need to identify which field in here is going to be our ID, our unique identifier. And of course, it's for the author going to be ID, so we can use @ID in order to identify that. There we go. Now we have a choice to make. We can either define the ID of the author every single time when we're creating a new author, we create a new ID ourselves, or we can leave it up to the database by using a sequence. So the sequence will start at 1, and then when an author is created, it will increment to 2. So the next author's ID will be 2, the next one will be 3, 4, 5, 6, so on and so forth. And the way that we would do that is by using the annotation generated value. And we'll say strategy here is sequence. And then we give the generator a name, which we're going to say is author ID sequence. And just like that, every time we create an author, the database will create a new ID for us, incrementing by 1 when we don't provide one ourselves. So that is all we need to do in order to convert the author POJO into an author entity. So let's now take a look at the book. So here is our book POJO. Let's convert this into an entity. So we'll add the @entity annotation on the top there, and we'll add the @table annotation, mapping this to the table of books. We'll now need to identify the unique identifier, the ID. So add the ID annotation to the string ISBN private instance variable here. Now, we're going to make a design decision, and the design decision is that we want to provide the ISBN every time we create a book. We're not going to use a generated sequence or anything like that. We're just going to provide it. Now, the title we don't need to do anything to, but this field can be updated. So this is the author ID field, which is of type long, which we use to store the ID which reference the author of this book. Now, because we're using Spring Data JPA, we can actually use the author object here. So we're going to say author, and we're going to change the name to be author. And we can add some annotations to this private instance variable to make it so that we can deal with the book and its related author. So we could retrieve a book and also retrieve its related author object. So first we need to tell Spring what the relationship between these objects are. And you can see here there is a many-to-one relationship. So we're going to say @many-to-one on the top here. So when I define a relationship like this, I usually like to define the cascades as well. And we're going to say cascade all. So what this means is if we get a book back, we also retrieve the author. And if we were to take that author that's on the book, make some changes to it, those changes would then also be saved into the database. So all changes, everything that you do to the author retrieved via the book would then be persisted in the database. So that's our many-to-one annotation. And now we need to specify what the join column is. We can do that with the join column annotation here. And the join column annotation was, of course, author ID, which we know from our DAO experience. And just like that, we've converted our author and book pojos into entities. Now, when we were creating these, we were adding a lot of information, such as names of sequences in terms of the author here. And we were also adding information on the book like this, which is the join column. But we have removed the schema.sql file. So how on earth are we going to create all of the relevant structure in the database in order for the information that we've put on these classes to be correct? Well, Hibernate can do it for you. So let me show you Hibernate Auto DDL. So Hibernate can set up your database schema for you, and how you enable this is really straightforward. But to show you how it works, we're going to need a database first. So we do have this Docker Compose file in the root of our project, and it starts a Postgres database. So let's do a Docker PS to see what's running. We have nothing running, so we're going to do docker-compose and then up. And this is going to start our Postgres database. Database system is ready to accept connections. It's looking good. So I'm now going to connect to this using dbeaver so I can show you the database structure visually. No surprises, it's going to be empty, but let's take a look. So here we are in dbeaver. I'm going to create a new connection up here in the top left. I'm going to select PostgreSQL, next. It's on localhost, the database is called Postgres, the username is Postgres, and the password is change me in prod ! Let's test that connection. Connected, looking good. Click on finish here. So now if we go into the databases, into the Postgres database, look at the schemas, the public schema, look at those tables. There are no tables. It's completely empty, exactly what we'd expect. So now that we have that set point, let's have Hibernate create our structure for us. So let's go back to our code. So like a lot of things in Spring Boot, you can enable this feature in your properties file. So if we open that up now, we're not going to need spring.sql init mode anymore. We're going to need a new key for this. So let's go over to the documentation in our browser and figure out which key we need. So if we take a look here, we've got the key that we need, which is spring.jpa.hibernate.ddl-auto. So I'm going to copy this. You can see a description of what this does here, but essentially if we set this to the right value, then Hibernate is going to set up our database schema for us. Now, the value I happen to know that we want to use here is update. You can see that there's things like create drop and none, and obviously each of these has its place, but we want our schema updated when we change our entities. Obviously, be very careful with this in production. So let's go back to our code now, add this key, and I'm going to type update as its value. So remembering that our database is completely empty, if we run our application, we should expect now that Hibernate is going to create our schema for us by using the entities. We can't expect the application to do too much, but it's certainly going to create the entities for us. So let's start the application. Okay, so it's exited, it's connected to the database. Very good. Okay, great. So let's take a look at the database in dbeaver. Okay, and I'm going to right click on tables and I'm going to go to refresh. Cool. So we have both the authors table and the books table now available. So we can see here that we've got ID, age, and name on our authors. And we have ISBN, title, and author ID on our books. So Hibernate has been so kind to create these tables for us. If we take a look at the sequences, there's our author ID sequence, so we should expect to get a new ID every time we create an author as well. So that's looking pretty good. But we don't have any functionality in our application that makes use of all this power just yet. So let's get back to our repositories and start implementing our create endpoint. So we have some entities and we have managed to use Hibernate to initialize the schema in our Postgres database. But we don't actually have any functionality in our application just yet. And we want to start with a create method. So where do we go for that? Well, we've got our repositories that we've created already, one for author, one for book. So if we open up the author one, I think this is where we'll start. Now this is an interface. And the wonderful thing about Spring Data JPA is you don't actually have to provide an implementation for the interface. It does it for you, providing you extend the correct repository interface. Doesn't make sense, stick with me. So if we were to go into our author repository here and say extends CRUD repository, and we're dealing with an author here, and the author's ID type, let's just import that, and the author's ID type is a long, You wouldn't believe the amount of functionality we've just unlocked. There is a missing piece of the puzzle, however, and that is the @repository interface here. So @repository is very similar to @component, does pretty much the same thing, but of course it describes this as a repository. So the author repository is now a bean that can be injected anywhere that's needed. So how do we test this? Typically, you wouldn't test a repository because this has all been generated for you, but we're going to demonstrate this. So we go down here to our tests, we go into our repositories, we've got those 2 leftover classes that we had from earlier. So this is exactly why we've kept them. So if you go into the author DAO integration test here, the first thing that I'm going to do is I'm going to uncomment this code, and I'm going to rename this to be the author repository integration tests. There we go. And the class that we have under test is no longer the author DAO import, it is the author repository. And we just need to change our constructor here. Great. So I am going to go ahead and comment out all of the methods that don't relate to creating here. So we do have this method, which is test that an author can be created and recalled. Sounds pretty good. So we've got our under test here and we're calling create, but that method doesn't exist. Well, what if I was to tell you that actually it does, and on Spring Data JPA, it's called save. And actually we've got here under test.find1, but on Spring Data JPA, we can go find by ID. And you'll see that this entire test is compiled absolutely fine. So if we take a look at these individual methods here, for example, let's go to save to begin with, you can see it exists on the CRUD repository here, which extends repository. This is the base repository. And then we've got some basic CRUD behaviors in here, including save, save all, that find by ID that we were using a moment ago, find all, count, delete. So this is the basic CRUD stuff that we had before. But of course, we don't have to do any of the low level work as we did with the DAO. So if we were to run this test, I wonder what would happen. Okay, so it can't find the author ID. Yeah, that would totally make sense. So we are going to pass in the author instead, and then we'll have that passed in instead of the author ID, because this is how we changed our book entity, wasn't it? So let's do that. Let's go back to our test and let's compile this. Okay, that's compiling fine. Let's try running this test again now. You'll see that it passed absolutely fine. And we didn't write a line of SQL. We were able to create an author and then recall it from the database. Pretty cool, right? So let's do the same for our book repository now. So we go over to book repository. We're going to add the @repository annotation on the top. We're going to extend here the CRUD repository. And we're dealing with a book in this case. And the ID type of the book is a string because it's our ISBN. So let's import book. And we have a book repository, at least with basic CRUD functionality. So let's go over to the book DAO import integration tests, uncomment this, and we'll need to do a few changes over here, starting with the name. So let's change this to be book repository integration tests. And now we're injecting a few things. So let's start with the book repository and call that under test. And let's not bother with the author DAO. Let's remove it from the constructor as well. But we are going to change the type in the constructor to be a book repository, which makes that compile fine. And then we have our test book can be created and recalled. So let's comment out everything here. And we'll see that we've got an author. That's great. Do we need to create the author manually? No, we don't, because we have our cascade set up. So let me show you how they work. So we do need to pass in the author to the book because we've updated our utility method here for creating a test book. We don't need to worry about any of that because we don't need to set an ID on the book. We've just set the author on the book. We know that we're not using a create method in Spring Data JPA. We are using a save method, however. And we know that we're not using a find one, we're using a find by ID. But everything else remains absolutely fine. So for this to pass, we should expect for the author to be created in the database in addition to the book. Let's see what happens. Let's fix those imports. Compile. Looking good. Let's run this. And it passes absolutely fine. Now, just to demonstrate, so if we were to go over to the book here and then remove the cascade type from the annotation here, and then rerun the test, you can see that the test fails because we're not cascading to the author. We can't save the author there. So we're unable to find the author with the ID of 1. Put it back. And Spring Data JPA handles creating that author because it's a brand new author with a brand new ID, and everything works just like that. So not only have we implemented the create endpoint with no SQL whatsoever, we've also created the read one endpoint. So I think what we need to do now is deal with the rest of the CRUD acronym. So we're going to do the read many, the update, and the delete, starting with the read many. So we've got our create method and we've got our read one method. What about our read many? Well, we happen to have an integration test for that before. So let's go over to the author repository integration tests, and we can see we have this one right here. And we are creating test author A, test author B, and then test author C. So if we were to save these, we have 3 authors here. And instead of find to return the list of all authors, we are going to go find all. That's returning a iterable rather than a list, but we can make that work. And then we can assert that the result has size 3 and contains exactly author A, B, and C. So if we play this test, we can see that we also got the find all functionality for free with our CRUD repository, which is pretty cool. What about the book repository? Let's go over there and let's uncomment this test and make the same update. So we do need an author. We don't need to create it. We don't need to set the author ID. We do need to pass the author in to the create testbook A, B, and C methods. We can remove setting the author ID. And instead of create, we are going to call save. Instead of find, we're going to call find all. And that returns an iterable. Okay, so if we now click play here, we find that we do get this find all functionality for free on the book as well. While we're here, we might as well just update the remaining tests. Let's update the update methods. So let's uncomment the update method on the author here. Rather than create, we're simply going to go save. We're going to go save rather than update. But with author A like that, and then we're going to go find by ID. So save is used for both creating and updating in Spring Data JPA. So essentially what we're doing here is we're creating an author, we're saving that author, we're updating that author with a brand new name, updated in this case, we're resaving it, and then we're finding by ID, or using the author's ID, and we're asserting that the result is present, so asserting that we did find an author, and then we're making sure that the author matches, or the result matches, our author A with our updated name. So if we run this, it passes just like on our DAO. So if we go over to the book repository and do exactly the same thing here, so we do need an author. Pass that in. It's when we create book A. Don't need to set the author ID. We're going to call save. And save once more. And then find by ID. Of course, we don't need to pass in the ISBN for this method. It gets it from the object. There we go. So let's click on run. Looking good. That's working absolutely fine. Let's move on to our delete methods. So the last of the CRUD functionality, of course, is the delete. So we're in the author repository integration test here. Let's uncomment this. And we're creating an author so that we may delete it. So we've got several options here. We can either delete passing in the author entity, or we can delete by ID. Delete by ID is probably the most similar to what we were doing before. So let's go author a.getID. And it's not find one that we're using, of course, it's find by ID. So if we run this test, we can see that it passes absolutely fine. Let's do the same for the book. Uncomment this. We don't need to create our author because we're going to pass it in to our test data util here. And then via a cascade, we're going to have that created for us. Let's go save. And then we're going to delete by ID. And then we're going to pass in the ISBN. Instead of find one, we're going to find by ID, and we're going to run our test. And it passes absolutely fine. So we have create, read, update, and delete functionality, and we've tested it via our integration tests. If we go down here and we run our Maven wrapper, clean and verify, let's make sure everything's working fine. We have a build success. All of our tests have passed. So just like that, we have implemented exactly the same functionality that we did with our DAOs, writing all of our SQL queries manually with what seems to be under 10 lines, most of them being imports. So we have a repository for our authors here, and we have a repository for our books, and we have full create, read, update, and delete functionality with all of the SQL being generated for us by Spring Data JPA. Now this only scratches the surface of what's possible with Spring Data JPA, so let me show you how to do a more complex query. So Spring Data JPA does a lot of hard work for us. And one thing which I find really impressive is the way that you can create queries just by naming a method inside of a repository. So to demonstrate this, we're going to need a test, I think. So let's go down to our test, so our integration test, and we're going to create this one in the author repository integration tests. We're not going to bother with the book for this one, just the author. So we go at test, public, void, test that, get authors with age less than. And for this, we're going to need some authors. So let's get test data util, create author A, let's assign that to a variable. We'll do the same for test data util, get author B, assign that to a variable, and the same for C. Assigning that to a variable. So we have three authors. Let's take a look at the implementations of these methods. So we can see we've got Abigail Rose, age of 80. We've got Thomas Cronin, age 44. And then we have Jesse A. Casey, age 24. So if we wanted to, let's say, get all of the authors with an age under 50, we would expect to get test author B, test author C, but not test author A because Abigail Rose's age is over 50. So how would we go about doing this? Well, first things first, we need to save these into the database. So we'll go test author A, the same for B, and the same for C. So we have three of those authors saved in the database. Now we're going to say under test, and we're going to say age less than, which is a method that doesn't exist, and we're going to say 50. And we expect this to return an iterable of author, because that's what things like find all returns on the CRUD repository, and we'll call this results, or just result. And we're going to assert that the result contains exactly author B and test author C, not A, B. There we go, test author B, test author C, and no others. But this method doesn't exist, so let's create it, which we'll do with create methods. It's going to return iterable of author, and this is going to be an int, and it's going to be the age. And we're not going to provide an implementation, just this. So let's run this test and see what happens. Well, it passes, because Spring Data JPA has been clever enough to figure out that it can provide an implementation to this method. because age less than the name of the method is able to take a look at the author, see that it has an age instance variable, and then it's able to work out what that query should be when you pass in an argument to that method. So we can see here that we get a passing test, and we get test author B and test author C. Just to prove that it does actually work, if I change that to be test author A, which of course is Abigail Rose, age of 80, we should expect this to fail. And just like that, it does. Because we've got Thomas Cronin and Jesse A. Casey returned, and we're expecting Abigail Rose, which of course isn't going to be the case. Really very clever. Spring Data JPA is able to work out custom queries based on just how you name your methods in your interfaces. So Spring Data JPA being able to work out the implementation, to work out the SQL for a query just based on what we name the method is really very cool. But as you can imagine, it has its limits, and sometimes you have to kind of give it a bit of a hint on what the query should be. And that doesn't necessarily mean writing SQL, but it might mean writing HQL. So let me show you how to use the query annotation inside of Spring Data JPA. So let's say, for example, we wanted to have a method which done something a little bit similar to authors with age less than. Let's say we wanted to have the opposite of that, in fact. Let's write a new test here and go public void test that get authors with age greater than returns the correct authors, I suppose. So we're going to take exactly the same approach, create 3 authors in the database, and we're going to go under test dot, and we're going to create a method now. Now I'm on purpose going to create a method name that Spring Data JPA won't be able to work out. So we're going to call it find authors with age greater than. And then we'll pass in the age, which in this case we'll say 50, which of course will be the inverse of the last test. So we should only expect to get test author A back, Abigail Rose. We'll assign that to a variable, which is going to be iterable of author. And we'll call this one result. And then we will assert that the result contains exactly test author A and no other. Now let's create this method in the repository here, and we'll call this one age. So if we run this test, we should expect it to fail because Spring Data JPA doesn't really know what to do with this method name. There we go. So we've got big red stack trace, and it's saying along the lines of no property, find authors with age for type author. Of course there's not. So what are we going to do? Let's go over to the implementation. So let's go to find authors with age greater than. We're going to add an annotation, which is going to be at query. And inside of the query annotation, we're going to add our query. And now this isn't going to be SQL, but HQL. So it's going to be a little bit different. So we're going to say select A from authors, or author being the Java object type A, where A dot age is greater than the parameter, or the first parameter, question mark 1, that we have provided. So if we were to play this test now, we can see that everything passes absolutely fine. So we've not had to write any SQL. Actually, Spring Data JPA would still work out the SQL for you. But if you find you can't do a simple query such as age less than, and you do need to add some query in there using HQL, you would do so by using the @query annotation. So that wraps it up for Spring Data JPA. So we should have a pretty good handle on the persistence layer by now. So let's move on to creating a full-blown REST API. A full project from beginning to end. But before we do that, we need to understand a little bit about JSON and Jackson. So let's cover that now. Jackson is a super popular library for dealing with JSON in the Java programming language, and it just so happens to integrate so well with the Spring framework. Now, at its core, Jackson is there to take a Java object and turn it into JSON through a process called marshalling, and then do the opposite, take some JSON and then take the information and put it into a Java object in a process called unmarshalling. So to start, we're going to explore how Spring Web uses JSON, something we'll need to know to implement our REST API, and then we're going to explore the JSON object mapper in a little bit more detail. So let's start with Spring Web. So let's go over how Spring Web uses JSON with an example. So we have here a very basic web project. Take a look at the dependencies. We have the Spring Boot Starter Web, we have Lombok, and not a lot else. So what do we have? We have a book controller. We're going to get into controllers a little bit more in a moment, but this is similar to how we saw in our Quickstart application. So this exposes two endpoints, a HTTP GET endpoint on /books, which is returning a book object, we can see. And then we have a post mapping, again, also at /books, and this expects a book object. So you can see here, we've got a book object named book as an argument to the create book method, which is then got that post mapping annotation. And all this simply does is it's going to do a log.info with the book and then just return that same book again as JSON. So let's take a look at the book. This is a very basic ISBN, title, author, and year published in this case. That is our book, but that's it. That is exactly it. So let's start our application and then we'll hit it inside of Postman. Okay, so our application is up and running. Let me show you Postman. So Postman is a client for REST APIs, GraphQL APIs, and a few other things as well, but we're going to use it to hit the REST API. So you can see here we're using the HTTP GET method. We're hitting localhost 8080, which is where our application is running, and we're hitting /books. So if we click on send here, we can see that we've got a JSON object back. The ISBN, title, the Enigma of Eternity, author, Aria Montgomery, and the year published of 2005. This is our book object. But if you remember, we're not returning a JSON object, we're returning a book object from the method here, but Spring Web is able to use JSON to convert that into a JSON object, which is what we see right here. So that's our get method. What about our post method? Well, let's take this same object, shall we? Let's change the HTTP GET to a post. And now we're going to go into our body. We are going to send a raw body, a JSON body, and let's paste in that same book, maybe with the number 2 after it, just to show that we've got something a little bit different. And if we send this, we can see that it's returned exactly the same thing. The Enigma of Eternity 2 by Aria Montgomery. If we, I don't know, Aria's middle name is also Aria. So if we send that there, we can see Aria Montgomery. So what's happening here is this JSON object is being sent to our server. It's being converted into a Java object from a JSON object, and then it's being converted from a Java object back to a JSON object and then returned to us, the caller. So if we look at the code, we can see that, yes, we're expecting a Java object here and we're printing out a book. I mean, there it is on our logs. But then we're returning a book object. So seamlessly, Spring Web is working with JSON to convert to and from JSON and Java objects. And if we just double check that book object once more, there's nothing special happening on here. So let's look to understand JSON in a little bit more detail, and hopefully all of this should become clear. So we've seen how things were done in Spring Web, but let's see how to use the JSON object mapper directly. And we're going to do that via a test here. So we can see that we've got the code as it was before. We still have the controllers there. And we have the book objects. Now what I'm going to do is I'm going to create a test. And I'm going to call that test JSON tests. This is going to be a straightforward unit test. So I don't need to do anything too special in here. And I'm going to create a test. I'm going to call this one public void test that object mapper can create JSON from an object. Now this isn't a proper test, we're not actually testing anything, but I am going to be able to demonstrate to you how to use the JSON object mapper by doing this. So first things first, we need a JSON object mapper. So let's get an object mapper. Let's call it object mapper equals new object mapper. We have a JSON object mapper now. So we can convert to and from Java objects and JSON objects. So we want a Java object because we want to create some JSON from a Java object. In fact, let's update that test name to be Java object. Let's use that book. So we're going to say book, let's call it book. Let's import that. And let's create this book, which I happen to have here. So we now have a book available, The Enigma of Eternity, Aria Montgomery. Great. So how do we convert this into JSON? Well, it's pretty simple. We go object mapper dot write value is string, pass in the book, and we will get a result. Now, write value is string, you can see it's got a red underline. And the reason for that is it throws a JSON processing exception. So, for the sake of the test, add that to the signature of our test here. So we can see that we've got JSON processing exception. So in the case that is unable to convert the object into JSON, you will get a JSON processing exception thrown. However, in the case that it is able to do it, we'll get this result back here. And we're going to say assert that result. Let's import assert that is equal to, and then we'll just do a string it is absolutely not going to equal to begin with, and let's play this test to see what we get back. There we go. So it's expected this smiley face, but actually it was a JSON object that looks a little bit like this. And this is exactly what we would expect that Java object to look like in JSON. Now this isn't a proper test, but if we were to put that in there and then click play, we should get a green test. So really, to convert a Java object into a JSON object, it's as simple as calling objectMapper.WriteValue as string. So we've managed to convert a Java object into a JSON object, but what about the opposite? How do we convert a JSON object into a Java object? Well, again, it's pretty simple with the object mapper. Let's create a new test so I can show you it, and we'll call this one public void test that object mapper can create Java object from JSON object. Okay, so we're going to need a JSON object to begin with. So let's say a string, and let's just call this one JSON. And we're going to take this, even though it's a little bit ugly, we'll take this string from up here and we'll dump it straight into that variable. Great, so we now have got some JSON to play around with, and we know it represents a book. We want a book, so we're going to say book, and we'll call this one our result, is equal to, well, we're going to need an object mapper to begin with, so let's create an object mapper. We can do this if this is a proper test as an instance variable in the class, but we're not going to. Object mapper equals new object mapper. There we go. And now we're going to say object mapper dot read value. And we're going to pass in the JSON as the first value. And the second value is going to be the class that we want to read this as, which in this case is going to be book.class. You can see, as before, we've got that red underlined squiggle because we haven't handled the JSON processing section. So we're going to add that to our method signature there. Obviously, in production code, you'd want to handle that because it's more likely that you won't be able to turn a bit of JSON into a Java object rather than the reverse. And now let's do our assert that result. In fact, why not? Let's just take this book from up here because we know it matches. Put that there. And we'll say assert that the result is equal to the book. And if we run this test, we can see that converting from a JSON string into a Java object is as simple as that. So you've probably noticed already, but if we take a look at the JSON and then compare it against the Java object here, we can see that the attributes in the JSON object match the instance variable names of the Java object. ISBN, title, got author there, we've got year published. But what happens when you don't want them to match? What happens if you want to change them for whatever reason? Well, it's pretty easy again. So we're going to demonstrate this one by going over to our book. And we can see here we've got the year published. But let's say we just want that to be year in our JSON. Well, we would do an annotation on top of this of JSON property. If I can show you the arguments here. See, we've got these. We're simply just going to do the string in here of year. And just like that, anytime that we read a JSON object into Java or do the reverse, take a Java object and put it into a JSON object, year published will become year. So if we go back to our class, our test class, and run this, we should expect to get 2 failures. Okay, we do have 2 failures, and we can see unrecognized field, year published. So we can just change year published to year. So let's go down here, change that to be year, and do the same up here. And if we click on play, we can see that the test now passed because we're now using year instead of year published in our JSON. So we're starting to get the basics of the object mapper, and this is really good. Obviously, any annotations that we put on the book object, our JSON objects, will then be respected by the object mapper that's used by Spring Web as well. So bear that in mind. So what happens when we get an attribute in our JSON object that we just don't care about? Well, by default, everything will blow up. So if we go over to test that let's change this one here. So test that we can create a Java object from a JSON object. Now let's say that there is an additional, right at the beginning here, there is an additional attribute which we're going to call foo. And then the value for foo is bar in proper computer science way of doing things. So these escape characters are always fun. Okay, so I believe that would be valid JSON. So foobar is now in our JSON object that we're going to try and convert into Java. So what happens? What happens when we try and parse this book? We can see that we get an unrecognized property exception. So there's an unrecognized field foo. So an exception is thrown. But what happens when we just want it to pass? We just want it to ignore fields that it doesn't recognize. Well, we can configure that. So we're here in our book class. So all we need to do is add an annotation to the top of the class called JSON ignore properties. And then as an attribute in here, we're going to say ignore unknown equals true. The default, of course, is false. So if we run this, we can see the test now passes absolutely fine. Of course, you can configure lots and lots of other things inside of Jackson and the object mapper, but these are the ones that seem to come up most commonly. So at this point, you should have a really solid understanding of the fundamentals of Spring Boot and how it all works. So we're going to take what we've learned, and now we're going to do the fun bit. We're going to bring it all together, and we're going to build our REST API. So let's write our REST API. Let's set the stage. So the whole thing about a REST API is it's built on the concept of resources. The URL structure is all about resources. Now, we need to establish what resources we're going to use for our REST API. And as should be no surprise by now, we're going to be using books, and we're going to be using the authors of those books. So books and authors. Next, we're going to have to figure out where we're going to be persisting those books and those authors. And we're going to be saving those into a Postgres database today. In fact, we're going to build on the project that we've already got when we were putting together our Spring Data JPA. So we already have our repositories in place. We just need to build a service layer and a presentation layer in order to build our REST API. We already have a Postgres database, and it's already got a schema. So this is what our REST API might look like. Now, if you take a look here, we can see what they all have in common, which is this /books as the prefix. Now, bear in mind, it's books plural, never singular. That's the convention. So that's what this has in common. Now, books is the web resource that we're dealing with in this case. In the case of the author, we've already seen would be /authors, but more on that in a moment. So this is our CRUD functionality. So our create, read, update, and delete. Now, what's particular about the book is that we're not leaving it up to the database to generate any IDs for this. We are providing the ID each time, and that ID is the ISBN. Now, because of this, because we're providing the ISBN each time, the convention is to use the HTTP put for the creation. And we can see that here, /books, then providing the ISBN with a HTTP put. Now, if we were, like in the case of authors, leaving it up to the system to generate IDs, then we might use a post, but more on that in a moment. So we've got our create endpoint, and on a successful create, that will return a HTTP 201 created. And then we have our read one endpoint. So you can see here using a HTTP get /books and then the ISBN of that book. This will return, in the case that the book exists in the database, the book as a JSON object and a HTTP status 200. If the book doesn't exist, then you can expect an empty response body and the HTTP status 404. And then we move on to our read many books. So this will return a list of books rather than just one. Still using the HTTP method get, but this time just /books, no ISBN specified, returning a list of books, HTTP status 200, always. Even if it's an empty list, there's no books in the database, always get a HTTP status 200. Next, we have put again. So this is our update endpoint, and you'll see that the URL is identical to the create endpoint. So that's because it is. However, in this case, when we are updating a book rather than creating a book with put, we would expect a HTTP status 200, not 201 created, but otherwise exactly the same. And that's because for this particular object, we're always going to provide that ISBN. Then we have our partial update, which is the HTTP patch /books providing that ISBN. Now this differs from the put endpoint because the put endpoint, you have to provide all of the attributes of the object, and the entire object will be updated in the database depending on the attributes that you have provided. However, in the case of the patch, this is a partial update. So only the attributes that you provide will then be updated on the object in the database. So in the case of the book, if you only provide the attribute title in your JSON body, only the title will be updated for that book in the database. And you would get HTTP status 200 back on a success for this. And then finally, we have delete. So delete will delete your book in the database. So delete HTTP method here, /books, providing the ISBN, and this will return no response body whatsoever. So a HTTP status 204, no body. So that's the books. Let's take a look at the authors. So this is our authors. It's similar to books, but not quite the same. So if you look here, we've got, again, CRUD functionality, but to create the author, we're using the HTTP post /authors, no ID in the URL. And this is going to return HTTP status 201 created on a success and return the author object in the response body as well. But because we're not providing the ID, we're leaving it up to the system to determine it. We would use a post rather than a put like we've done on the book. And then we have the read one, which in the case of the author is HTTP get /authors with the ID, exactly the same. If the author is found, HTTP status 200 and the author, or if it's not found, then HTTP status 404. And then the read many for authors. So this will return a list of authors, just like the book, HTTP status 200, regardless if there's no books in the database or many. And that's fairly straightforward there. And then we've got the update for the author, the full update for the author. We can see we're using that HTTP put /authors with the ID of the author. So this will do a full update. So whatever the author object you provide in the request body for this one will be what's updated in the database. It will completely replace whatever author we have in the database with whatever we provided in the request body of that HTTP put. That will return a HTTP status 200 on a success. And then we have our partial update, which again works like the books endpoint. Whatever attributes that we provide in the request body of the partial update endpoint to /authors / the ID of the author will be updated in the database. If we just provide the name of the author, then only the name of the author will be updated in the database. HTTP status 200 on a success returned from this one. And then we have the delete endpoint, HTTP method delete /authors, the ID of the author, and this will return a HTTP status 204 no body and then delete the author in the database. Something you might be wondering about is, well, what happens if that author doesn't exist in the database? Well, it therefore doesn't exist. So the delete was, I suppose, successful. So it will still return a HTTP 204. Different schools of thought on this one, but that's what our API will be doing in this case. So that is the REST API structure that we're going to build. So with our REST API designed, let's get coding. Now, if we take a look at the different layers of our Spring application, we've already implemented our persistence layer. So we're going to build on that. So let's open up that project in our IDE and get started implementing our REST API. So here's our project as we left it from setting up Spring Data JPA. So we're going to now build our REST API. Where do we start? So we're going to go down to the pom.xml here and take a look at our dependencies. So we already have the Spring Boot Starter Data JPA. So we have everything that we need in order to use Spring Data JPA. We don't have everything that we need in order to build a REST API. So we're going to bring in another starter, and this one is Spring Boot Starter Web. Now, you'll remember this because we brought this in via the Spring Initializer in the past for our Quickstart project, for example. But I'm just going to bring it in via the POM file here and then click on the refresh button to make sure that dependency is available in my IDE. Okay, looks good. So we've already got our domain classes up there, our author and our book. We've got our repositories. That's all good. So our persistence layer is handled. Let's start at our presentation layer then. So I'm going to create a new package in here, and I'm going to call it controllers. Controllers being the pattern that we use in order to build our presentation layer, at least for a REST API. So I'm going to create a new controller in here, and I think we should start with the author. We've been doing that, so we'll go author controller. We'll call that a class. Now we're building a REST API, so we're going to put the annotation on top of here of REST controller. And then that allows us to start building. So we're going to build CRUD functionality out of our REST API. So this is going to have a create endpoint, a read endpoint, in fact, several read endpoints, a read one, a read many. It's going to have an update endpoint, and we're going to do a couple of those as well. We're going to have a full update, and we're also going to have a partial update, and we're going to have a delete endpoint. And I think the best place to start in this case is our create endpoint. We know from our design earlier that we're going to do this using a post endpoint, a HTTP post endpoint. So we're going to use the annotation here, post mapping. And then we're going to put in our endpoint for this one, which we can do with the path variable of our annotation. And we'll say that this one is /authors, and that's it. Now to create our actual method. So this is going to be public. And we are going to return from this method the author that we've created. So we're going to say author, and we're going to call this create author. But of course, we expect a author JSON on the request body for this one. So it's going to be read in, it's going to be converted using Jackson into a Java object, and that Java object is going to represent an author. But we need to tell Spring about this. So we're going to put the @requestBody annotation onto that variable there, and that's going to tell Spring to look at the HTTP post request body for the author object represented as JSON. It'll convert it into Java for us. And now we have to go about creating, actually saving the author object in the database. So that's when we get into our service layer. So we've already got our persistence layer. We're writing our presentation layer, but we need something to link them together. We need a service layer. So I'm going to go over here and I'm going to create a package for our service layer, calling it services. Now it makes sense, I think, to have an author service to deal with authors. So we're going to have an author service represented as our interface here. Add that. And in the author service, we are going to create a method, a public method, of course, and it's going to return an author, and it's going to be called create author. And it's going to take an author, which of course is the author to create. Which seems fairly reasonable, because what we can then do is inside of our author controller, we can inject the author service, which we're going to do like so, author service, and we'll need a constructor. And that, of course, will inject our author service in order for it to be used, and then we can call the author service .createAuthor. Okay, so we haven't created the service yet, but in theory, this is all that you would need in order to create that author in your database. However, this is far from perfect, and perhaps the biggest reason why is that we are using, in our presentation layer, the author object. So if we take a look at the author object, we can see that actually this is an entity. This is an entity that should exist in our persistence layer and our service layer, but go no further than that. We don't want our presentation layer to have any knowledge of how our persistence layer works. So one of the ways of dealing with this is we would use a DTO, or a data transfer object. So the service layer would return still our entity, but in our presentation layer, we would map that over to a DTO, and that DTO would be the thing that is sent and also expected in things like request bodies on our presentation layer. And then that decouples our presentation layer from our business logic and our persistence layers, because we have that mapping layer in between. So I'm going to, before implementing our service, create in our domain here a new package, and I'm going to call this one DTO. And in our DTO package, I'm going to create a class here, and I'm going to call this one author DTO. Now, the DTO is going to be a POJO, a plain old Java object. So it's going to have that data. We're using Lombok again. So we have all of our getters and setters, equals, hash code, etc. All ours constructor, We'll have a noArgs constructor because that's needed for Jackson. And we will have a builder here. I mentioned Jackson for the noArgs constructor. Typically, Jackson will create an object using a noarguments constructor and then use getters and setters in order to set the values on the object. So always make sure that objects that you'll be using with Jackson have that noArgs constructor. But what should the author DTO look like? Well, actually, no surprise, it should look exactly like the entity. So if we go over here, it should have these fields. Shouldn't have anything like at ID or at generated value or at entity. Of course, that's all to do with Spring Data JPA, and this object doesn't need to know anything about it. So we now have this ID, name, and age on our author DTO here. Excellent. So we can now start to use this. So we're going to go up to the author controller, and rather than expect an author, we're in the presentation layer, so we're going to expect an author DTO. We try and import this. And we aren't returning an author, we are in fact returning an author DTO. Here's our challenge. Our create author method expects still an author object. Should we change this to be an author DTO, or is it okay for it to be an author object? There's different schools of thought on this, but ultimately I deem it okay for the service layer to deal with entities. It's your business logic. So some knowledge of the underlying entities that the persistence layer uses isn't the end of the world. If you're doing something completely 110% by the book, you might look to decouple them, but I consider it to be okay in this case. But we do, of course, want to separate our presentation layer from our service layer and from our persistence layer via the use of the DTO. So we need to convert our DTO to an entity in this class. And just to make it super obvious that we are dealing with an entity, let's go over to the author here and let's rename this from author to author entity. Let's rename our test class as well. Yeah, go for it. Let's rename all of those. Great, and let's do the same for our book while we're here. Book entity. Great, and just to keep things organized, let's create a new package in here, and let's call this package entities. Excellent. So we have our author entity and we have our author DTO as well. And you can see they're pretty similar. Now we could write the mapping from one to the other manually. However, as this is a fairly common pattern that people tend to use, there is a lot of libraries that handle this for you automatically. And one such library is the Model Mapper library. You can take a look at the documentation online here, including the Getting Started and the user manual. But ultimately, this is going to allow us to convert from our DTOs to our entities. It's going to map from one class to the other. So how do we use the Model Mapper? Well, the first thing that we need to do is import it. So we're going to go down to our dependencies here, and we'll put it, I don't know, right here. And as before, let's just refresh this to make sure we have it on our class path. Excellent. So we can now use the Model Mapper. So the Model Mapper is an object, so we need that in order to use it. And a nice clean way of doing that, as we've seen in the past, is create ourselves a config directory. And we're going to create a new class in here, and we'll call it Mapper Config. This, of course, is a configuration class. And we're going to create a bean. And this is going to be a Model Mapper. Let's call it Model Mapper. And we're going to return a new Model Mapper. Great. And just like that, we have access to the Model Mapper inside of our application context. How do we use it? What's a nice way of using it? Now, I'm going to create ourselves here a new directory, and I'm going to call this one, or a new package, I'm going to call this one Mappers. And to keep things nice and clean and to allow us to swap out to potentially use a different mapping library later on, I'm going to create a Java class, which in fact I'm going to create a Java interface here, and I'm going to call this Mapper. And this is going to encapsulate all of the logic for mapping for our application. And this mapper is going to deal with two classes, which could be different. So we're going to use generics here. So we'll have class A and we'll have class B. And we're going to have two methods, I think, on this one. So we're going to have map2, which is going to return the type B. We'll call it map2, and it's going to take A. And then we'll have the inverse, which is map from, which of course is going to return A, and it's going to take a B.
So we can implement this interface with beans, and then we can inject those beans as and when they're needed, and then that allows us to swap things out. So we'll need an author mapper. So we're going to go up here, create a new directory actually first. We'll call this one import to keep things nice and clean, and we'll create a new class, and we'll call this one author mapper import. And we'll implement the mapper, and we're going to go from an author entity to an author DTO. Cool, let's implement our methods here, release the stubs of them, and now we can go ahead and implement them proper. So we're going to need that model mapper from earlier. So let's go private model mapper, and then we're going to need a constructor. So in fact, let's just generate that constructor. Great, so we now have access to that model mapper, but how do we use it? Well, it's actually fairly straightforward. So we're going to use our model mapper in here, and we're going to say map, and we're going to take that author entity, and we want to map that to an author DTO.class. And we'll return that. And on the other method, we want to do the inverse of that. So we're going to still return, still use our model mapper, and we're going to map, but in this case, from our author DTO to an author.class. Author entity now, isn't it? There we go. Great. And just like that, we have a mapper for authors going from an author entity to an author DTO and then back again. We want to be able to inject this, so we're going to say at component on the top there. There we go. This is now a bean. So let's just copy this and go back to our controller. Now, in addition to our author service, we're also going to want an author mapper in here. So we're going to, declaring our type as this mapper going from author entity to author DTO, we're going to call this one author mapper. And we'll just need to make sure this is in our constructor as well. And then we'll assign this.author mapper to author mapper. Great, so we now have our author mapper. So let's use it, author mapper. And we will map from the author DTO as provided. And then we'll get to pass our author entity to our create author, which is going to return an author entity again, which we're going to call saved author entity in this case. And then we can return, using the author mapper again, map to the saved author entity, which will of course return an author DTO, which is then returned to the caller. This might seem like a lot of hard work for not a lot of value, but as your application grows, it's really important to have it as manageable as possible, and decoupling your presentation layer from your service layer and your persistence layer is going to be one of those ways that you can make it more manageable. So by showing you this now, you might not necessarily need this if you're doing like a really small project for yourself, but it's really worthwhile knowing for when you start to work or if you are working on those bigger projects. So now it's time for implementing our service. So we're going to go to our services here. We'll create our import directory. And inside of here, we're going to create an author service import. And this is a service, so a bean. So we have our author service import. And this implements our author service. Great, so we now have to implement our create author. And we do this, of course, via our author repository. So let's generate our constructor. Great, so we now have access to this author repository, and this is an example of a pass-through method, more or less. So we're going to take our author entity, and we're going to take author repository.save on our author entity like that. And then, of course, that's going to return an author entity because that's the default of what Spring Data JPA does. Okay, So we now have our persistence layer implemented. We have our service layer implemented, which just does a pass through. And then we have our presentation layer implemented as well, this being a REST controller with a post mapping at /authors. So in theory, everything should work now. So let's start up our application and see this working inside of Postman. And then I'll show you how to test this with mock MVC. So let's start up our application. So we're going to, first things first, make sure that we have a running database, because that's something we're going to need. So we're going to do docker ps to see what's running. Nothing's running. So we're going to docker -compose up, making use of that docker compose file on the root of the project that has a Postgres database in it. Great, that's up and it's running. So we're going to go to what's currently called database application. We'll need to rename that, but let's run this. Okay, that's the application up and running. Let's now open up Postman. So here we are in Postman, and we know that our application is running on localhost 8080, and the endpoint that we need is /authors being called with a HTTP post. So we can now see that we have an author object. So remembering an author object has ID, name, and age. We're not going to use the ID in this case because we've already set up Spring Data JPA to generate those IDs for us. So we're going to provide the name of Aria Montgomery and the age of 80, and this should create our first author in the database. So let's take a look, see if this works. There we go. We can see we've got a HTTP 200, which isn't necessarily what we'd want. We'd want maybe a HTTP 201 created. So it's working, but we can tweak that. And we've also got here our first author created. So the ID of 1 generated for us, the name Aria Montgomery, and the age of 80. So that looks really good. It seems to be mostly working. That's absolutely great. So it looks to be working, but let's actually now write some tests for this. So it looks like our first endpoint was working, but let's now prove it. So we're going to do that with an integration test using mock MVC. So first things first, let's go down here and let's create for ourselves a new package in our test directory called controllers. And we'll create a test in here and we'll call this one author controller integration tests. Okay, and this is going to be a test, which is an integration test. So we're going to need a running Spring application, albeit a test version to test on. So we're going to need to add the Spring Boot test annotation. Now we also want this to be clean between each running. So let's add our dirties context annotation. Let's not forget our extends with to make sure that everything is nice and integrated. So we need the Spring extension class used in there as well. And we're also going to want mock MVC. So we can add an annotation, which is autoconfigure mock MVC, which creates an instance of mock MVC for us that then places it into our application context ready for use. So let's get hold of these objects and then we can actually start writing the test, because mock MVC is a super powerful way of testing your controllers. So then let's get hold of these objects. So we're going to need mock MVC first of all. So let's say mock MVC, which is going to be private, of course, mock MVC, mock MVC. And let's now create ourselves a constructor. Because we're inside of our tests and we want to auto wire this or inject it, we're going to have to use the auto wired annotation. There we go. So we now have access to our mock MVC object. We're also going to need a couple of others for this, but let's start writing our test and we'll add those as we need them. So we'll write our first test here, and this will be a really basic one. So we're going to call this one test that create author successfully returns HTTP 201 created. Great. Now we can start using mock MVC. So mock MVC is a little bit complicated. So let's start with mockmvc.perform. And inside of our perform, we need to use a request builder. So the request builder that we want to use is post in this case, because we're using a HTTP post, and we're going to post to /authors. But that's not where it ends. We're going to want to specify the content type, which we know is, if we go to media type, is application JSON. And then we want to add a request body, which we can do with the content here. Now, content takes a string, and we know that we're posting a JSON object to this endpoint. So we need to get hold of a JSON object. Well, of course, we need an object mapper. So let's get hold of one. So we're going to declare one up here, private object mapper, call it object mapper. Let's import that. And now we need to initialize this. We don't have an object mapper in our Spring context, so we'll just create one. This.object mapper equals new object mapper. Great. So we now have access to our object mapper. Let's use it to generate some JSON for our author object. So we have our test data util, and we know that we can create a test author. So let's do that. But let's also set our test author ID to null, because we now know that it auto generates it for us when we use Spring Data JPA. So we have our author entity. Let's make it into JSON. So we're going to go object mapper dot right value is string, passing in our test author A, and that will assign that to a string called author JSON. And of course, we'll need to add the exception to the method signature. So we now have our author JSON. Let's put that in content. Mock MVC also throws an exception, so we need to add that to the method signature there. So exception should cover everything that extends exception. So that's not where it ends. We now need to add some assertions to this. So we add assertions like so. We need to go down to here, and then we need to go and expect, and then we'll need to have a result matcher. So the result matcher we're going to have in this test is status and is created. And that's all we're going to do for this test. We can actually go ahead and write additional tests to use JSON path, so we can actually test the response body for that, but we'll do that after. First thing, let's run this and see what we get. Okay, we have a failing test. That's what we'd expect, but why is it failing? And it's failing because you can see there the body that's being returned. That's very good. That's a response object. HTTP status 200, bear in mind. Status expected a 201, but was a 200. So this allows us to update this. So we're going to go over to our controller. And rather than just return the author DTO, we're going to wrap that in a response entity. And that response entity allows us to control things like the status code of the response. So we can return a new response entity, passing in our object, but then as our second parameter, we can then do HTTP status created. And if we were to run our test again, we can see we now get a green test. We now respond with a HTTP 201 rather than the 200 that we had before. So let's go back to our test and we'll write a second one, but this time using JSON path. So we'll go to integration test here, and I'm going to copy this test, being a little bit lazy. We can always refactor afterwards. Test create author successfully returns saved author. So we're going to do exactly the same thing as before. We're going to use test author A. We're going to write the value to the JSON there, and then we're going to post it to /authors. We're not going to test the status in this test. Instead, we're going to use JSON path. And this is where things get interesting. So in JSON path, you would usually use an expression to denote where to look in the JSON. We'll start with $, and then we'll say .id in order to check for the ID attribute in the root object, which in this case we want to do an assertion on, which is a number. So the ID is going to be generated for us automatically, so we can't necessarily assert that it's going to be a specific number, but a number should be enough for now. Now let's do another and expect, and we're going to use the JSON path again. We're going to use the name, and we can use the value method on this, and we know that this is going to be equal to Abigail Rose, but for the sake of a failing test, let's do a triple question mark there. So that tests our ID, that tests our name. Let's also test our age, which we know to be .age, and again, this is going to be the value that we don't really know right now. So let's run this test and see what we get. Okay, we got ourselves a failing test. That's good. Let's go down here. Here's our failing assertion, expected triple question marks, and got Abigail Rose, which is exactly what we'd expect. So let's put that in there and run our test once more. Okay, another fail. That's good. Okay, expected triple question marks, but got 80, which of course we know Abigail Rose to be 80 years old, which of course matches our create test author here, Abigail Rose, age of 80. So if we now run our test once more, we should expect a passing test. There we go, looking good. So it looks like our endpoint is working absolutely fine. We've seen that in person, and we've also written mock MVC tests for it that test both the status code is returned, did a little tweak there, and we also make sure that a particular object structure is returned as well. So all very good stuff. So with the author create endpoint out the way, let's quickly do the book one as well. So that's the create endpoint done on the author controller. Let's now do the book controller. So first things first, we're going to need to create a controller class for us, which we're going to call book controller. There we go. And we need to put the app REST controller annotation on the top there, because of course we are dealing with a REST API controller. Now let's create this endpoint, which we know is going to be a put mapping to /books, and then the ISBN is going to be in the path. So we're using that put mapping so we can specify the ISBN every time we create a book. That was a design decision that we made. So we then need to do a public, and we will return a response entity wrapping a book. Well, at this point, we have a book entity. So we will put a book entity in there for the moment, but let's replace that with the book DTO right after we've done this method. So we'll say create book. And we're going to need to get a handle on the ISBN that's in the path. So let's do a path variable, the name of which is ISBN, and let's assign that to a string called ISBN. Okay, now what are we going to do for the implementation? Well, before we do the implementation, let's get hold of that book DTO so we're working to the right objects here. So let's go to our domain and then go into our DTO. And inside of here, we're going to create a new class. And we're going to call that book DTO. So this is going to be a plain old Java object, a POJO, much like our author DTO. So we're going to have here a data annotation using Lombok, an all R's constructor, a no R's constructor, and we'll have a builder in there. Why not? Now, what is our book DTO going to look like? Well, exactly the same as our book entity. So let's go over to our book entity. Of course, the difference is the book entity references the author entity, whereas our book DTO is going to reference our author DTO. So we're going to borrow this, go to our book DTO, paste that in. Now, we're not going to need the ID. That's from Spring Data JPA, and we're not going to need the many-to-one or the join columns. In fact, let's get rid of those imports there. Now, instead of an author entity, of course, we know this is going to be an author DTO, but we'll still call it author because that seems relevant. So we've now got our book DTO. Let's go ahead and use it back over in our controller. So we're going to instead return a response entity book entity. We're going to return a response entity book DTO, and let's import that. Wonderful stuff. So let's start implementing our method here. So first things first, we're going to want to map our DTO to our entity so we can use it in our service and our persistence layers. So we're going to need a mapper. So we go down to our mappers. We've got our mapper implementation for author there. Let's create one for book. So let's go new Java class, and we'll call it book mapper. And this is going to implement mapper, going from a book DTO, book entity, to a book DTO. Lovely stuff. And let's implement the stubs of these methods. Great. So for this, we're going to need our model mapper. So let's get a handle on that as well. So model mapper, and that's a private, of course. And we can then inject that with our constructor injection. So let's use our IDE to generate this for us. So we'll go generate constructor, and yep, we want that model mapper in there. Great. So we now have access to our model mapper. Although this isn't technically a bean quite yet, so let's put our component on the top of this. So we'll now use our model mapper in our method implementation. So we're going to say return model mapper.map, taking the book, which is a book entity in this case, and then we will convert that to a book DTO.class. That's the first one done. And now for map from, so we're going to say model mapper.map, going from the book DTO, and that will map to the book entity.class. Let's return that. Great stuff. So that's our mapper. Let's now use it in our controller. So let's go back over there. and let's get a handle on it. So we're going to need a private mapper going from book entity to book DTO, and we'll call this one book mapper. Let's import everything that we need. Great, and let's use our IDE to generate our constructor for us so it's injected. Great, so we now have our book mapper. So let's get hold of our book entity. So we're going to say book mapper.map from. We haven't yet got a handle on the request body there. Forgotten about that. So we're going to say request body. And of course, we expect a book DTO to be put in the body of this call. So we're going to say book DTO, and we'll just call this one book DTO. Great, so we now have access to that book DTO. So we're going to put that in the map from, assign that to a variable, and that is our book entity. So to create a book, we're going to need to interact with our service layer, of which we currently don't have one for books. So let's go down to our services directory here, and let's create in there a new interface in this case, and we're going to call this one book service. And book service at the moment is going to have a single method, and it's going to return a book entity, which is the book that was created. And we're going to call it create book. And it's going to take the ISBN of the book to be created, bearing in mind we specify that each time. That was our design decision. And then it's going to take the book entity, which is the book to create. Now, if we create an implementation for this, let's create a new class. We'll call this one book service impl. And this, of course, will implement our book service. And we'll get a stub for the method, and we'll put @service annotation on the top of the class there, denoting it as a bean. So how do we create a book in the database? It's fairly straightforward. We need to handle on our book repository. So let's declare a private book repository inside of our class there. And now let's create for ourselves a constructor using generate constructor. Okay, great. We now have access to our book repository. So book repository.save, and that will take a book. However, we want to make sure that the ISBN that's on the book entity object is exactly the same as the ISBN provided in the method. Because if they're not, then we can get into a situation where we are creating a book with a incorrect ISBN, or at least a different ISBN specified in the book entity object and the URL. And that can lead to all sorts of problems. So we're going to simply say book.set ISBN, specify the ISBN that's provided, and we can then be sure that the book that we save, the book that we create, will always have the ISBN provided in the URL. The one on the body will be overridden. So we're going to return that, and then that will return our book entity, and that simply is our create book method. So let's go back. So we're going to need to get hold of our book service. So we'll say private book service, call it book service, and of course we're going to need to drop this into our constructor because we want it injected. So let's say this.bookService equals book service. Wonderful stuff. We now have access to our book service. So let's use it. Book service dot create book, and then we'll pass in the ISBN from the path, and then we'll pass in the book entity that we converted from the book DTO that was in the request body of that call. So let's assign that to a variable called saved book. So we now have a saved book entity. We of course need to return a book DTO from this. So we're going to use our mapper once more. Book mapper dot map to, and then that will take the saved book. And that is then going to be our saved book DTO. Let's call that our saved book entity just to make sure that there is no confusion. So now we'll simply say return new response entity, passing in the saved book DTO, and we're going to say HTTP status. And because we are creating, we are going to return HTTP status created or 201. And that is our create book method implemented. So let's start our application and go over to Postman to test it out. But actually, before we do, let's rename this from database application to books API application. There we go. And let's start our application up. Great, the startup absolutely fine. Let's go over to Postman. Here we are in Postman, and we can see here the request to our new endpoint. So we've got here our HTTP put going to localhost 8080 where we're running, and then we have /books and then the ISBN of the book that we want to create. And then in the body here, which is JSON, we have an ISBN, a title, and we're leaving the author as null. Now we can manipulate the nested author. However, we're going to leave setting that up until a little bit later and just use the default configuration for the time being. So we expect a book to be created with the ISBN provided and also the title. So if we go ahead and click send, I'm expecting a HTTP 201 created and for that book to be returned. Okay, so we've got a HTTP status 201 created. That is great. And here is our book, ISBN, and then the title. So something I want to double check while we're here, and we're going to have to create a new book for it, is that the ISBN in the URL overrides the one in the body. So I'm going to change this one to be, let's say 999, and then I'm going to change the ISBN in the URL to be 2. And I expect the one in the URL to be used because that's what we set on the body of the book entity when we save it in our service layer. So we're expecting a HTTP status 201 created and for the ISBN of the book to be the one specified in the URL here, not the one in the body. So let's try this out. Looking good, 201 created, and it's ending in 2, which is the one specified in the URL. Everything looks to be working fine. Let's now write our mock MVC test for this. So here we are back in our code. Let's go down to our tests, and we're going to create a new class in here, and we're going to call it our book controller integration tests. And we'll just put the necessary annotations on the top here. It's a Spring Boot test. We're extending with a Spring extension to make sure everything is nice and integrated. We have our dirtiest context, so our database is cleaned down with each test. And we'll auto-configure our mock MVC so we can get a handle on that. So that's the first place we're going to start. So we'll say private, and we'll say mock MVC. Call it mock MVC, and then we're going to need to get a handle on this. So let's generate our constructor. And because we're running in our tests, we need to specify the auto-wired annotation to make sure that everything is injected. So now for our first test, and we are going to use a test annotation here, go public void, and we'll call this test that create book returns HTTP status 201 created. And now for our implementation. So we are going to need to get hold of a book to create. So we're going to need a book DTO. So if we go to our test data util down here, we can see that we've got, much like we did have before, simply got create test book A, and that creates a test book entity. We, of course, want to create a test book DTO. So I'm just going to copy this, and we're going to return a book DTO. We're going to call this create test book DTO A. And that's, of course, going to require a author DTO specified there. Great, so we now have a create test book DTO A, which is going to create for us a book DTO. It's very similar to our book entity here, which I'm just going to rename to create test book entity A, just to differentiate it. So let's go back to our test. And we'll say we've got here a book DTO. I'm going to call it book DTO. And we'll say create test data util. And we won't pass in an author. So we now have our book DTO, but of course our mock MVC is going to expect JSON. So we're going to need that object mapper, much like our author controller integration. So we're going to say private object mapper. Call this one object mapper, and we'll create it in our constructor. So this object mapper equals new object mapper. Great, so we now have our object mapper. So we're going to say object mapper dot right value is string, passing in our book DTO. Now, of course, right value is string is going to throw an exception. So I'm just going to say throws exception. We'll use the top level exception, because we know that mock MVC also throws exception, so that should cover everything. And let's assign that to a variable. And we'll say, we'll call that create book JSON. So we've got our create book JSON. Let's now use our mock MVC. So let's go over to the author controller integration test here and just borrow from there because it's quite elaborate. And we're going to say mock MVC perform, not a post for this one. It's going to be a put, and it's going to be to /books. And then it's going to be the ISBN. So we're going to say book DTO.getISBN. And the content type is application JSON, and then we're going to pass in our book JSON there, and it's going to be HTTP status is created. So that should be everything we need for this test. Let's go ahead and run it. Looking good to me, everything passes fine. So that's the HTTP status code. Let's make sure that the created book is returned in the body. So let's borrow this test here. And we'll say test that create book return HTTP status. We'll say the created book. So it's going to be very similar to our previous test, but of course the expectations are going to be slightly different. So let's go back to our author controller integration test here, and we will borrow the specific incantation that we need for JSON path, and we will set it up for our books. So we want to make sure that the ISBN matches the ISBN that is provided. So we're going to say value, and it's going to be the same one for our book DTO. So we'll say book DTO dot get ISBN. And we want to do another expectation here. And the second expectation is going to make sure that the title of the book is exactly the same as the one specified there. So this is going to make sure that our saved book is returned. Let's run this test. There we go, it's passing absolutely fine. And there we go. We have implemented and tested our create book endpoint. So let's now implement our read many endpoints on our authors here. So we've got the authors controller. Let's go ahead and create a new endpoint. So we know that the endpoint for read many is a get endpoint. So we're going to use get mapping. And the path for this is going to be /authors, just like before. Let's go public. We're going to turn a list of author DTOs, and we're going to call this one list authors. Don't need to do anything special in the arguments of this method because of course the read many doesn't have an ID in the URL or anything like that. So we're going to take our author service. Let's call it find all on the author service, shall we? And this will expect to return a list of author entities, and we'll call this one authors. And then we'll need to convert the author entities into author DTOs. So we'll do that with authors, stream.map, and then we'll use the author mapper. And then we will do a map from. And we'll collect to list. Oh, of course, it's not a map from, it's a map to in this case, isn't it? There we go. So this will do everything it needs to return a list of authors. Now, bear in mind, it will return everything in the database, which is definitely not the most optimized. If you had 5 billion rows of authors in the database, it would take a long time and crash a system or two, I imagine. But we'll cover that when we get onto pagination, which is a way of getting around that. We'll do that a bit later, though. So we need to implement this find all method. So let's create the method in the author service. It's going to return a list of author entities, and it's just called find all. Go down here and let's generate. Okay, so we're going to take our author repository and we're going to go find all. It returns an iterable. Now we could decide to use an iterable throughout this application, but I prefer the list API for this case. So we're going to convert this into a list, encapsulating it in our service layer here. So we're going to do that with this incantation. So we're going to use stream support. We're going to call .stream on there, passing our split iterator, and we are not going to be parallel, so we'll pass in false, and we'll collect to list, returning this, and put that on a new line so we can see everything. So we'll use stream support to take the split iterator from the find all, which is an iterable, and then we will make sure, we don't need it parallel to the convert it. So we will simply just call the collect on the stream that's produced with the toList collector. So we now have a list of author entities. So let's go to our author controller, and all seems well there. So our list authors endpoint should in fact work. So before we write tests for this, let's just start our application and see if that's the case. Okay, the application is up and running. Let's go over to Postman. So here we are in Postman. We can see we're using our HTTP GET. We've got localhost 8080/authors, and yeah, that's all we need. So let's send this request and see what we get. Okay, great. We've got HTTP 200, okay. And then we've got a list of authors, and there's our Aria Montgomery, ID 1, age of 80 that we created earlier. So that seems very good indeed. Let's go over and write our mock MVC test for this. So we know that it always returns a HTTP status 200. So let's create a test for that. So we're going to say @test public void test that list, not books, list authors returns HTTP status 200. Okay, and we're going to borrow the mock MVC perform from up here, but we aren't using a post, of course. We're using a get to /authors, and we don't have any content to send, so there's no point in providing that. Okay, perform, of course, throws an exception. Let's add that to the method signature. Okay, great. Now for some expectations, and expect mock MVC result matches dot status, and the status, of course, is okay. So we should expect this to pass. Looking good. So we now need to go on to the body, I think. So test list authors returns list of authors. Okay. So rather than, we're not going to expect on is okay in this case, we are instead going to follow the JSON path example, and we'll paste them there. But of course this returns a list, so rather than it be just ID, it's going to be .0. It's going 0, not .0, but $0, .name, and then $0. .age, 0 being the first thing in the index, the first object in the list, but of course the list is going to be empty, but let's have a look. Okay, so there's no value at that path, so we need to create an object in the database, because we know between each test our dirty's context annotation is going to completely clean down our database. So what's the best way of creating something in the database? Well, I think the best way of doing it in this case is just to get a handle on our service layer. So we're going to go private, author service, and then we will inject the author service using constructor injection, and then we'll go list.author service equals author service. Great, so we can now save entities in the database. So let's do test data util dot create test author entity A. Let's assign that to a variable. And then we can now go author service dot create author, passing in our entity, and we don't need to assign the entity to anything, don't need to assign it to a variable. So providing I've got my JSON path correct, this should now pass, because the author has been created in the database by calling the service directly. Great, looking absolutely fine. So we now know that the object is returned as the first element in the list when it exists in the database. So that is the list all or the read all or the find all endpoint for our author. Let's now do our book. So let's now implement our list books endpoint. So we're going to go over to our book controller here, and we're going to go get mapping. The path, of course, is going to be /books. And then we're going to go public list of book DTO to be returned. And we'll just say list books is the name of the endpoint. Don't need to provide any path variables or anything for this one. And let's import the class of list. Okay, so we are going to need to call book service dot, well, we'll call it find all. I think that was the convention we were using before. And that's going to turn a list of book entity. And we'll just call that books. Of course, find all doesn't exist, and it's better to use pagination, but we'll use a straightforward list for the time being. So we now have our list of book entities. What do you want to do with them? Well, we can use the mapper. So we're going to go books.stream, and then we'll map them, and we'll use our book mapper. And it was map2. And then we'll collect that as our list and return that. Let's Let's put on some new lines. Great, so very, very similar to our authors implementation. Let's now implement our find all. So let's create that method, returning a list of books. Go to the implementing class down here, get the stub of our method, and we'll call book repository dot find all, again returning that iterable, so we need to do the incantation of stream support dot stream, and that expects a split iterator. We don't need to be parallel. And then we will collect that to list and then return that. So we now have a list of all of the books in the database being returned by find all. So that in theory should be enough for things to work. So let's now restart our application and hit that in Postman. Okay, let's go to Postman. So here we are in Postman. We can see we're using the verb HTTP get here, and we've got localhost 8080/books is our URL. So if we hit send, we should expect to get that one book back that we saved earlier, but in list form. So let's hit this. There we go. And there is the shadow in the attic and the ISBN of the book that we created earlier. So that seems to be working fine. Let's now write the mock MVC test for this. So here we are in the books controller integration test. So we are going to write the HTTP status 200 test. So every time that we go ahead and hit this endpoint, we expect a HTTP status 200 back. So we're going to say test that list books returns HTTP status 200. Okay. The URL doesn't have the ISBN, and we're using HTTP GET. Of course, we're not providing any content to this endpoint, and we expect an is okay. So this should be enough to test that. Okay, looking good. That's working absolutely fine. So let's now implement the test that tests for the response body. So we need a new test, and we'll call this one public void test that list books returns book. This will throw an exception as well. Okay, so let's borrow this from up here. But of course, we are going to use our matches, which are similar to what we had on our create endpoint. So rather than it being just a plain object, though, this is going to be a list. So we're going to change this to be 0. But of course, because of Dirty's context, we need to create that book in our database. And for that, we're going to need our book service. So let's create our book service here. Book service. Book service, and we'll need to inject this via our constructor. So let's do that there, and then assign it this dot book service equals book service. Great, so we now have access to our book service. Let's create our book. So we're going to say test data util dot create test book entity A. Not going to pass in an author. We'll get onto the nested object again in a little bit. So test, we have a book entity. So now we're going to say book service dot create book, passing in the ISBN, which we'll get from our test data, and then we'll pass in our book entity. So at which point we should have our book created in the database, and we should expect this test to pass. So let's play this. Passing absolutely fine. So we now have a list books endpoint. Let's now get on to the retrieve, the find one for authors. So let's now implement our read one or our retrieve one on our authors controller. So let's implement our method. So we are using a get mapping, and the path for this one is going to be like before /authors, but this one is going to have an ID in the path. So we'll now need to go public, returning a response entity because we want to have control over the response status code. And it's going to return an author DTO. Okay, and we'll call this one get author. We're going to need reference to whatever the ID that's passed in the URL. So I'm going to say @path variable passing in the label, which we know to be ID, and we're going to assign that to a long because it's a numeric ID for authors, and we'll just call that ID. So we now have reference to it. So whatever is provided in the URL path here will be put into this variable here. Great. So we're now going to call our author service, and we're going to say find one. We're going to say, yeah, we'll say find one. And we're going to pass in the ID of our author there. And we expect this method, which currently doesn't exist, to return an optional because either the author will be found or it won't. And we want to return an author entity because it's coming from our service layer. And we are going to call this one found author. There we go. So we now have an optional. So in the case the author exists, we'll get an optional with the value of the author. And in the case that the author doesn't exist or can't be found, then we are going to get an optional empty. So let's convert this into what we expect, which is a response entity. So we're going to go found author.map, and in there we're going to have our author entity. Now in the case that we have found an author, we want to convert the author entity into an author DTO. So we can use our mapper to do that. And we'll say map to, passing in our author entity. We'll assign that to a variable author DTO, and then we're going to return a new response entity containing our author DTO with the HTTP status of OK. There we go. And in the case that we get an optional empty, we want to return a new response entity, but in this case it's going to be a HTTP status of not found. And we will return the result of that from our method like so. Now, this is all well and good, but we don't have a find one method in our service layer yet. So let's create that. So create method in our author service. Great. So let's now go down to the implementing class and get the stub for this method. And it currently returns an optional empty. That's no good. So we're going to say author repository dot find by ID. And we'll just pass in the ID there, and we'll say return. It is just a pass through in this case. So with that being done then, it looks like we are in a position to test our application. So let's restart our application and hit it in Postman. Okay, that's restarted absolutely fine. Let's flip over to Postman. So here we are in Postman, and we can see the results of our list authors here. And we can see that we've got one author in the database, Aria Montgomery, with the ID of 1. So bearing that in mind, I'm going to borrow the URL, open up a new tab here, put that in, and then put the ID of 1 in the URL like so. And if we send this, we get a HTTP 200 back and Aria Montgomery. That's perfect. But what if we were to change the ID to be, let's say 99 and send that? For HTTP 404? Perfect. 404 not found. So it looks like it's working absolutely fine. Let's now write the test for this. So we're going to go to the author controller integration tests, and we will borrow the HTTP status test from up here, and we'll tweak it for our needs. We'll test that get author returns HTTP status 404 when author exists. So we're going to say /authors1, and we expect it to be is okay, but of course we need an author created in the database for that. So we're going to borrow from our list authors test, which does that for us. So this is going to create an author in our database, and we should expect HTTP status 200 okay here. So let's run this. Working good. Let's just change that to be 99 and just see if we get a failing test. Okay, looking good to me. Okay, so we'll now need to make sure that we get HTTP 404 when it doesn't exist. Let's copy that. Let's not create anything in the database. And then let's change that to be 99. Author returns HTTP status 404 when no author exists. And we expect it to be is not found. Let's run this and see what we get. Looking good. So now let's write a test to make sure that the response body is what we expect it to be. So we are going to say test that get author returns author when author exists. And we're going for author 1, which is the test author entity that we are creating here. So Abigail Rose, age of 80, ID 1. So that's what we expect to get. And now rather than checking the status in this test, I'm going to borrow the matches from up here. And we will replace this assertion here. And we're not expecting a list, we're expecting an object, so we can tweak these JSON paths. Otherwise, that's what we expect. And we can actually assert that the value is 1 in this case because we have already saved it in the database. So let's run this and see what we get. Looking good. So this is the find one, the read one endpoint for our authors implemented and tested. Now let's do the book. So let's implement our read one, find one endpoint for our book controller now. So we go over to our books here. We're going to need a get mapping. Path is going to be /books with the ISBN provided in the path. We're going to go public. It's going to return a response entity of our book DTO. And of course, we're going to need our path variable, ISBN, and we'll assign that to a string called ISBN. Okay, so let's implement this. So we're going to call our book service and we're going to say find one, passing in the ISBN, and we're going to expect that to return an optional of book entity, and we'll call this one found book. There we go. Of course, it doesn't exist yet, but that's fine. And just like on the author side, we are going to call findbook.map. And in the case that the book does exist, that we do have a book entity, then we're going to need to call our book mapper, and we're going to map to, passing in our book entity, which is going to return us a book DTO. And then we're going to return a new response entity, passing in our book DTO, and it's going to be HTTP status OK. Or else, in the case that the book doesn't exist, we're going to return a new response entity, and it's going to be HTTP status code not found. And of course, we need to return like so. Great, so that should be all that we need to do on the controller. Let's implement find one in our service layer. Great, so that's looking good in our interface. Let's now go to our implementing class, and we'll need the stub of this method, and then we can call our book repository dot find by ID, passing in our ISBN, and then we can return this just like that. So this should be enough to make our find one, our get book endpoint work. So let's restart our application and then we can test it. Okay, application restarted. Let's go over to Postman. Okay, so this is the results from our list books endpoint that we've already implemented. And we can see here we have one book in our database, Shadow in the Attic, with that ISBN. So I'm going to open up a new tab, and we're going to go /books, passing in that ISBN, and we expect to get HTTP status 200 back with that book JSON. So let's send this. Looking good. And if we were to change the ISBN to one that doesn't exist, HTTP status 404, looking good. So we can now implement our mock MVC test for this because everything seems to be working absolutely fine. We're going to go to our book controller integration tests, and we are going to implement a test that get book returns HTTP status 200 OK when book exists. So borrowing, again, creating that book in our database, and we are going to say /books plus test book entity dot get ISBN, whatever that may be, and we expect it to be OK. Let's run this, expecting it to go green. Looking good, and I'm going to copy this test, and I'm going to say test get book returns HTTP status 404 when book doesn't exist. And I'm simply just not going to create the book in the database, but I might as well just keep the reference to that book there. And yeah, so this is going to go not found. Let's run this test, expecting it to pass. Looking good. So we now implemented our find one, our get book endpoint, and that's been tested as well. Let's move on to the update endpoint for our author. So let's now implement a full update endpoint for our author. So if we go over to the author controller here, we are going to need a put mapping. And the path for this one is going to be /authors and then the ID of the author. We're going to call this one public. And we will have a response entity. And we will return the author DTO because we're going to return the updated author, whatever that may be. And we'll simply call this one full update author. But that's not all. We're going to need the path variable because we need to know which ID we are dealing with. So ID, assigning that to the long of ID. And we are also going to need the request body because we are expecting a author DTO, and we're going to call this one author DTO. So this is the author information that we're going to update in our database. Let's now go ahead and call our author service. In fact, before we do that, let's just make sure that this author does actually exist first. So we're going to say author service dot is exists, passing in the ID of the author. We'll say if exists. In fact, we'll say if it doesn't exist. Then we're going to return a response entity of HTTP status not found. Because of course you can't update an object that doesn't exist. So that's our response entity of HTTP status not found. We're going to have to implement this isExist method. So let's create a method in our author service here. Now go down to our author service, to the stub, and we will implement this. This again is going to be a straightforward pass through. So author repository dot, I think it is exists by ID, passing in the ID as provided, and that's going to return our Boolean for us. So we go back to our controller now. That exists absolutely fine. But what's going on here then? Missing new keyword. Okay, great. So we can now be sure that our author exists in the database. That's good. So let's go ahead and update it. So we're going to say author service dot. Now we get to make a design decision. We can either create a method on our author service called full update author, or we could make the current method that we have, which is create author, a little bit more generic. So we take a look at the implementation for create author. We can see it simply just saves, it just updates the author in the database. So what I'm going to choose to do at this point is rename that to be save. It still makes sense in the context of our create endpoint. However, it now also makes sense in the context of our update endpoint. So we know that our author exists in our database. So let's take the author DTO, making sure that we set the ID on it to be the ID as provided in the path to make sure everything is nice and aligned. And now we'll go ahead and convert that using our author mapper. And we will map to, let's map from. So we now have a author entity, and we'll pass that into our save, which of course is going to give us a saved author entity, which we can then take the author mapper and we can map to, in this case, taking the saved author entity, and then we can return a new response entity with the first argument being our saved author DTO, or updated author DTO in this case, and then the HTTP status of OK. Great. So this should be enough to have a full update endpoint working. So I'm going to go ahead and restart our application and we'll see it working in Postman. Great, that's up and running. Let's go over to Postman. Okay, so we know that we have Aria Montgomery in our database. So here's our retrieve one, our find one, our get author endpoint, and you've got Aria Montgomery in there. So if we were to take this same request and change it to be a put to this endpoint with the ID in there, and go over to the body, go to raw, go to JSON, and then we're going to provide the JSON body. But rather than Aria Montgomery, we're going to say, actually, we've got the name wrong. It's Maria Montgomery. Now, for the sake of argument, I'm going to change the ID in the body to be 99, hoping that that's also overridden. And let's click on send now. Okay, so we have HTTP status 200. The ID is still 1, which is what we specified in our URL. Perfect. However, we do have Maria Montgomery now. So we change that to a get just to, yep, Maria Montgomery in the database. Now, if we were to do a put for a author that doesn't exist, for the sake of argument, and it's just 99, let's make sure we get HTTP status 404 back. 404 not found. Looking good. So let's now write our mock MVC test for these. So we're in our author controller integration tests, and we're going to write a few tests for the status code first of all. So test that full update author returns HTTP status 404 when no author exists. I think that's a reasonable test to start with. So authors 99 put. We are going to need a test author entity. I think, of course, we aren't going to save it in the database at this point, but we are going to need to get the JSON for it. So we're going to say, almost fallen into the same trap. We need an author DTO, not, so we'll go test data util dot create test author DTO A. There we go. Write that value as string author DTO JSON, and we'll pass that using the content method there. Great. So we're doing a put to authors /99. That author doesn't exist in the database. We happen to create the DTO, but certainly haven't saved it using the service. So we now expect the status to be is not found. Let's run this, and it should pass. Looking good. Now let's do the inverse, where we test that full update author returns HTTP status 200 when author exists. So we've got our test author DTO. That's all well and good, but we are going to need our test data util dot create test author entity A. So we've got our entity, and we're going to use our author service to save our author entity in our database there. Looking good. And then we know that the DTO, in fact, before we do that, let's get a reference to our saved author. And we will use the ID of the saved author in our URL there, so it definitely all exists. And we are passing our test author DTO. Let's run this and expect a green test. Got a failed test. Oh, because I haven't updated this, so is okay. Let's run that once more, expecting it to go green. Looking good, that's all green. So we now have those for the status code. Let's make sure that the update actually takes place. So we're going to say at test, public void, test that full update updates existing author. So we're going to need an existing author in the database before we can go any further. So let's do that. So we've got test author entity A, which we know to be Abigail Rose, age of 80. And that's now saved in the database. Now let's get hold of our DTO. So we're going to say test data util dot create test author B. And we'll call this one our author DTO. Now test author B has an ID of 2 in this case, Thomas Cronin, age of 44. We're going to update, we're going to fully replace the information of our author with ID of 1, which we know will be Abigail Rose, with Thomas Cronin's information, doing a full update. So to do that, we are going to borrow this from up here. Need hold of that JSON first. So object mapper dot write value as string, taking the author DTO. Author DTO, and then we'll set the ID though of the saved author dot get ID, because that's what would happen in the real world. naturally you'd want the IDs to match. And then we'll add that exception to our method signature, maybe just making an exception because we know about our mock MVC. And there is our author DTO update JSON, which we're going to put in our method body there. Okay, this is where it gets interesting. So this should update, but we want to assert that whatever is returned is from the Thomas Cronin version of the author. So we're going to borrow expectations there. And the ID is still going to be whatever the saved author.get ID is. That's not likely to change. However, the author DTO, the value that's returned from the updated object should be whatever was in the author DTO, not the original author entity, and it should be the same for the age as well. So let's run this test, expecting it to pass. Okay, we have a failing test. Let's see why that is. Typo on my part. So that's should be get name. Let's try again. Okay, looking good. So that is the full update endpoint implemented for the author. Let's now do the books. So let's implement a full update for our books controller then. So if we take a look here, we have the create endpoint, which if we look is a put request to /books ISBN, which is exactly the same path that we would expect for our full update as well. And the reason being is we made a design decision that we want to specify the ISBN every single time we create a book and not leave it up to the system to generate it for us. How is our full update going to differ? It's going to differ in the response code that's returned. And that's pretty much it. So in the case of a create, it's going to be a HTTP 2.0. So let's implement a full update for our books controller then. So if we take a look here, we have the create endpoint, which if we look is a put request to /books ISBN, which is exactly the same path that we would expect for our full update as well. And the reason being is we made a design decision that we want to specify the ISBN every single time we create a book and not leave it up to the system to generate it for us. How is our full update going to differ? It's going to differ in the response code that's returned. And that's pretty much it. So in the case of a create, it's going to be a HTTP 201. And in the case of an update, it's going to be a HTTP 200. So let's change this in order to be both a create and an update. So we're going to change the name of the method to begin with, create update book. Doesn't do anything functionally, but of course is very descriptive for us. Now then, we need to check if the book exists in the database or not, because if it already exists, then it's an update. And if it doesn't exist, then we're creating a new one. So we need to call the book service, and we'll have a method which is called isExists. And then we'll pass in the ISBN of the book there. Now, of course, this method doesn't yet exist. We'll need to create it. Now, in the case that the book does exist, then we have ourselves an update. And in the case that the book doesn't exist, we have ourselves a create book case. Let's not implement that just yet. Let's see how the different paths would differ. So we've got the map from a DTO to an entity. Well, we're going to need to do that anyway, so let's put that up there. And then we have the creating of a book. That's interesting. So we would need to create a book each time, more or less. Well, would we? Let's take a look at the implementation. Well, we would need to do this logic each time, but we wouldn't necessarily need to create a book each time. We would need to maybe create update book, because we would definitely want to set the ISBN provided onto the object, and then we want to call the Spring Data JPA save. So that would be the same for each. So that's now more descriptive as to actually what it does. And we'd want to do that every single time. So we're going to put that up there. Then mapping from the entity to the DTO. We're going to want to do that each time as well. Okay, and then we have the response entity, which if we take a look here, okay, that's going to be different. So let's put that in there. HTTP status created. Let's make that HTTP status. Okay, but that's not going to be enough. We need to check that the book exists before we then look to create or update it, right? So let's put this up here and we'll say Boolean book exists equals, there we go. So we'll take the book DTO, convert it into an entity. We'll check if the book exists in the database using the ISBN provided as the path variable here. And we'll then look to create or update the book. So we'll do a save based on whatever information is provided, and then we'll map that entity back to a DTO and then respond with either a HTTP status OK in the case that the book already exists, or a HTTP status created in the case that we've created a brand new book, because of course the create update book method is capable of both. So before we can test this, we need to implement isExists. Let's go over there. And then get that stub. Great. And now we'll call return book repository, and we'll say exist by ID. Lovely. ISBN. Great. That's our method implemented. So let's restart the application and go over to Postman to test this functionality. Okay, the application started fine. Let's go over to Postman. So we're in Postman and we can see the panel from when we created our book, The Shadow in the Attic, in the database. And that's all well and good, but let's just make sure everything works still. So we're going to change the ISBN, let's increase that from 1 to 2. And rather the shadow be in the attic, I think the shadow is now in the basement. Let's click on send, and we're expecting a HTTP 211 created. Great, 201 created, the shadow in the basement, but oh wait, the shadow wasn't in the basement at all. It was actually in the ballroom. So we're going to keep the ISBN exactly the same up here, and we expect it to say the same, but we expect the title to be different. So if we click on send, there we go. The shadow is now in the ballroom with a HTTP 200. It looks like our update and our create working absolutely fine. Let's now write our tests. So we happen to know our test data util is set up so that the DTOs are the same as the entities. So we're going to go test data util dot create test book entity A, and then we won't pass in an author. We will assign this to a variable, which is test book, well, entity A. That will do. And then we will now save this into the database. We'll say book service dot save. No, it's create update book now, and we'll pass in the ISBN. Test book entity A, get ISBN, and then test book entity A. Great, and we'll assign this to a variable which is called saved book entity. Let's just put that on a new line. Great, so we now have this saved book in the database. So we want to make sure that definitely 100% that our DTO matches up. So I'm just going to do test book A dot set ISBN, making sure that it is the saved book entity dot get ISBN. It should be by convention, but just for documentation in the test and for it to be obvious. And then we are able to convert that into JSON and then do the update here. So it's not created anymore. It is simply is okay. So if we run this test, we should expect it to pass. Okay, looking good. So that's it for the status. We now need to make sure that the object that's returned in the response body is what we expect it to be. So again, we're going to borrow this test, and we're going to say test that update book returns updated book. So like before, we're going to have to create a book in the database before we even start. So let's borrow that in its entirety, replace that there. Great, so we now have a book in the database, it's been saved, and now we're looking to do an update, and we're making sure that what's returned is the updated book. So we know that both our entities and our DTOs from test data util should match up. So let's say test book A dot set title of simply updated. There we go, and if we take a look here, the shadow in the attic, let's see that fail, because we should see that the title updated is returned if this is working correctly. So let's click on play. Okay, it's failing, and the reason it's failing is expected the shadow in the attic but was updated. So that's a correct failure. However, I was taking a look here and it looks like we're using the string ISBN rather than the variable. So actually that's a bit of a gotcha as well. So let's make sure it is definitely using the ISBN as we've got here. There we go. And in fact, I'm going to do the same for up here as well on our update. Great. Okay, we'll change this to be what we expect it to be, which is updated. And we should expect this to pass. Looking good. Now we've changed a few things on here, so I am going to take the liberty of running Maven on the command line to make sure that everything is still working absolutely fine. So we'll do Maven clean verify. Looking good. So that is the full update implemented for books. Let's now move on to the partial update for our author. So that's the full updates done. Let's now move on to the partial updates. So the partial updates, if you remember, we don't have to provide the full object in the request body. We just have to provide whatever attributes that we're looking to update. So in the case of the author, if we only wish to update the name, then we only provide the name in the JSON object. So let's now implement this. So in terms of what we're going to need, we use the HTTP method patch for this. The path is going to be identical to the full update. And then we have public response entity wrapping a author DTO. And we'll call this one partial update. So we're going to need to have the path variable in use. We want access to whatever is passed in the URL here. And we'll assign that to a long of ID. That'll be the ID of whatever author we are to update. And we'll also need access to whatever is in the request body as well, which of course we know to be an author DTO, or at least whatever fields of an author DTO we care about. So that is the signature dealt with. What do we need to do in order to implement this? Well, I think just like the full update, we should check to see if the object actually exists in the database first, and if not, return a HTTP 404. That's what we'll do just like above. So in terms of this one, we will want to first map from a DTO to an entity. So let's do that. We'll call the author service. We'll say the author service dot, and we'll say partial update. I can see we've done it up here. We've set the ID on the object in the controller in the presentation layer. I don't know, I feel like that's probably better done at the service layer. So let's choose to do it for the partial update, maybe changing it for the full update. So we're going to pass in the ID of the author to update, and we're also going to pass in whatever the author DTO provided is in order to update it with those values. And that is going to return for us an author entity, and we'll call that one updated author. Of course, it's not going to be an author DTO we pass in, it's going to be the author entity we've converted. So we've got our updated author entity, so we now need to map that back. So we're going to go author mapper dot, and then we'll say map to, passing in the updated author. Okay, and then we'll return a new response entity, passing in our author DTO, and then it's going to be HTTP status OK if everything has gone correctly. Great, so this should be enough to do our partial update, but the real complicated logic is going to be inside of the partial update method here. So let's go inside of our interface and create that. Looking good. Now let's go into our implementing class, get that stub. Great. So the first thing I'm going to do is I'm going to take the author entity and I'm going to set the ID on it, provided. That's what we were doing in the controller before, but actually is kind of business logic, I suppose, in a way I'd prefer it to be in here. So here's where things get a little bit complicated. In order to update what we have in the database, we first need to retrieve what we have in the database and then update the attributes as provided. So the first thing we're going to do is we're going to use the author repository and we're going to say find by ID. Now we happen to know this should already exist. We checked for it in order to return a HTTP 404. So what we'll do is go map, and this will be what we'll call our existing author. So we have our existing author. How are we going to update the fields? Well, the way that I like to do it for pretty simple objects like this is by going optional of nullable. And then we can go author entity.get, and then whatever we'd like to update, which in this case, because we're not going to do the ID, but we are going to do the age and the name with this method. So we're going to get the age. So if the age exists, so if present, then we want to call the existing author and we'll say set age. So what this is doing is saying if we find that the author entity as provided has an age and it's not null, then we want to set that on the existing author as we found it from the database. And we're going to do exactly the same for the name as well. So optional of nullable, and we'll say author entity.get name, and we'll say if present, we're going to go existing author get name. Sorry, set name. There we go. And now we want to save the existing author again, just to make sure that anything that we've set on it is going to be updated in our database. So we're going to say author repository.save, and then of course pass in our existing author, which is going to be what we return at the end here. And then we will return this. And in the case that the author doesn't exist in the database, which we happen to know is very unlikely at this point, but may be the case, we're going to say or else throw. And just for the moment, I'm going to throw a new runtime exception. And we're going to say author does not exist. Okay, so this should be enough for our partial update method. Let's try it out in Postman. We can see that we have Maria Montgomery as renamed using our full update. But we were mistaken. It wasn't Maria at all. It was always Aria. So we're going to attempt to update this by using patch now. So we'll flip this over from get to patch. And then rather than Maria, we're going to provide Aria. But that's all we're going to provide, not even the ID in there. Just the name. So we should expect what's returned here to be the full object, but with the new name of Aria Montgomery and a HTTP status 200. Let's try this out. Looking good. It's Aria Montgomery. And actually, Maria was Aria's middle name. So we're going to do that. And of course, she's not yet 80. She is, in fact, only 79. So we're going to change that as well. So let's send this, expecting those two fields to be updated. Looking good. So yeah, it looks like our partial update is now been implemented. Let's write our test for this. So here we are in our author controller integration test. So we're going to test for the status code, and we're also going to test that the attributes can be updated. So let's start with the status code. But before we do so, I'm just going to borrow from this test up here because it's going to be fairly similar indeed. So let's create a new test, and we're going to call this one public void test that partial update existing author returns HTTP status 200 OK. Great. So what we have here then is we are creating our test author entity and we're saving it in the database. We have an existing author. Now, of course, we happen to know that our entities match up to our DTOs here, at least when we're using our test data util. So in fact, let's just throws exception. So the DTO matches the entity and we've got our DTO as JSON. So we're now performing, but not a put, but a patch to /authors and then the ID of the author as saved. For the sake of argument, we are also going to change the test author DTO A. Let's set the name to be updated, let's say. It's not going to make a huge difference in this test, but it'll be closer to the real life example. So we're expecting it to be status OK. So let's run this. Looking good, so we get HTTP 200, which is what we saw inside of Postman. Now we're going to do the test to make sure that the body is updated. So test that partial update, existing author returns updated author. So this is going to be very similar. So we're already setting the name of the author in the DTO to be updated, which is how it's going to differ from the one already saved in the database. We want to make sure that it is updated in our JSON bodies. So we are going to borrow from up here once more. Replace this. The ID is going to be the same. The name is going to be updated. And the value is going to be exactly the same age. So we're going to say here, test author DTO, A gauge. So if we run this, we should expect this to pass. Great, and just like that, we have implemented our partial update for our author. Let's now do our book. So let's now implement a partial update for our books. So we're in our book controller here. We're looking at the full update, the create and update. We've got list, we've got get book. So let's now create a new endpoint. This also using the patch mapping. And the path is going to be exactly the same as the full update or the create in case of the book. We're then going to say public, returning a response entity of the book DTO. And we're going to call this one partial update book. Let's get that path variable, which of course is going to be ISBN. And we'll assign that to a string called ISBN. And then we're going to need that request body, which of course is going to be a book DTO. And we'll just call that book DTO. So that's our signature. Now let's look to implement this. So as before, we need to take that book DTO and turn it into a book entity to work with our service layer and our persistence layer. So we've done that conversion just like that. Now we want to check if that book exists. Yes, just like above, because if it doesn't exist, then we need to return a HTTP status 404 because, hey, the book wasn't found. You can't update a book that doesn't exist. We'll say if the book does not exist, which we could probably inline. Then we want to return a response entity, HTTP status not found. Okay, but what if our book does exist? Well, in that case, we want to do the partial update. So we're going to say book service dot, and we're going to say partial update, passing in the ISBN of the book, and of course, our book entity, which will move the line down to here. Okay, so this is going to return us a book entity, which we'll call updated book entity. And then we need to map to, so we'll say book mapper dot map to, passing in an updated book entity. And then we can return a new response entity containing our saved book DTO and then the HTTP status of OK, because the update went OK. So this should be what we need to do in our controller. Let's take a look at implementing this partial update method, shall we? So let's create the method in our book service. Looking good to me. Let's now go to our implementing class. And there's our method stub. So as before, the first thing I'm going to do is say bookentity.setISBN, making sure it's the one provided as this argument here, which comes from the URL. And now we want to do our partial update, which of course means we need to get our book from the database. So book repository, and then we'll say find by ID, passing in the ISBN, and we'll do a map, and we'll call this one existing book. Great. So we'll now do how we did before, optional of nullable, checking the book entity provided for, in this case, I think we'll support updating the title, which we can do like so, and then we'll say if present, we'll say existing book set title. We don't want to be able to update the ISBN, and we don't really want to be dealing with the nested author in this case. Of course, it's completely an option for you, but I think we'll just make our tutorial a little bit more complicated. So we'll just update the title in this case. And if the book doesn't exist, so we'll say or else throw, which needs a function. We'll say new runtime exception, and we'll say book does not exist. But the chances of coming up against that are slim to none because we're checking inside of our controller, at least how we're using the application now. So let's return this, and let's make sure that our book entity or our updated existing book is saved, which we can do by saying book repository dot save, passing in our existing book with all of its updates, and then we will say return. Great, everything looks like it's compiling. This is what we need for our partial update. So let's go ahead, restart our application and test this out. Okay, the application started up. Let's go over to Postman. Okay, so here we are in Postman, and we can see we've got a book existing in the database, the shadow in the attic with this ISBN right here. And let's now try this for a partial update. So we'll go from get to patch, go to the body, and then we'll provide JSON in the body, but we're only going to provide the title, just like that. And it's not the shadow in the attic, of course it's the shadow in the basement. So if we send this, we should find that everything stayed the same except for the title, which is now going to change to the shadow in the basement with a HTTP status 200. Looking good. That partial update seems to be good for the book. Obviously we can update this as the book object grows out with additional attributes, additional instance variables. So that's all good. Let's now write our test for this. Okay, so here we are in our books controller integration tests. I'm going to borrow this because we're going to be using something similar in our mock MVC. And now let's write a test, and we'll say test public void test that partial update book returns HTTP status 200 OK. Okay, and we'll say throws exception. Great. Of course, we do need an existing book for this, so let's get the necessary bits we need to make a book exist in the database. There we go, which is test book entity A. So we're going to need to send some JSON in our request body for this one. So let's see if we can borrow something from up here to make that easy for us. This should do. There we go. So we can see that our testbook DTOA, of course, matches our testbook entity A. That's how we've set it up. And we have here, we don't set in the ISBN on the saved book entity. And then we're setting the title to be updated in this case. In fact, let's not do that. Let's just make sure it's just the title that's being updated here. Change it to book JSON. Now we're going to make use of the patched HTTP method to books plus the ISBN of the saved book entity. Great. And then the content, of course, is going to be the book JSON with the title being updated. We're expecting is okay. Do we get is okay? We do. Excellent. So that seems to be working absolutely fine. Now let's look to, yes, let's assert on the response body now. So we'll take this test because this next one's going to be very similar. Test that partial update book returns updated book. So creating a book, and then we're updating the book DTO, which is then going to be different from the book in the database. And then we are creating some JSON from that DTO, and then we're patching it to the right ISBN. Everything is good. The only thing that's going to be different is going to be our assertions. So let's go down, well, go up here, borrow these. We're not using a list, we just have an object. So the ISBN is going to be exactly the same ISBN as our test book entity dot get ISBN. However, the value is going to be updated because we're updating it right here. So if that's returned, then our test should pass. Let's try again. Looking good. So that is the partial update implemented for our book. Now we get to move on to the delete endpoint. So let's implement our delete endpoint for our author. So here we are with the last letter in the CRUD acronym. We've done our create, we've done our read one, our read many, we've done our update partial and our update full. We now have the plain and simple delete. So let's implement our delete for our author here. So we're in our author's controller. We are going to need to use the delete mapping. The path, that's going to be absolutely the same as the path that we've used so far with the ID provided in there like that. Now we're going to say public response entity, but we're not really going to be returning much in there, but it's because there's going to be no body. We can just provide the response entity like that. Now we're going to call this one delete author, and we're going to need to get hold of that path variable ID because we need to know which author we need to delete. And now we can get to deleting our author. So we're going to go author service dot, and we'll say, well, we don't have one yet, but we're going to say delete. And we're going to pass in the ID of our author, which is a void method. It's not going to return anything. So we're going to then return a new response entity. And in that response entity, it's just going to have an HTTP status of no content. 204? 204, no content. Wonderful. So let's implement our delete method on our author service. So we'll go create method delete, void delete, long ID, looking good. We need to go to our implementing class. Very nice. And now we'll need to delete, which of course is very easy with Spring Data JPA. We can go delete by ID, passing in the ID as provided. And we've deleted our object. We've deleted our author. Very nice. So that is all we need to do to implement our delete method on our author controller. Let's test it out. So let's restart our application. Okay, that's restarted absolutely fine. Let's go ahead and open Postman. So here we have Aria Maria Montgomery in our database, one of our saved authors. We do that on our get one endpoint. We can see that she is returned. HTTP status 200, everything looks fine. So let's now delete this author. So we'll go up here, we'll click on delete. Path stays exactly the same. Any body that we send is going to be ignored, but let's send this. There's our HTTP status 204, no content. Everything seems fine, but to really test this, we need to do a get again. If we get our author back, then the delete didn't go through, the delete failed. However, if we don't get anything back, we get HTTP status 404, then our delete worked. Let's try this out. HTTP status 404, our delete endpoint works absolutely fine. Let's write a test for it now. Okay, so we're in our author controller integration test at test. We'll say public void test that delete author returns HTTP status 204 when, that'll be enough, HTTP status 204. So for this then, we will need to, let's borrow this from up here. We need to do a delete / authors and then the ID of an author, which can be an existing author or an author that doesn't exist. So we're going to say test that delete author return for non-existing author. And we'll simply just make up an ID because we said that actually a delete is still successful if there's nothing to delete because at the end nothing exists. So that's a successful delete. We'll test it out, or at least we'll test it. So the content, there's no content provided here, but we are going to expect that the status is no content. And we'll just add exception to our method signature. So let's run this. Pass is absolutely fine. Now let's do the same, but with a author that already exists. When existing author. So for this, we'll actually need an author in our database. So we can do that like so. So we have test author entity A now in our database. So I'm going to say saved author, and I'm going to say saved author.getID, making sure that it's going to try and delete the existing author. So we'll click on play. Looking good. So our delete seems to be working absolutely fine. Let's now move on to implementing our deletes for our book. So we're now going to implement our delete endpoint for our book, and this might be the quickest run we'll do. So let's try it out. We're going to go delete mapping. The path is going to be exactly the same as the one that we've seen with the ISBN provided. And we're going to now go public response entity. We're not going to specify any generics for this because nothing's going to be returned. It's no content. And we're going to call the method delete book. Now, of course, we'll need a path variable. We'll need to know which book we're deleting. We can do that by assigning it to the argument ISBN here. And now we need to delete our book, which we're going to do by calling the book service dot delete, passing in the ISBN. That, of course, is going to be a void. So we need to return a new response entity. And that response entity is going to be HTTP status, and we'll say no content, just like before. So let's now create delete on our interface. Then go to our implementing class, and we'll want to create it there too. Great. Again, it's going to be a pass-through book repository, delete by ID, passing in the ISBN, and we're implemented. So let's try this out in Postman. Let's restart our application. Okay, that's restarted. Let's open up Postman. Okay, so here we have our shadow in the basement book with this ISBN. So if I do a get, we get HTTP status 200. If I do a delete, we get 204 no content. And if I try and do a get once more, 404 not found. So it looks like our delete is working fine for our book. Let's write our test for this one. So here we are in our book controller integration tests, and we're going to say at test public void test that delete non-existing book returns HTTP status 204 no content. And we all borrow this from up here. We're going to provide an ID of a book that doesn't exist. And we're not going to provide any content, but we are going to say and expect result mock MVC result matches dot status to be no content. And of course, we need to add exception to the method signature and then click on play here. Okay, we've got a failure. I wonder why that is. Let's take a look. Expected a 204, but was a 400 because we're using patch and not delete. Let's try once more. Great, that's working fine. So let's copy this. And we're going to say test delete existing book, returns HTTP status 204, no content. Of course, we're going to need to create a book in our database, which we can do by borrowing this up here. And then we'll say testbook entity, and then rather than this made up ISBN, we're going to say testbook entity.get ISBN. Still expecting a HTTP status 204. Let's run this. Looking very good. So that is us implementing a very basic CRUD for both our books and our authors. Now let's just run Maven on the entire project to make sure everything's working fine. Got a build success. So there we go. So we've got a couple of additional things that we want to clean up. One of them being our nested objects and the other one being pagination. So we're going to move on to those right now. So far we've shied away from manipulating nested objects when we are dealing with our CRUD endpoints here. So what I mean by that is we haven't tried creating a book and then also creating an author. We haven't tried updating a book and then also updating the author that goes along with it. And the reason for that is pretty simple. We haven't configured our model mappers correctly yet. Or at least we haven't configured it to support this. So out of the box, Spring Data JPA allows you to update nested objects. We've already seen that inside of our Spring Data JPA part of the tutorial here. If we were to, for example, restart our application, now I have taken the liberty of clearing down the database to make this super obvious, we'll see that actually this is a mapping configuration problem and not necessarily a Spring Data JPA problem. So application's restarted. Let's go over to Postman. So we have here an endpoint which is going to list all of the books in the database. If we hit this, we get a 200, but we get an empty list. There's nothing in there. If we do the same for the authors, we get a 200, but we get an empty list because there's nothing in there. So if I wanted to create a book and then also create an author, something we've done quite a lot when we were dealing with our persistence layer with Spring Data JPA, which of course our presentation and service layer uses, it should be easy, right? It should be obvious how we do that. Well, it should be. So we're going to create a book, which we know we're going to do with put, and then we're going to go /books. We need to provide an ISBN. We know there's nothing in the database, so any ISBN will do at this point. And then we're going to, oh, there's already an object for us. That's handy. Let's make sure that the ISBN matches. It will be updated anyway. The shadow in the attic, looking good. And now for our author, as our nested object, we know that our author, we don't really need to provide an ID for it, so I'm not going to. And our author has a name. Well, we've gone with Aria so far, so let's say Fred. Fred the author. So it has a name and the age is going to be, let's say 14. Fred started at 14. Well, Fred has published a book at 14. Good going, Fred. What we're expecting to do when you put here is we want the book to be created, but we also want the author to be created and then an ID generated for it, then our author to be referenced by our book. Now, remembering earlier in the tutorial when we set up our database manually, we set some constraints in there. Those constraints don't exist by using Hibernate Auto DDL to generate our schema for us, so we can potentially have a book without an author. The author could be null. Of course, that's not what we want in this case. Let's send this and see what we get. The author's null, because you've seen this quite a lot based on us implementing our CRUD endpoint. There are no authors. So if we open up a new tab here, go HTTP localhost /books, there's our book with our author of null. But if we then try and do the same for our authors, there's no authors. So how do we set it up to do that? Well, it's all to do with our model mapper. So we know DDOs are a good idea, but the model mapping and the mapping from to and fro is extra overhead. We know that, but it does pay off depending on the size of the project. So I'd rather show you the full-blown approach in this tutorial. So the model mapper here is mapping from an author entity to an author DTO, looking good. And then the same for the book. So it's going from the book entity to the book DTO and back again. But we know that the book DTO and the book entity, they reference the author entity and the author DTO. So why isn't it handling the nested object conversion? Well, it's because we haven't told it to. So if we go up to the mapper config up here, we're simply just returning a new model mapper. But what happens if we were to, I don't know, let's assign that to a variable, and then we can configure this. Now, the particular incantation that we need for the model mapper is this. So we're going to use the matching strategies loose, and that's going to match supposedly nested objects and allow us to convert from one to the other. So what this will mean is when we send a nested object within the DTO, it will then be converted to a nested entity object, and that is all Spring Data JPA needs in order to then cascade, do those saves, do those updates, really harness the power of those nested objects in Spring Data JPA. So with this being done, let's now restart our application. Back to Postman and then try this again. So we've already created the shadow in the attic. So let's get a new ISBN and let's put that up here. Shadow in the attic is now the shadow in the basement. Still Fred the author, needs to publish his second book at the age of 14. Good going, Fred. So we now expect with this change in configuration for Fred to be created as an author in the database. Let's give this a go. Okay, we've got a 201 created, and we can see here ISBN, shadow in the basement, and now an author's been created with the ID of 1 generated for us, Fred the author, age of 14. So we've now enabled the ability for the DTOs to be mapped to entities with nested objects, which then means that we can harness Spring Data JPA to do all of those cascades to our nested objects. So if we just double check that, if we go to authors here, click there's Fred the author, go over to books here, there's our two books, our original one with a null author, and then this one here, our new one with Fred the author as our reference author. So we mentioned before our list endpoints return all of the entities. So in the case of the list books endpoint, it returns every single book in the database. If that's no books, if that's one book, or if that's 10 billion books. And obviously the more books that it needs to return, the more resources that requires. And that can mean things like crashed databases, crashed app servers, or just wait times, which means that users get really bored and then go and do something else. So where we can, we want to set limits to the number of entities that are returned on those list endpoints. And one of the easiest ways that I know to deal with this is by making use of pagination. And pagination is built into Spring Data JPA and Spring Web. It's one of those things that goes all the way up the chain. It's really simple to use. Let me show you how to use them. So we're going to start over our repository, and we're going to do this in the book repository. Now, remember I said before, depending on what repository you extend, it depends on which functionality you get access to. Now, in the case of the CRUD repository, we get access to CRUD, create, read, update, and delete. Now, we're going to also extend, putting that on a new line, the paging and sorting repository, dealing with our book entity and also our strings here. And just like that, we have access to some additional methods. So we take a look in here, we can see we have access to find all, and this takes a sort. We also have find all that takes a pageable and returns a page. This is the one that we care about. So let me show you how this is used. If we go to the book service, so we have our find all method already, we're going to overload this with a different return type. So rather than a list of book entities, we're going to say a page of book entities. We need to import page, and we'll do that. And then we'll say find all, and we're going to pass in here a pageable. There we go. And this pageable object contains information. So it's things like the sort, the offset, all that good stuff. And the page is like a list, and then there's some additional metadata around that. But we need the pageable in order to inform what is in the page. So that's inside of our service. Now let's implement our method. We'll do that next to the old one. And we'll simply call book repository dot find all, passing in our pageable, and we'll just return this. It'll be a pass through. Got our find all. Let's go up to our books controller, and we'll go to our list books endpoint. So list books returns a list currently. We're going to turn that to a page of books. And now we need access to our pageable. It's pretty great because if we put pageable in here, Spring is going to inject that for us. So we have access to our pageable. Thank you, Spring. And we're going to put that inside of find all. It's of course not going to return a list anymore. This is going to return a page. And now we have to deal with our page. So we have a page of book entities at the moment. We want a page of book DTOs. So we're going to map this and then to our book entity. In fact, we'll just go book mapper and we'll say map to, it's map to, it's that way around. And then we'll return this just like that. So in fact, it's a lot simpler. So we're doing that find all and we're returning that page, in this case, of book DTO. So let's restart our application. I'll show you how this differs. Okay, let's go to Postman. Okay, so let's see what books we have in our database. So this is the old list books endpoint. So you can see here, it's just a JSON array with JSON objects in there. And then we've got a couple of books, one with an author, one without. So if we click on send now, we can see the structure is a little bit different. We have this content node or this content attribute, and it contains those two books. But we also have, minimize that, this pageable information. We have total pages, the number of elements, the size, which in this case is 20. And this is all of our page metadata. Now we only have 2 books in the database at the moment, so I'm going to take the liberty of just creating a few more. Okay, so there is a few more now in the database. So if we go down here, we can see that we've got total elements of 2 at the moment. If I hit send again, scroll down to the bottom, we've got a total elements this time of 40. So we have 40 in here. Or do we? There's certainly a lot more of them with some pretty poor data in there, but there is many, and that's really what we want. So we've got many of these. So we've got 40 altogether, and we've got 20 being returned. And we now have access to a couple of query parameters, which allows us to control this even further. So if we were to say size equals 2, and we take a look at our content here, 1 book, 2 book, and then our pageable metadata. That's it. We say page equals 1. We only get 1 book per page. So this is the book on page 1. And if we say page 2, we get a different book. Page 3, we get, well, different ISBN, same book with terrible data. Ultimately, this allows us to control the size of the page and then which page we're currently viewing, which allows us to limit the amount of elements that's being returned by our API. And you can tweak these variables to return whatever you like, really. 0 index for page. You can see here, we've asked for 100 elements. We've only got 40, so we get all of them returned. And if we ask for page 2, it's going to be empty because, well, we're on page 2, or we're going to go from 100 up to 200, and they don't exist, so we don't get them back. And this is a much more efficient way of dealing with large quantities of data on our list endpoint. And there are some other nice built-in extra features to this as well. And one of those is sorting, which is sort of out the scope of this, but just know that there's some additional query parameters which allow you to sort the items that are returned. And just like that, we have pagination. So if you stuck with me so far, thank you so much and congratulations. We've implemented a CRUD API, and we've even talked about some additional features like the model mapping with nested objects, and we've even talked about pagination as well to take your API to the next level. So we have an API, we've built it, it's great, and it's running locally, but how do we deploy it? Well, let me show you one way of deploying it to AWS. So we've built our REST API, let's deploy it to AWS so we can hit it and show other people our REST API. Now there are a number of different ways of doing this. I'm going to choose to package up my application in a Docker container, and we're going to be using AWS LightSail today in order to host the Docker container and make it available for us to hit. So first things first, we need to package our application up in a Docker container, and we need to go to our application here, create a new file, and we're going to have a Docker file here. So we are now going to create ourselves a Docker file to be able to package our application up in Docker. So here we have perhaps the simplest Docker file that I can think of for a Spring Boot application. Now this isn't a Docker tutorial, so not going to go into the myriads of different ways that you can optimize your application. And believe me, there are a lot of ways inside of your Docker file. But let me just talk you through what this does. So we're building on top of the OpenJDK version 17. We know about version 17 because that's what we've been selecting so far in our Spring Spring initializer, so we want Java 17. The maintainer, which in this case is devtiro.com. And then we're going to copy inside of our target directory our jar file into app.jar. Bear in mind, we'll need to have a jar file available before we run Docker build. And our entry point is going to be Java jar and then app.jar. Again, there are loads of different ways of doing this. However, this is probably the simplest and it should work. So what we're going to do now is we're going to open up a terminal and we are going to say Maven clean and package. And this is going to create us a jar file. Okay, so if you now look in our target directory, yep, we have, it's called database. We should probably update that by now. We have our database snapshot jar file. So this is what we're going to need for our jar file. It exists, it's in our target directory. The name of it doesn't matter too much for the time being. Okay, so now what we're going to do is we're going to go back to our root directory of our project, where our Docker file is located. And now we're going to go Docker build in the current directory, pointing to the Docker file, T, and then our tag is going to be devtiro/books. Okay, now if we do Docker image ls, we can see that we have devtiro books, the latest version, and it was built 5 seconds ago. So we have our Docker container built. That's great. Let's now get this into LightSail so we can run it. Now remember, we are needing a database to run our application, so we're going to need to configure that as well, but let's do that. So let's flip over to LightSail. So I've logged into my AWS account and here we are in LightSail. So we're now going to go to containers here and we're going to create a container service. So for the sake of this, we are going to choose a nano is absolutely fine. We're only going to need one of them. Of course, when you're using this, bear in mind, there may be a cost associated with it. It should be very, very clear. And now we need to identify our service. So we're going to call this one devtiro books. Okay, we'll set up a deployment after it's started. Let's create our container service. Okay, so we're at the getting started here. We have our Docker container on our local machine. So we have already installed Docker, that's all good. We already have the AWS CLI installed, or at least I do. Make sure that you follow these instructions otherwise. And now we need to push our container images to LightSail. And this is the incantation for it here. AWS LightSail, the region that you're running in, and the service name, the label, and the image. So I'm going to take this and we can start filling these in. So we're going to push the container image. The region that we're going to push to is the region that we're running in. Region at the moment is EU West 2. So we're going to say EU West 2. The service name, which we know is devtiro books. And then the label, which we'll also say is devtiro books. And then the image, which is our local container image, and then the tag. So we know that to be devtiro books and then latest. Okay, so that is now pushed. There we go, and we can see it in images right there, so that's looking good. So we now need to create a deployment. Before we do that, let's create ourselves a database. We'll have a Postgres database. We'll have a standard database, and we'll call this one devtiro books. And then we'll create our database, devtiro books DB. Okay, so that is in the process of being created. Okay, so our database is now up and running. So we need to take a look at some details because we're going to need these a little bit later. So let's go to our IDE. Let's open up a new file. And we'll take note of the endpoint and put that in here. We're going to need the username. And we're going to need the password. This password and this instance will be long gone by the time that you see this, so don't try connecting to this. So keep that password there. So that's our endpoint. That matches up fine. Port 5432. Public mode is disabled, so only LightSail resources in the same region can connect to this instance. All looking good to me. So that's good. Let's go over to our containers. And we'll go into container DevTiro books. We need to create our first deployment. We'll call the container name DevTiro books. Why not? We'll choose the stored image that we've got in there. Launch command we'll leave as the default inside of the Docker container. And we'll add now some open ports, which are going to be the default port of 8080, which we know from Postman is the port that the application runs on. And now for the environment variables. So we mentioned before that we can inject configuration into our application by using environment variables. And that's exactly what we're going to do. So we're going to go back to our IDE. We need to know the endpoint. We need to know the username, and we need to know the password. So let's go to our source, main, resources, application properties, and we can see how these match up right here. So let's start with the URL. So the key for this is going to be spring underscore data source underscore URL. And it's in this format here. So we go back to our Scratch and then update this to include, and we're just going to connect to the Postgres database to begin with. So this should be the correct value for us now. Let's add another one. So we now need to specify the username that we're going to be using. So like an application properties, it's spring data source username. In fact, let's do it here. It's easier to see. So we'll uppercase this, change the dots for underscores, place that in there, and then we'll place the value in there. That was easier. And then we'll do the same for the password, which we know is spring data source password. We'll uppercase that, underscore, underscore, and then let's place that password in there like that. Arguably, you might want to use some kind of secret service. We're just going to put it in there for the time being. And then 8080, looks like DevTiro books on the public endpoint. Looking good to me. We'll say /books. And now we'll save and deploy. So after quite a while, the application failed to start up, and the reason is the health checks didn't pass. So if we go to show details here, the health check simply needs to return a success status code in order to show that the application is up and running. If we look at the logs here, we can see that we expand this. Deployment took too long, and we scroll up. Health checks failed, port 8080 is unhealthy, and it's simply just not starting up fast enough. And it may well be because there's not enough memory, and it may be because of the settings. Now, I can tweak the settings. That may take a bit of time. However, I am going to choose to attempt to update the amount of memory used. So, I'm going to go to a micro instead. Okay, and the status looks ready. So I'm going to modify and redeploy this, leaving everything as it was before. /books lists our books, but always returns a HTTP 200, remember, so this should be okay. So let's save and redeploy. We have a running application, so I had to make a few tweaks to the settings. So if we go inside of the deployment here, show you some details. In addition to increasing the size of the instance, which then gives us some more memory to play with, things then tend to run a bit faster. I've made some tweaks here. So we're still using the /books, a health check endpoint, because that will always return a HTTP 200. I've changed the check timeout seconds to 12, so it has up to 12 seconds to respond to that call. And the health check interval seconds is now 120 seconds in between. These are very lax, okay? So these are quite forgiving in terms of settings. So between 120 seconds between each check, and yeah, we've got up to five checks before it's unhealthy. And I've done this because of the size of the instance that we're using, it's taking a bit of time for the application to start up, and that's what it needed. But yes, if we go to open logs, we can see here's the logs of our application, and eventually application starts up. and it connects to our Postgres instance, which we've got there, running on port 8080. Everything looks good. So now our application's up and running in AWS. Let's try hitting it in Postman. So I'm going to take the public domain up here. So let's attempt to create a book and an author on our application running in AWS. Now, a little quirk I've noticed of this is we need to change it to HTTPS. And it will go do a put to the /books endpoint with this ISBN. And we're going to provide the title, The Shadow in the Basement, and our author is going to be Fred the author, age 14, and of course no ID is going to be provided. So we're expecting to get a HTTP 201 created. Let's send this now. Okay, we've got HTTP 201 created. So if we go to our authors, change that to HTTPS, and we'll go /authors. We've got Aria Montgomery that I created as a test a moment ago, and then we have Fred the author right here. Now, if we go to /books, we can see that Shadow in the Basement exists. So our application is up and running as we built it locally, but now it's running inside of AWS inside of a Docker container.
Congratulations, that brings our course to a close. Now, if you feel you've taken some value from today's course, be sure to like and subscribe because that will allow us to make more courses just like this. Now, if you do want to see another course on Lombok, which is a library we've used throughout this course, then be sure to check it out over here. It will talk you through all of the annotations, how to use them, and allow you to become a much more efficient Java developer. I'll see you over there.